Now, you built your app, you implemented all the features you have, and you thoroughly tested and optimized it. Now, obviously, you now want to get it into the app stores, into the Apple App Store and the Google Play Store. In this module, we'll dive into how you may deploy your app, both if you're using the managed workflow Expo provides, or if you're having a raw app created with the React Native CLI or with the bare workflow Expo offers. I'll have a look at both, and you will learn how to configure and prepare your app and how to then also build it and get it into the app stores. Now here's a big picture of the steps you typically go through when you deploy your app. The first step is one you might already have finished. That is that you should, of course, thoroughly test and polish your app and your code. Make sure that it works, test it on different devices, on real devices if possible, test it on different device sizes, different operating system versions. So all of that's something you should go through and make sure your app really works on all these devices and feels and looks the way it should look and feel. So that's really important. Now, I assume that we did all of that for this module here. So the next step is that we configure the app and the deployment. That means that we set a name for the app, an identifier which identifies it in the app stores. Every app needs a unique identifier, and so on. In the Expo managed workflow, this also means that we can configure some additional nice features which I'll dive into. Now, you obviously also want to add your own icons and a nice splash screen, so a loading screen before the app opens up to your app. Last but not least, it's time to then build and deploy the app. Now, these are actually two steps because building the app means that you now bundle up your app into a deployable app bundle. And deploying then really means that you set up the store page in the Apple App Store or the Google Play Store, and that you then get your file into that store. That's the last step. And then, of course, it's all about tweaking that store page, uploading some nice images there, setting description texts, and so on. So these are the steps you typically go through. And in this module, we'll have a look at the deployment-related steps, at the configuration steps, and I will show you how you can get your app onto the devices of other users. Of course, there also is kind of a difference if we talk about Expo apps and non-Expo apps, if you want to call it like this. With Expo apps, I mean apps that use the managed workflow, which we used throughout this course, and non-Expo means bare apps, so we're using the bare workflow offered by Expo or not using Expo at all, created with the React Native CLI. In the managed approach, you have the app.json file, which you can use to configure your application. Assets like icons and splash screen are automatically created for you. You just provide some input assets there, and then all the creation and optimization is handled for you. You have a command which you can run to publish your app, and then commands to build for the different platform, for the different operating systems, and that build will happen on cloud servers provided by the Expo team. So you can even build for iOS if you're running on a Windows or a Linux machine, something you cannot do if you have to build manually on your own. Then you can only build iOS apps on a Mac. And you even get a nice feature, a nice extra feature, which is called over-the-air updates, which allows you to push basic updates, code changes, and so on to apps which are running on other devices over the air, so over the internet, over Expo's servers, without the need for those users to update your app physically, so they don't have to install a new version from the App Store. Instead, you can push such code changes behind the scenes. You can live update these apps whilst they're running on other machines or on other devices, which is pretty sweet. Now, in non-Expo apps, you have to configure everything manually. You have to set up the name, identifier, and so on manually in different files. You have to provide all the icons manually, create them manually. So a lot of manual stuff involved there. And you also have to orchestrate the entire build manually. So you have to build the app via Android Studio and Xcode. And that's, of course, a lot of, simply manual work you have to do. And you have no built-in over-the-air updates. There are other third-party services you can use, and therefore you can get that feature to work in this approach too, but it's just not as easy as with the Expo managed workflow. That's just something to be aware of. So with that, I want to start with the managed workflow and show you how you can publish and build your app there. And thereafter, I'll also briefly show you how that would work if you're not using Expo. What I got here is this application we built earlier in the course with the native device features, with the camera, maps, and so on. This is the app I want to deploy. And this is now how we can configure it to be deployed in the managed Expo workflow, as I mentioned. So what can we do? Now we should have a look at the app.json file, because that's the file where we can generally configure this app for deployment and for publishing it. And I want to walk you through some of the core settings you can make here and you should make here. Though let me also point you at the official docs, the official Expo docs, where you also have a full article about configuring the app.json file. You find this article attached, or a link to it attached to this lecture. And there you learn all about the possible settings you can set up there and what they mean, what they do, and where you would need them for. So there's a lot you can configure, but for a basic deployment, most of these things don't matter. So what we have here, for example, is the name of our project. And there I will use Great Places. This is also the name that will show up on the home screen when you build this app as a standalone app. And I'll come back to what a standalone app is in a second. Now here we also can add a slug, and that should be like this in the URL format, so that this could be part of a URL. And you'll see where disk becomes important in a second as well. The same for privacy public. We can leave this here at public for the moment, but again, this is something which I'll explain in more details in a second. The SDK version here simply identifies the SDK version of the Expo SDK you're using. Typically, this should be the latest one, though of course, if you are building the app with, let's say, Expo SDK 33, and then whilst you're building it, a new version comes out, you should always follow the update or the upgrade guides, which are released along with the new Expo version. New Expo version simply means that some features could change, that maybe some breaking changes were added, some bug fixes. So typically you want to upgrade, but you want to follow the upgrade instructions. Though you don't have to use the latest version here to be able to deploy it. You can also deploy an older version here. Platforms, that should be self-explanatory. You can describe for which platforms you want to publish, and I'll remove web here because we haven't really focused on that, and support for it also is still kind of experimental, so let's go with iOS and Android. Then you can set a version, and this number is totally up to you. In the end, you should just manage the version such that whenever you publish a new version of your app, you change that. And you have 3 numbers which you can change, where typically the last number should be changed if a new version only includes tiny bug fixes, but no major new features. The middle number should be changed if you have a new version that does introduce major or important new features. And the first number should be changed whenever you have a real major new version that might also very well include some breaking changes or some huge changes. So that's kind of something which also signals your users if it's a rather big, important update or just a small one, just a small fix. Orientation is a setting we already saw earlier in the course. There you can lock the orientation of your app. You can set this to default to allow for rotation or for rotating the app. You can set it to portrait or landscape mode to lock it down. Icon and splash screen, that's something I'll come back to in separate lectures soon. This allows you to set an app icon and an app splash screen, and you just set a pointer at an input source, at a basic file, and then Expo will generate a bunch of icons for different device sizes, different screen sizes, which is really convenient, but again, I'll come back to this in more details later. Updates, that's also something I'll come back to. That's related to the over-the-air update thing, which is very interesting. Asset bundle patterns, also something I'll come back to. This kind of has an impact on how extra assets like images that are part of your app, and with that I don't mean the icon, but images which you display in your app, which you store locally, or fonts which you might be using, how those are distributed, but again I'll come back to this. And then you can also set platform-specific settings here for iOS and Android. Now if you want to publish your app, you can do this in a very simple way. You just need to run expo publish. Now, when you first run this, you will be prompted to log in with your Expo account or create a new one if you don't have one yet. So simply create one. It's free. It doesn't cost you anything. You just need to create one. You can do this on the fly after running Expo publish. As I said, you will be prompted to create an account or log in if you aren't already. And there you can create the account on the go in this command line here. All you need is an email, a username, and a password. Once you did this and you run Expo publish, this will try to publish your app. And no worries, it will not immediately publish it to the app stores. Now instead, let's see what happens if we try to do this. It now builds a JavaScript bundle for Android and also for iOS. It also gave us a warning, by the way, regarding our assets not being optimized. That's something we can have a look at in a second. And with all of that, it's now uploading the JavaScript bundles. We don't know where, but we'll see in a second. And now it's done. So did it now create an app and upload it to the app stores? No, that's not what happened here. Instead, what it did here is it created a deployment. It published our app to Expo. So what you can do now is you can enter the URL, which was displayed here. What you find is your app now hosted on Expo's servers, so to say. And you can scan this barcode here with a real device, with the Expo client app. So basically what we already did during development can now be done with our published app. So let me briefly show this to you. Here's my iPhone, and now again I just point my camera at this QR code, or with Android you open your Expo app and scan the barcode there. And now you can open that app in Expo. Now again, you need the Expo client installed for this. Now what you'll also see here on the screen, however, is a warning that I can't open this app because I'm not the author of the experience. So the Expo client on iOS, as you see here, can no longer open published projects that don't belong to the signed-in user. Now that's an iOS limitation. On Android, you would be able to open this app. But of course, the question is in general, why would we publish our app like this? It's very hard to reach users with this. They need to have the Expo client app installed, which almost no one has in the world, probably just a couple of React Native developers. So this is not really how we want to distribute our app, right? Well, this is just one step of distributing our app. And this is actually not how we aim to target it or how we aim to get it to all users over the world. Instead, this is just one step of publishing it to the app stores. This still is a nice step for you to now easily test your app or to share it with other users, especially on Android. On iOS, unfortunately, there are some limitations where you can't test this, but with Android devices, you can scan this and you can share an app across users. You can show it to your friend, and all this friend needs is the Expo client app, and he can scan this code and run the app you just built on his device. So for this, it's nice, but of course, this is not the final solution for really publishing this to unknown users. Before we continue with the build or publishing process and therefore get it to the app stores, let's continue configuring this. Now for one, there are some blanks here, like the description which is missing, which you could add by adding a description key here with some text, and that would be the description that shows up here. Important, that's not a description that shows up in the app stores, that's really just a description that shows up here, and you can learn more about the description, all the other keys you can set here in this page. There are a lot of settings you can set after all. Now what I'm interested in right now is the icon and splash screen part, because that's the icon people will see on the home screen. Of course not yet, because right now we're not publishing the apps to the App Store, but that will change. And the splash screen, well, that's what users see when our app loads. And both are things you typically want to customize. Now, Expo gives you an icon and a splash screen out of the box, but both is, well, just an empty placeholder, right? So that's not too amazing. Instead, we want to provide our own icon and own splash screen image here. Now, you're really flexible regarding what you provide here, but in general, it's a good idea to provide an icon in the 1024 by 1024 resolution, so a square icon as an input. And for the splash screen, you can build a splash screen as described in the official docs, where you can learn more about how you could build such a splash screen, how you could structure it, and so on. Now, I prepared something for you, which you can use to now follow along, which you should not use for real deployment because, well, these assets are just for this course, not for you to use in your app which you plan to deploy. And for that, attached you find the icons zip file. Now, if you unzip this, in there, you'll find a places PNG file, which you can, of course, drag and drop into the assets folder. You can also delete the icon PNG file there if you want. You can also delete the splash PNG file because in this attached folder, you also find this splash icon PNG file, which you can, of course, therefore also drag and drop in here. Now, these are just some icons I created, which we can use now. And back in the app.json file, we now can point at the custom icons. Important, you should provide PNG files, as I'm doing it here. So now for the icon, we can point at assets places PNG. And for the splash, we can point at assets splash _ icon PNG. Now, as a background color, there we can use a dark black color, like hex code 171717. This should be a hex code color like this. And the resize mode here can be set to contain or cover. Cover will basically stretch the icon to take the full available width and height. Contain will keep the icon size, center it, and have that background color behind the icon. Now, if we do that, we can already see the result of this if we just npm start this. So this server, as we did many times in this course, or expo start. And we then launch this on an emulator, Android or iOS again, as I'm doing it here. Now this launches it there. And now you see this is the splash screen, already taking the new one with the image in there, which is rather big, but that's on purpose so that we can clearly see it. And the background color, which is slightly different so that you also have a chance of seeing that. Of course, you could pick the same color to have a seamless splash screen here. So that's working. Let's wait for that to finish. And here's the app running. And now you see your icon here as well if you go into the task switcher. You see it's not looking that great with that background, but that's something we can improve. But here is the icon in general. So that is working. We see both the splash screen and the icon. And on iOS, it would be the same. Now, as you can tell, the icon doesn't look that great on Android, though. The reason for that is that Android, depending on the version of Android you're running on your device, uses different icons. Newer, more recent versions of Android use these so-called adaptive icons, which are these rounded icons where you have your icon in the middle and then some background color or a background image even behind them. Older versions would use square icons. Now, you can cater for this by providing a more detailed configuration for Android and also for iOS if you want. Instead of having this general icon key here, you can set up platform-specific settings. And that's also something you'll learn in the official docs, of course. There you can find information on how you may configure icon and splash, that's nice, but then also how you may configure iOS in a specific way. And there you can set up icon specific for iOS if you would want to use this. Of course, the same is true for the splash screen, so you can basically add an iOS node to your configuration. We already have that here even. And in there, you could also add an icon and then also a splash configuration, which looks exactly, or which would look exactly like the root configuration we have here. But now you could basically override these general root level settings and have a specific icon for iOS and a specific splash screen for iOS. So that's something you could do. And the same is true for Android. And you, of course, find that as well in the official docs. You can add an Android key here to your app.json file. And then this holds an object, so to say. There you can also set up an icon and a splash configuration, just as I explained it for iOS. And now these settings would be taken for Android. iOS, since it doesn't have specific settings, in my example here, would still use the general settings up there. Now, the interesting thing is, for Android, you can not just set a specific icon and splash screen, you can also set an adaptive icon here with the adaptive icon configuration. That's not available for iOS because adaptive icons are exclusive to Android. Adaptive icon takes a JavaScript object, so to say, as a configuration value, not a string. And this object can have three keys: a foreground image, a background color, or a background image. Now you have either a background color or a background image, but you always should have a foreground image. Now here we can add foreground image, so this key here, and background color, which should be a 6-digit hex code, as you can see. And let's quickly do that here. And now we can set the background color to, let's say, that 171717 code, and the foreground image can now be set to our icon. Though for this, I would recommend that you use a specific icon, which you also find attached here, the places adaptive PNG file, which you can drag and drop into your assets folder. And that places adaptive PNG file can now be used here as a foreground image. So we can point at assets and then places-adaptive.png. Now this icon, the places adaptive icon, is transparent. It still is the icon, but it has a transparent background, unlike the other icon. And that will therefore allow Android to place it in front of this background color or background image you provided and automatically round the corners for you and so on. So if we now save this, and this therefore rebuilds, and to be safe that it really takes this into account, I'll restart my Expo server here. If we now launch this on Android, and for that I'll also close the Expo client here, and then rerun this on Android, we should see that once this restarted, we now have a nicer icon, which looks a bit better. So let's wait for that to launch. This is still the splash screen as we set it up before. I also did not set an Android-specific splash screen, which we of course could, but here I didn't. So we of course got the same splash screen as earlier in this module. And if you now have a look at the icon, you might unfortunately still see the old one. The new one will be taken into account though once we build this app as a standalone app and distribute it to the app stores. In general, the recommendation is that for Android you do set such an adaptive icon because you cover more Android versions, which, well, doesn't hurt, of course. Setting such a general icon is also not a bad idea, and of course you can either use one and the same icon for both iOS and Android, or you set specific icons for iOS and for Android, as mentioned for Android, possibly the adaptive icon. If you want to learn more about the process of creating and managing icons and splash screens, attached you find the official Expo docs, which dive deeply into the different options you have there and what you should consider. Now, besides icons and splash screen, our app also might include other assets. This app actually doesn't, but you might have other images here in the asset folder, which you're using in your app with the image component. So not network images, but local images, as we also used them earlier in the course. Or you might be using custom fonts, as I did in many of the course modules. Now, if you do that, there's actually something interesting happening in a managed Expo app. When you publish your app, and even if you later deploy it to the app stores, which I will show you, these assets by default are actually taken by Expo, are optimized and so on, and are then uploaded onto one of their servers for free, but they're uploaded there. And your app is configured to download them from the servers when it launches. Now, the advantage of this is that your app bundle is kept a bit smaller because the files are not included in your app, but instead live on a server and are downloaded into the running app. But the disadvantage of this approach can be that your app always needs an internet connection, because if you don't have an internet connection, your images and your fonts can't be loaded into the app, and that of course might lead to your app not working in the way it should. So therefore, you actually might not want to have your images or fonts uploaded to Expo's servers, or at least not all of them. And that's what you can control with that asset bundle patterns setting in the app.json file. Whichever path or paths you provide here will be excluded from uploading, and you can use wildcards. Now, as you see, what this basically says is all files should not be uploaded. So all files should be included into the app bundle. If this would be an empty array, or if this would not be set at all, this option, then you would have the default behavior of uploading all assets to the servers. With this approach, which was pre-configured here, you say, well, upload everything to Expo's servers except for what you find in this path, and this path on the other end is a wildcard that says everything, so every file in every folder of this project should be part of the app bundle. So actually nothing will be uploaded with this setting. You could also be saying, well, everything in assets, or maybe everything in assets and subfolders of assets should be part of the asset bundle. If you had any other files which you use in the app in other folders, you would upload them. So you can really control this in great detail. And again, you can learn more in the official docs if you wish to. Attached, you find a link to that as well. And therefore, you can control what's part of your bundle, therefore increasing the size of it a little bit and the loading time of the app a little bit, or what should be stored on servers, which might make your bundle a bit smaller, but which forces you to always have an internet connection. There also are more things you can set up, of course. One thing I want to dive into are the over-the-air updates, though, which you control with the updates key in the app.json file. Now, that's a neat feature, which means that people running your app on their device, no matter if it's just running in the Expo client because they scan such a barcode, which as mentioned isn't too useful, or if they really downloaded it from the app stores, as long as you build your app in the managed Expo workflow, you got the over-the-air update functionality built in. And that means that if you change something in your code, let's say here on this screen we change something, we change some title, some functionality, or we even add a brand new native module. No matter what you do, whenever you publish this update with the Expo publish command, all your users, even if they installed the app from the app stores, will get this update in their app the next time they open the app. And that's important. You can configure the functionality here in the updates key. Again, in the official docs, you learn more about this update key and what you can set there. What you can set, for example, is if it's generally enabled, which by default it is. And with this fallback to cache timeout thing, you can configure how long the app, when users launch it on their device, should check for updates and try to load them before it displays the recent available version. By setting this to 0, you're saying whenever the app launches, it immediately displays what it has. It looks for updates behind the scenes, and for the next launch, it might then take them into account, but it doesn't try to look for updates and download them before actually loading the app. Now you could change this to, let's say, 5 seconds. This is a millisecond value, so 5,000 is 5,000 milliseconds, which is 5 seconds. This would mean that when people launch the app, they will see the launch screen for up to 5 seconds, which is of course quite long, because after loading everything else, Expo, or your app, tries to look for an update, and if it finds an update, it tries to download it and take it into account. That might be done in 5 seconds, it might be done faster, in which case your app will also launch faster. But if it takes longer than 5 seconds, then it will continue with the updating, but not immediately load it, but instead load the most recent version that is available. Now it's of course up to you what you prefer. This approach makes sure that users have the fastest possible startup experience, but they only get your updated code the next time the app is launched. This approach, or setting this to an even higher value like 10 seconds, means that users get newer versions more frequently or quicker because they get it on the next app launch already. But the downside is that the app launch might take a bit longer, which is maybe not what you want. So it really depends on which type of app you're building and which type of users you're targeting, what you want to set there. If it's a business app, let's say, which you distribute to your employees, which needs to be updated all the time and where the user experience is not that important, you might want to take a value like 10 seconds here. If it's an app you share with normal end users around the world, you might want to go for a faster startup time to provide a good user experience and sacrifice update speed for that. So users would then only get the update on the next launch after this launch. With all of that out of the way, let's actually have a look at all of this and also at this over-the-air update feature. I changed a couple of settings here, and therefore what I'll now do is I'll run Expo publish again. Still, that's the command which will not get it into the app stores, but which will share it here on this Expo page, so to say. So I run this command, and we could have still optimized our assets with Expo optimize. But since we don't really have images included in the app other than the icons here, which are generated and optimized by Expo anyways, this shouldn't be a problem. So I can just run it like this and wait for this to complete. And then I will test this on an Android device, because there the advantage, of course, is that we can use this barcode here. So now once this is finished, the cool thing is we'll immediately have this new app available by scanning this barcode. And thereafter, I'll show you how we can get over-the-air updates without even scanning the app barcode again. Because that's the idea. We get any updates without scanning again. It's pushed to our app the next time we launch the app. So let's wait for this publish process to finish. And the URL is still the same as before, because I haven't changed anything about my slug here, which is part of the URL, or anything else. So now here's the Expo app on my Android device, where I can now scan this barcode, and therefore now the app launches here on Android. Now you see, I got the splash screen, got the app running here, and I can of course also use it. For example, I can take an image here. So that all works the way it should work on my device here. And now let me show you this over-the-air updating functionality. See that add place title here at the top? Now let's change that in our code. So let's go to the code here, and on the screen here, in the new place screen where we set this title, let's change this to add new place. It's a tiny change, but still. So now if I run Expo publish again, this app will be bundled up and will be published to, well, the Expo servers again. So let's wait for this process to finish. And it's done. And now let me show you this live updating. I still have the app running here. So of course, this does not change whilst the app is running. So of course, here we still have the old title. But now let's say I was away quite a time. I closed this here. And now I relaunched the app. If I now go to the new places screen, I still see the old title. Now that makes sense if you think about the updating strategy we used. I made sure that the app launches as quick as possible and downloads a new update behind the scenes. So that's what happened now. This was the first relaunch of the app on my device after updating it. So now let's say I'm again away quite some time and I relaunch it again. By the way, here you can see the adaptive icon in action. Now if I go to that screen, you see add new place as a text, because now this is the second launch after the update. In the first launch, we downloaded the update and installed it, so to say. In the second launch, we were using it. Now the app on the device technically didn't change, just what's in there changed. Our JavaScript code changed, and since we have this Expo wrapper, this means that Expo can take this into account and use this new code. And this will also work if you publish your app to the app stores, because there, whilst you will build a standalone app and people won't need the Expo client, you will still include that Expo client app into your standalone app, as I mentioned earlier. So your standalone app kind of has the thin Expo wrapper, the Expo client, built in and wrapped around your app. That's why over-the-air updates will even work there. And speaking of that, we now tested this a lot. We tested this all with just Expo and with scanning the barcode. Now let's dive into how we can really build this app and publish this app for the app stores. When building for the app stores, the Expo CLI, so what we type here in the command line, can help you or will help you, but you might need to tweak your configuration in the app.json file, depending on which features your application uses. So our application here uses a bunch of native modules. These modules all need to request permissions, and we kind of do this with the permissions API, like for example in the image picker here when we ask for permissions. But for Android, for example, you also need to provide a list of the permissions your app needs in a configuration file, which you, when you use React Native only, have, but which you don't have when using Expo, because Expo provides this wrapper and does all of that for you in the Expo client. But now we don't plan on using the Expo client anymore, and whilst it will include this into your standalone app, as I mentioned, you now need to tell Expo which permissions it should request there. In addition, for example, if you're using Google Maps, you also need to provide your Google Maps API key. And with that, I don't mean as we're doing it here, which we use in some parts of our JavaScript code, but to use the React Native Maps package. Again, the Expo client app basically uses its own key for development and so on, but as soon as you plan on offering a standalone app, you need to bring your own key so that the Expo wrapper, which will be included in your standalone app, will use your key, and because the Expo team won't give you a key owned by them for that. Again, the official docs are your friend. There you can learn what you can set up in the app.json file. And let's start with Android, because there you'll have to configure a bit more before we dive into what's specific about iOS. So for Android, besides icon and so on, what you can configure there are the permissions. Now, the thing is, you can't just omit the permissions key, and in that case, as you see here, Expo will actually set up your app to request all permissions. Now, I would not recommend doing that, because people will look at your app in the App Store, and if they see that your basic place management app wants permissions to read their contacts or make calls, well, I don't know about you, but I wouldn't download such an app. So my recommendation would be that you are specific regarding the permissions your app needs. And you do that by going to your app.json file, and there in the Android node, you add the permissions key, and now you add permissions. Now, some base permissions will always be requested. You find these permissions here, for example, permissions to get data from the internet and so on. But you can now also, for example, add permissions to use the user location and access the camera, because that's something we will do. So let's add these keys here to permissions like this, 2 string keys with double quotes, by the way, that's important in this file, added to this permissions array. Now we will also need the right external storage permission to save our image. So we should add that as well. And with that, we should be good for this application. But of course, depending on the application you're building, carefully check which permissions your app will need. You can always consult the documentation pages of the native module packages you're using. There you should normally find a description of the permissions this package needs. So permissions are one thing. In addition, if you're using Google Maps, you should add the Google Maps node to your Android configuration. So here, after permissions, we can add Google Maps like this, which also holds an object as a value. And in that object, you set up the API key. Again, you didn't need that for the Expo client when we published the app to this Expo page and used the Expo client app, because there, the Expo team basically gives you their own Google Maps key. But if you're building a standalone app, you need to provide your own one. So for that, make sure you use your key here, like this. And also important, and I mentioned this in the non-Expo module already, make sure that in the Google APIs, so in the Google Cloud Console, when you check your API library, you make sure that the Maps SDK for Android is enabled for this project to which this API key you provided belongs. So here it is enabled. This has to belong to the project for which you created that API key, which you now are providing here. Otherwise, this won't work. So these are the permissions and Google Maps settings, and you might need other specific settings, which you can learn about here in the app.json file, depending on which features you're using. You can also configure, of course, everything else and so many things. One thing you absolutely need to provide to build your app is also this package key. This is something you always have to add, no matter what your app uses. Here in the Android node, you need to provide the package key, and this now has to have a certain format. It's basically an inverse URL. A fictional URL, which doesn't have to exist, but which acts as a unique identifier across the entire Google Play Store. So it should be an inverse URL, which no one else has used before. And therefore, typically, if you own a domain, you would use your domain, for example, com.academind, so an inverse domain, and then a unique identifier like Great Places. You can come up with any URL you want here, but of course, again, it should be unique, and you should therefore use your own domain or a fictional domain which isn't owned by anyone, so not Academind, because I do own this. So any other domain, any other fictional identifier which should have this format. That's what you provide here. You also need to provide something similar on iOS. There, if you go to iOS, you don't need to provide this permission setting stuff because iOS permissions work differently. You would need to provide a Google Maps API key if you use the Google Maps version of the Maps package for iOS. The default of this package, however, is to use Apple Maps, and I haven't changed this in my app, so I don't need to provide the Google Maps API here. But what you definitely need to provide here is a bundle identifier. So replace package with bundle identifier, and the format is the same. You have this inverse URL syntax here. And I'll name it Academy Great Places course, and also use that -course edition here on Android. So bundle identifier for iOS and package for Android needs to be set to such an inverse unique URL. Now besides these identifiers, you also need to set something else. On iOS, you need to add a build number. Also here the iOS node therefore. And the build number should be a string which identifies your build. There you should have a build number just like this version up there and working in the way I explained it up there. So it should be a number consisting of 3 digits where you have a patch number for, well, patches, bug fixes, then this minor update number for new features which don't break everything though, and this major update number. You can change this however you want, but you should change it for every new version you publish and you deploy, and you should of course change it such that you reflect what changed. Now you need something similar for Android. If we go back to the Android documentation, there we also need a version code. So here we add version code, and now here this is not a string but a number which you should simply increment by 1 for every new release. So you start at 1, the next version you release, even if it's just containing some tiny fixes, should be 2. And then to 3, and so on. So that's what you should set up here. This is how it works for Android. You also find that description here in the documentation. And with that, we're now prepared to deploy this, or to build it first. And as I mentioned, the cool thing about Expo Managed is that now you can build this on Expo's cloud servers. So what you should do is you should run Expo publish to publish the latest version of your app to Expo's servers, just like that, which will not yet build it as a standalone app. And now what I get here are a couple of warnings or errors. So we see that Android should not have an additional property Google Maps. Yeah, because that should be in a config node. My mistake. So you should add config here, and in config you might have this Google Maps key. That's a tiny mistake on my side. And here for the package, Android actually doesn't like dashes in there, but you may use underscores. So let's use this. With that fixed, now let's run Expo publish again to again validate this and then publish the most recent version to Expo's servers, which again will not start the build process yet, but which is an important preparation. And once this is done, you're ready to also build your app for Android and iOS. Now the difference between publishing and building is that publishing just pushes your code and configuration to Expo's servers, and you can then scan the barcode with the Expo client and so on. Building means that you leverage Expo's cloud build service to really build an Android app bundle or an iOS IPA file. These are the files which you then upload to the app stores thereafter, so there is a huge difference here. Now these bundles which you build, as mentioned before, include the Expo client, so to say. They include this as a wrapper around your app, but it's a real native app therefore after all. So it's a native app with just this little extra tiny wrapper around it, taking into account the configuration you set up here, for example, regarding the permissions. In addition, these apps which you build on Expo's servers, which you then can distribute through the app stores, will talk to Expo's servers for the over-the-air updating functionality. So you will still just publish new updates with Expo publish thereafter, and your standalone apps, which are running on other devices, will get these published updates. So publishing is still important even if you're building standalone apps, if you're building app bundles, because these app bundles will continue to talk to Expo's servers to get new versions. But speaking of that, how do we build these bundles now? You do this with the Expo build command, and there you have build:\Android and build:\iOS. Now let's start with build:\Android, and as the name suggests, this builds an app for Android. You can learn all about the standalone build process in the Building Standalone Apps Expo docs, which you also find attached here. And there you find the basic configuration you need and what you should take into account there. For Android, here you find that you also right now at least can choose whether you want to build an APK or an app bundle file. Building an app bundle file is recommended because that is the preferred format Google wants. And for this, you can run, instead of just expo build Android, you run expo build Android-t app-bundle. If you now hit enter, this will in the end validate your setup and then push your code to Expo's cloud build servers, where this will now be scheduled. Now, first of all, it will ask you, because apps need to be signed. That happens with a private public key pair, which in the end is used to identify you as the author of the app. Future updates of the app, and with that I don't mean updates which you publish to Expo's servers with the expo publish command, but when you rebuild the app, when you rebuild the package, which you then re-upload to the app stores, which you occasionally need to do if you, for example, change the icon or something else, which can't be shared with Expo Publish. In such cases, you need to sign the update with the same keys you used for creating the original app to identify you as the author. Otherwise, the App Store will deny this update. It will not accept your next version of the app. So therefore, you need to sign your app. And if you know what you're doing, you can create and upload your own key store. But here, I will stick to version 1 and let Expo handle that, which means it will create such a key for signing and do all the signing stuff for you on their servers. So that's what I choose here. Now with that, it again builds the app just as for publishing. And even though I'm building Android app, it still builds it for iOS here, because in the end what it does here is it publishes the app. So let's wait for this to finish. Now it's just doing the same as Expo published it, but thereafter it will schedule this to be built on Expo's servers. So now publishing is done, and now it schedules such a build. And it queues it up. This, by the way, is a process you can now quit, as it says here. You can always check the status of your build by entering this URL. You'll need to log in with your Expo account there, and then you can see the build status. Now, important. This build can take very long. The build itself, not so much, but until your build is built, because it's scheduled. Keep in mind that this is a free service, so of course it's not built immediately, but when the Expo servers have room for it. This can take a couple of minutes, even hours, until that happens. So don't worry if that takes some time. You can always check this URL, which you're seeing in your command line, to see what's happening. So you can quit this. This is also the URL where you will later find the build file. So here's my build status. If we check it, you see it's queued, and right now nothing else is happening. We can revisit this later to see the build process and download the finished app bundle. And for now, let's do the same for iOS therefore. This can be done by running expo build iOS. Now important, to build iOS apps you need a paid Apple developer account. That's a must-have. So you will need to go to developer.apple.com, and there you will need to log in with your Apple ID and then basically get such a paid account. So you will need to add your credit card and pay a fee of $99. That is required. There is no way around that. Apple requires that for you to build apps which you want to publish to their stores. You don't need that during development, but now for sharing the app, you need to have that. It's basically a fee that's there to only allow people to the store who have at least some kind of serious goals there, I guess. So make sure you sign in here and set up your paid Apple developer account to join the Apple developer program. And thereafter, you can run this command, and it will ask you to log in with your Apple developer account. So you log in with your Apple ID and password, and that data will not be stored on Expo's servers, no worries. But it needs it to set up everything to build your app, because for the Apple build process, you need special certificates and so on, which it can request on your behalf with this data. Once you did log in, it asks you how you want to handle your credentials. Just as before, if you don't know what you're doing, you should let Expo handle all of that, because as I mentioned, you need a couple of special certificates to, in the end, build your iOS app. And Expo can request all of that for you and set all of that up for you. So I'll let Expo do this for all these steps. And now it will basically do all of that for you. Now this also builds my app here for iOS and publishes it again first. That's the same we did before for Android. And now we also got a build scheduled for iOS. Just as before, this is queued up. You can quit that and just watch your build here in the browser. So now we don't just have that queued up Android build, but we also have that queued up iOS build. And both will take a while until they're finished. Now there's one important thing you also have to do after this Android build is done, which it isn't yet. You should run expo fetch : Android : key store. Again, this only works after the build completed, because this will then fetch this automatically generated key store, which expo generates for you if you chose that in the setup, which you need for future updates of this app. You will definitely need that, and in future updates, when you rebuild the app, you then have to choose that you provide your own key store, and you need to provide this key store then. So enter the path to this key store, which you then download. So this command will in the end download a file generated on Expo's servers, which you need to store on your system for future update of the same app. Otherwise, you'll not be able to update. So that's some important command you'll need to run once this build is done. Well, and with that, let's wait for it to be finished. iOS actually is already building. Android is still queued up, but iOS is already on the go. So let's wait for the iOS build to finish. And now this is done. Now my iOS build is done. Now you can also check the official docs on how you can continue with testing this on your device or simulator, or then go to the part where you upload the app to the Apple App Store and the Google Play Store. So we built the app. Now you can upload it by running expo upload : iOS. This will by default use your latest app and upload it to the App Store. Now it's the part which I will not do here because I don't really want to publish this app here, but it is what you would now do. It would use this application which was just built here for iOS or for Android. Android build is now also running, as I see, so it would use this and then publish this either with this command to iOS or with this command to the Android, to the Google Play Store. Now, follow the steps you find here in the docs to create the appropriate accounts and set up everything correctly so that this command can succeed. And with that, you'll have your app deployed to the Apple App Store and to the Google Play Store so that you can, well, get your app to any user around the world as a standalone app, not dependent on the Expo client being installed on the devices, which is pretty neat. So we saw how we can build and deploy an app with Expo in the managed workflow, which was pretty convenient. Now let's say we have an app, for example, built with the React Native CLI. Here I'm not using any native modules, but if I were, I would have, of course, have updated my Android and iOS configuration files to request the right permissions and so on, and I showed all of that in the non-Expo module earlier in the course. So now let's say we're happy with the app and we want to publish it to the Apple App Store and the Google Play Store. Now the official React Native docs are a great place to get started with that. There in the documentation under guides, you also find this running on device guide where you can learn how you build your app for iOS or Android on the different operating systems you might be working on. Important, you can only build for iOS on macOS now. Linux and Windows don't work because now we're not building the app in the cloud as we did with Expo, but locally on our machine, and there Apple has this restriction that you can only build iOS apps on a Mac. It is what it is. So, now what you need now is an Apple developer account. Right now, not necessarily a paid one, just to build the app. However, if you want to build it for the app stores, you need a paid one, as mentioned earlier in this module. So you should set up such an Apple developer account and then open your project here, your iOS project to be precise, with Xcode. There you can click open another project, go into your project folder, there to the iOS folder, and there select this XC workspace folder or file here to open this with Xcode. This opens your project, your iOS project, which includes your React Native code, of course, in Xcode. Now it's there where you now configure this app, where you set up your identifier, for example. That's this inverse URL I was talking about, which could be com.academind.rn no expo test, something like this, where you set up version numbers, which your users will see, and your build number, which can simply be a number that you increment here. where you should choose automatically manage signing, and where you now need to choose a team, which should be shown here. If not, add an account and there log in with your Apple ID to add your Apple developer account as an account here. And thereafter, you should be able to choose your team here, which will be required for automatically signing the app, which will then be done by Apple, so to say. You can, in general, configure your app here, of course, and prepare it for deployment. And one important configuration is, of course, related to the icons you want to use. In Expo, we set up the icons conveniently in a configuration, and Expo generated all the icons for us. Now it won't work like this. Now you need to set up these icons on your own. And you do this by clicking on this little arrow here, which takes you to the assets catalog. And there you can now provide icons, and you need to provide icons in different sizes here, as you can tell. And obviously that was a convenient thing by Expo. It did create these icons for you, and you didn't have to manually create all these icons. Attached, however, you find the icons zip file, which includes icons you can drag and drop in here. So that's what I'll now do. And the icons are labeled such that it should be clear what you have to drag where. And with that, you got the icons configured. You also might want to configure the launch screen. For that, you can expand this folder, and there you find this launch screen zip file. This in the end allows you to customize your launch screen. There you can add new widgets to it, drag images into it, change the text you see here, for example, and configure the launch screen in general. You can learn more about this in the Xcode docs, of course. And once you did configure all of that, you can build your app here. For that, you can also, for example, test it on a simulator first by choosing a simulator version, then clicking the play button here, and this will now build your app and run it on the simulator. And thereafter, of course, we can also build it for deployment. Let's just see whether this now all works. It launches this bundler process, which you already saw earlier for this standalone app, because of course that's still part of the development experience here. It's still a React Native app after all, which you use for building this native app. And now this succeeded, and it launches the app on a simulator. Now I'm not too interested in the app there because I, only have a very basic app there which doesn't do anything fancy, but this proves that building works. Now in the official docs, if you scroll down further, still in this running on device section, you also learn how to build your app for production, if it's a non-Expo app. And there we have got two important things to do. The first important thing is that in our project view here, by clicking on this folder and then on this icon here, you expand this folder and then go to the info plist. And now there you'll find this app transport security settings key. This kind of controls how iOS controls to which web pages or web servers your app may talk. And by default, it only allows access to HTTPS servers, so SSL secure servers. That's a good default, but you might have some exceptions which you can add here. And one exception in the exception domains list is localhost. Now that's required for development because your React Native app in the end talks to this development server here, which runs on your localhost, which is not using SSL. Normally iOS would block this. Now to not block it, this is in the exceptions list. To build this for production, you should remove this. You can simply clear this key here by removing it with the delete key. And that's it. That's one thing you should configure for deployment. And then you need to configure such a release scheme. For that, you should go to Product, Scheme, Edit Scheme, and set this from Debug to Release here for Run, and then close this. With that, you can now run Product, Build here to build your app, and now this is built for release, built for production, so it's optimized and so on. So this builds your app now for production. Now, whilst this build runs, let's make sure we can also upload it to the Apple App Store. And for this, you should go to your Apple developer account, and here you now definitely need a paid account. And there, you now need to set up a couple of things. You need to go to Certificates, IDs, and Profiles here, and go to Identifiers, and then here add a new app ID. Just this here, the first setting, add an app ID, and you need to add the app ID which you set up in your project. So the app ID, the bundle identifier you find here. That exact identifier needs to be added here. You can add a description, RN demo, whatever you want, but then here you need to add this ID. Now you can check any special capabilities your app requires, which my app doesn't, so I don't need to check anything there. And then I can continue, confirm this, and register. Now this is required, otherwise you won't be able to publish your app. Now with that ID registered, you need to go to iTunes Connect, and you can simply Google for that, which is in the end the service where you create that store page and where you now need to, well, set up your app. There you can go to My Apps and add a new app here by clicking the plus, new app. Here, by the way, you also see the app we built with Expo, so click new app here. iOS, give it a name like RN No Expo, which of course is a beautiful name, which you wouldn't really want to use, but it's good for us here. Then choose the language you're building your app for. Choose the bundle ID, and there choose the ID you just set up. If it's not showing up yet, come back a couple of minutes later, it will be there then. You can then also add your own custom identifier, which will show up on your invoices basically and so on. RN No Expo, whatever you want, and click create. And this now creates the app here in iTunes Connect. This is then also where you can manage the app for the App Store and set up its pricing and so on. Now with all of that done, let's wait for our build to finish here. And if it failed, like it did for me, reason for that is you need to set this to generic iOS device. So make sure you have this set. Also make sure that on this RN without Expo tests, you select your development team. That's another error I got here. If you're still getting an error, as I do, press Command 1 here in Xcode. Click on Build Settings here with all these things selected as you see it here. In the linking section, which you'll find if you scroll down a bit, and in the dead code stripping part here, under release, set this from yes to no. This is a workaround around this error, which seems to be related to the automatic tests which are set up. And once you did this, try this again, run the build one more time, and now this should succeed. Once this build succeeded, you can go back to product, and now the archive option is available. If you now run this archives your app, which is nothing else than building that bundle which previously was built on Expo's cloud servers. So let's wait for this to finish. Once this is done, you should see your archive, or archives if you ran the process more than once, here. And now here you could distribute your app to the App Store with the configurations made on iTunes Connect and so on, which I showed earlier. Now, I'll not do this here, but this is how you would deploy your React Native only app without Expo managed. Now you learned how you can build your app for iOS. What about Android? Again, in the official React Native docs under Guides Android, you find the instructions on how to publish your app to the Google Play Store. And in the end, you can just follow the instructions you find here. It all starts with creating such a key store, which I already mentioned in the Expo managed workflow, but there Expo did that for us on their servers. Here we need to do that. And we can do this inside of our project, or on Windows, as it says here, make sure to run this command while navigated in this folder. You can copy your key store into your project thereafter or store it anywhere else. You will need that key store which is generated for signing your app and for signing updates to the app, so make sure you don't lose it, otherwise you'll not be able to, well, rebuild your app or update your app. So here you can enter an arbitrary password which you want to choose, and then some information about you, which technically could be wrong, but which, well, should be correct, kind of, since this is your identifier, or since this is used for assigning your app in the end. And once you had entered all this and confirmed it, and you chose your passwords, this now creates this my upload key store file here. And now you can use that to sign your application. Next, you need to set up some Gradle variables, as you see here. And for that, make sure you move the key store into the Android app folder. So from this folder here, move it up into Android and there into the app folder so that the file is there. And then go to the Gradle properties file, the Android Gradle properties file. So here under Android, we have the Gradle properties file. And in there, you can add these entries. And as it says there, replace the stars here with the password you chose for the key store. Once you did that, you can close that file. You should go to the Android app build Gradle file. So not build Gradle here, but in the app folder, and there the build Gradle file. And add this configuration in the Android node, as you can see. So you can just copy this, and then here search for the Android node, which is this node. There you got the default config, which you should not touch. But you got your signing config, where you should, in the end, add this release part. So not delete the debug part, but add this release part. And then under build types, release, add this line here. So if we scroll down further, build types, release, there we can add this line, signing config, release. And now you can generate your APK with these commands. So by navigating into the Android folder and then by running this command. So let's do that. Let's first of all navigate into the Android folder here with cd Android and then run this Gradle w command. And this should now build your app and sign it for production and give you such an app bundle in the end, which you can then upload to the Google Play Store. So let's wait for that to finish. And once this build succeeded, you can actually take that app bundle, which you now find under app, build, generated, outputs, bundle, this file here. That's your release bundle. That's what you can now upload to the Google Play Store. For that, you can search for Google Play Console, and you need a Google developer account for that, which also costs you money. But unlike Apple's program, it's not a subscription. It's a one-time fee of $25. And here in the Google Play Console, you can now create a new application once you're logged in with your paid account. Choose an app name, like this, create it. And then here you can manage your entire store appearance, your entire app, how it looks like. And under app releases, there you can click on production track, production manage, create a release there. And now here you need to upload your app bundle. Now you can click continue here with the default settings normally, but in general I would recommend that you dive into the Google Play Store, Google Play Console documentation to learn all about the things you can set up here. But in the end, this is now where you can upload the bundle which you built. So here you would upload this bundle file. And thereafter you can finish up your store appearance and you can publish your app in the Google Play Store as well. Now, of course, you might wonder, how do you add icons and so on? Because I haven't touched on this yet. A convenient and easy way of doing that is with the help of Android Studio. There you can open an existing Android Studio project and open your Android folder in your React Native project here with Android Studio. Just the Android folder, not the entire React Native project. In there you find your Android part of this project. And here to add icons, you can go to the app folder, source, main, res, and there wait for this initialization and the build to finish, which starts up when you open this. And once this initialization is done, in that app folder, if you click on the res folder, right click on it, you can select new and there image asset. And this opens an editor where you can conveniently add and generate new image assets, new icons for example. There you can choose launcher icons, adaptive and legacy. And now what you can do, you can leave the name, you can set up your icon, you can configure it there. You can choose a foreground layer, and there you can, for example, choose the path of an image you want to use. A background layer where you can set a solid color or also an image you want to use in the background. And then therefore generate your icon with that tool. Simply click finish and of course provide your own image there if you want to, and it will set everything up for you to have a nice icon, which of course is pretty sweet. Now, regarding how to customize the splash screen, attached you find some documentation on how you may do this on Android to set your own splash screen. Of course, whenever you change your icons and or your splash screen, you'll need to rerun this build with that gradlew command, and then also redeploy your new app bundle to the Google Play Store with the Google Play Console. And with that, this is how you would build and deploy React Native only apps. Of course, a bit more manual work, a bit more cumbersome than in the Expo managed workflow, but now you know both options and you can go for whatever approach you need for your application. In this course, you'll learn how to build apps with React Native and for navigating between screens with React Navigation. Now, actually, in this course, we use version 3 and version 4 is the same basically for navigating around. And now we have React Navigation 5, or by the time you're watching this, maybe even a higher number. The important thing is with the release of React Navigation 5, so of version 5 of this third-party library, the way we set up navigation in React apps, in React Native apps, I should say, changed. Now, in this module, I will walk you through the changes and let you know where you can learn more about them. And to show you what changed and how you can use React Navigation 5, we will take the finished course project and port it to use React Navigation 5, so that you can learn step by step how that works, and then you can decide on your own whether you prefer versions 3 and 4 or whether you want to switch to version 5. Now, what did change between version 4 and version 5? With React Navigation in the past, or with these older versions, so with React Navigation version 3 and 4, which we use in this course, we had this way of setting up routes or of setting up screens we could go to. We set up such a registry-like configuration in a file where we basically mapped our different screens to identifiers, and then we could work with these identifiers from anywhere in the application to go to a specific screen. Now, when it came to configuring these different screens, we could do that directly in the screen component or also globally on the stack navigator, for example, with the default navigation options. Now, this approach of navigating around works just fine, as you see in this course, and there isn't necessarily something wrong with it, though we also had some occasions where we definitely saw that it could be tricky at times, right? If you wanted to update header buttons in the header of a component dynamically, you had to abuse params to do that. And that was not ideal and definitely a bit tricky to wrap your head around. Nonetheless, you can definitely use React Navigation versions 3 and 4, and you can keep using those versions. But with the release of React Navigation version 5, things changed a bit, and we now set up routes and we navigate around a bit differently. Now, there basically is one super big change between version 4 and 5, which I'll cover in this module. We now don't set up our different routes or our different screen name mappings in this registry-like way we see on the left, but now instead we set everything up as a component tree, you could say. So now we have a component-based configuration of our different routes we can go to, of our different parts of the app we can go to. And what looks a bit messy here on this slide will look way cleaner later in this module when we port our project to that setup. Now, whilst this certainly is a big change and a big mental model switch we have to make, because we set up our navigation configuration in a totally different way now, it offers some nice advantages, as you will see. It's actually closer to the React way of building apps, where you basically want to use components everywhere to express what the result should look like, and you then let React figure out the way to get there. And if we set up our screen configuration in such a component-based way, then we actually just define our end result, and we let React and React Navigation figure out the way to get there. So that's actually a good mental model to have, but of course it's one we have to get used to. And therefore, without further ado, let's dive in and let's port our application. However, there still is one thing I want to say. React Navigation, this package, with the versions 3 and 4 is still super important. Of course, React Navigation version 5 and so on is the future of React Navigation, but the vast majority of projects you will find out there, of React Native projects, will use React Navigation in versions 3 and 4. So you have to know those versions as well, which is why the overall course still uses these versions. With this module, I also show you version 5 so that you have the full toolkit and you're able to work on any React Native project, no matter which version of React Navigation it uses. So here's the finished project, not with the bare workflow, not ejected, our finished Expo project after adding authentication. I didn't update any dependencies here, so what I'll actually do now is I'll open up my terminal and I will first of all run npm install to install all these packages again. Now, of course, you don't need to do that if you already have your up and running project, but I need to do that because I literally took that finished project snapshot you find attached at the end of the authentication module, and I'm now going to install all the dependencies there so that you really see how to pick up from that finished snapshot and get everything to work with React Navigation version 5. So let's wait for this installation here to finish. And with that finished, the first thing I'll actually do is I will run expo upgrade to install the latest version of the Expo toolkit and make sure that Expo also updates everything in the way it needs to be updated so that it installs all packages it needs and so on. So I will now hit yes here and also yes here on this question. And now here it will update the installation on the iOS simulator, the installation of the Expo preview tool. And therefore, you should make sure that you have a simulator up and running. And I do have that on a separate screen, so I will hit yes here as well. And once it is done with that, it also asks me the same question for Android. And for that, I also have a running Android emulator where it now reinstalls the Expo application. And it should succeed with this as well. Let's wait for that to finish. And that looks good. And now it just installs a couple of dependencies again. Let's wait for that to finish. And with this, we can run npm start to bring up this Expo process. And once this is started, just as you saw it throughout the course, we can press A to launch the Android app and I to launch the iOS app, or do that in that extra tab in the browser, which opened up on another screen here for me. And once this is done, it now starts building, and I'm getting an error here regarding React Native screens. To quickly fix that, I will just quit this again, and we'll run expo install react-native-screens. And thereafter, once this is finished, restart this process with npm start, and thereafter again, press A to launch the app on Android, and press I to launch it on iOS. Now let's wait for this to finish so that it builds this JavaScript bundle and launches the app on both simulators. And therefore I see both apps up and running. Now, in order to log in, I also need to adjust my Firebase data, simply because I created a new Firebase project. If you didn't do that, which you probably didn't, you of course don't need to do anything. Here, I will quickly update those credentials, those links, and so on in my actions with my proper Firebase data, which I'm using now. And with that done, I can try and log in here. I did create one user, and that works. Now, I get an error here because I got no products at the moment. That's no problem, but what we see is that we generally can navigate around in this application and that this app works the way it worked when we finished the course. Now, of course it does, because right now we're not using React Navigation in the latest version. So let's make sure that we do that. Now, just like earlier in the course, the official docs are the place to go. So on reactnavigation.org, you can learn more about React Navigation, also in its latest version. Now there's one thing I would recommend, and that's a blog post where React Navigation 5 was announced. You find it attached to this lecture. Now, in this blog post, you can learn more about React Navigation 5, what's new, what changed, why they changed it, and which new features are included. There are a lot of features which don't matter to us here, but which might matter for your next application, so definitely check that out. You also find a link to an upgrade document in there, an upgrading guide, which gives you detailed steps on how to migrate your React Navigation 4 application to React Navigation 5. So that's definitely worth a look to learn more about it. What we will do now is we will install React Navigation 5. And for that, I'm in the Get It Starting documentation, and there it's this command which I'll grab. So grab that, stop that process here, and run npm install @react-navigation/native. This is new, by the way. Prior to version 5, the package name was just React Navigation, not @React Navigation/something. So now let's install this new package here. And whilst this is installing, we can already grab this next command down there, copy it, and also run this command to install all dependencies of this React Navigation version. And once this is done, we should be able to restart this application with npm start here, and then again launch it on Android and iOS to see the updated application there. Now what you'll see now is that it's broken. It's not working anymore just because we installed these new packages. And now it's time to migrate our setup to this new component-based setup. So let's start with that. The majority of our files don't need to change. What we will need to change, though, is what's happening in the navigation files in the navigation folder. In app.js, you might remember, I'm rendering the navigation container here, and the navigation container is just a custom component here, where we in the end have our logic for checking whether the user is authenticated, and then we render the shop navigator, which is our root navigator created here with React Navigation. And that is where things have to change now. Now let's start with the navigation container. We won't need this code here anymore, where we manually navigate somewhere else if the user is authenticated, because you will see later that this will now be handled differently with this component-based configuration. So you can delete use effect here. Keep is off here though. You can delete the ref here, however, and also delete it there. And when it comes to the imports here, we don't need the two hooks here anymore, and we also don't need this import anymore. So we just have the shop navigator left. And that's also not really something we need here anymore. We're not adding a shop navigator as a component like this, where we then refer to the overall configuration from the shop navigator file. Because that overall configuration is of course all set up with that old logic of having that global registry-like configuration, which is simply not working anymore with React Navigation 5. Instead, we now need to migrate all of that to that new approach, to this component-based approach. And to do that, I want to start quite simple. In the navigation container, I will set up a new stack navigator, which is just a dummy navigator for now, so that you see how it generally works, before we then later will actually, apply this to our real application. For that, let's add an import here from @react-navigation/native. And from there, we need to import the navigation container. Now that can be confusing because our own component here is also named navigation container. So to avoid confusion here, I will rename our own component here to app navigator, or whatever you want to name it like. So I will rename it here, and also to avoid confusion, even though it's not technically required, in the app component, in app.js, I will import it as app navigator. I will rename the file to app navigator, and I will import from app navigator here in the app component. So adjust the import path to include that new file name. And then here I render app navigator. Now I just made these name changes to avoid confusion. The more important part happens inside of that app navigator, which previously was our navigation container. Now we're importing navigation container from React Native, but that will be a different component than what we built in the past. It just shared the same name, which is why I renamed it. More important than this navigation container, for the moment, is that we import something from @react-navigation/stack. And this is now a package which doesn't exist, which we haven't installed yet. So let's stop this process again, and with npm install --save, let's install @react-navigation/stack. So npm install --save @react-navigation/stack. This will install us the stack navigation logic. And we can also install another package already, because we'll need it later, and that's @react-navigation/drawer, which will later give us the drawer-based navigation, which we'll also need. So let's wait for these two installation commands to finish. And thereafter, with npm start, we can bring up this Expo server again. So now that we installed React Navigation Stack, we can import something from it, and that something is the create stack navigator. Now, create stack navigator is a function we already know, right? In shop navigator, which still uses the old React Navigation version, we also imported create stack navigator from React Navigation, or if you were using version 4 of this package, from a separate package. But we also had create stack navigator in there, and create drawer navigator, and so on. Now, we used create stack navigator to create our configuration setup, our navigation registry for this part of our application, you could say. So for the product's overview, the product detail, and the cart screen, which we put together into one stack. And then we had multiple such stacks to compose them together in our drawer navigator, which we ultimately then combined with the off screen in the switch navigator. Now, back to our app navigator. What do we do with create stack navigator here? It now works differently. Now we use it to create a new component with it. And I will name it my stack. The name is totally up to you, but you simply call create stack navigator like this, and you're done. And this is now a huge change. You now don't pass any object to create stack navigator to configure it. Instead, it is a function that doesn't want an object. It is a function that needs no object. So what does it do then? What is my stack? My stack is now a React component, and we use it as such here in the app navigator. To be precise, we need to wrap all navigation logic with the navigation container component, which we're importing from React Navigation Native. You can think of that navigation container component basically as the component version of the app container, which we created with create app container in the old setup, right? There we had to wrap our finished navigator with create app container. Now we have to wrap our to be done component-based navigation setup with navigation container. So in here, we now set up our logic when it comes to which pages we want to be able to load. And here, we now use my stack as a React component, but not like this, but instead here, we need the .navigator component. So what my stack actually is it's an object with a navigator property, and the value stored in that property is now a component. So now we can create that component, and between the opening and closing tags of this component, we now put basically the different screens we want to be part of that stack. So what we previously here in Shop Navigator had inside of this object, we passed to create stack navigator. This map of screen components and their names, that's what we're now setting up here between this opening and closing tag. You could therefore think that what we do is we add the product's overview screen component, right? This is one of our components. We would add an import, which we haven't done here because this is wrong. But you could think that we do this. Well, almost. This would certainly be the screen we want to have as part of this navigator, but it wouldn't have a name. Now we need a name so that we can navigate to it, for example, so that we can trigger a navigation somewhere in our application. That's why we have a name here as well on the old setup. So instead we do something different. We again use my stack, this object up there, and now a second property which it has, the screen property. Just like the navigator property, the screen property also holds a React component, and hence we can render it like this. This is now a component which allows us to define a screen that should be part of that stack navigator here. And we configure it with the help of props now, because we're working with a component here, so configuration works with props, just as it's always the case when we work with components. To give this screen a name, we add a name prop. And now we can use that name we use here, products overview. So we can add this name. And to let React Navigation know which component to load when we target this name, when we do that with a navigation action, for example, we add a second prop, the component prop. And this should hold a pointer at the component we want to load when we want to go to this screen with this name. So for this, I'm going to import products overview screen here from our screens folder, the shop subfolder, and then products overview screen. So now we do need it. And I pass this here. Now important, we don't create the component here. We just point at it. We just use its name, which is exported from that file. And with this, we now have our first little stack set up here. Now let's comment out this import from Shop Navigator. We don't need it anymore at the moment. Let's save everything and launch this on Android, let's say. And when you do that, it builds the JavaScript bundle and opens this up on the Android device. And what you'll see is our products overview screen. Of course, it looks a bit different. Of course, it's missing the header buttons. It's missing the entire header configuration. The title is also wrong. But that makes sense because we're now not using the old navigator where we had all this configuration, but the new one. And this is just a proof that it works and how it works. Now, with this knowledge in mind, let's now leave this tiny example here and let's actually port our entire navigation setup here to this new logic. So let's work on porting our entire logic here. In the app navigator, we started with this dummy stack here, and that's nice, but ultimately not what we need. Now it's up to you where you do that configuration, but since we did it basically in the shop navigator file before, I will also keep on doing it there, even with that new logic. So what I'll do is, in App Navigator, I'll actually get rid of that my stack here, and I'll get rid of this import, and I'll get rid of this here. I'll leave the navigation container though, and I'll re-add this import, though ultimately we'll change this a bit. But now let's move on to Shop Navigator. There, first of all, we can delete this import from React Navigation, we'll not need it. Let's leave the rest for now though. Instead of that deleted import, we can import from @React Navigation stack and also already from @drawer. And from @stack, we import create stack navigator. From /drawer, we import create drawer navigator. Now we can scroll down and we can leave the default nav options here actually. Thankfully, the namings and how you generally configure things and what you can configure did not really change. Just how you apply the configuration changed. And therefore, what definitely needs to change is this part here, our first stack navigator. I will for now duplicate it and later delete it or comment it out to have a side-by-side comparison. I will create a new constant, which I'll name products stack navigator, just so that we don't have a name clash and that it's really obvious that this will hold a stack of pages, a stack of screens. And we do that with create stack navigator with this function, what I showed you before. This function takes no parameters anymore. Instead, I will create a new constant here, products navigator. So now we do have a name clash, but this will be removed anyways. And this is now a React component, a functional component. And we could therefore also store it in a separate file, just for this side-by-side comparison, and because we had everything in this file before, I will now set up all these navigator components with our navigation configuration here in this single file. Splitting it definitely is something you could consider. So here is our products navigator, and there I will now return products stack navigator dot navigator, as you learned, and in there products stack navigator dot screen. And we had 3 screens before, so I will replicate this 2 times so that we have 3 screens in there. Now we can configure them. Let's assign a name to the first screen, and that should be products overview. Now the component that should be loaded there is our products overview screen component. So basically what we mapped before as well. Now for the second screen, the name is product detail. So what we had here, and make sure you keep those names so that the entire navigation logic you have in your app, because that doesn't have to be changed, so that this still works. And here the component that should be loaded when we want to reach that screen is the product detail screen component, just as we had it down there. Let's reformat that. And for the last screen, the name is cart, what we had here, and we want to go to the cart screen, just like this. So now we set up this navigation stack with this new component-based logic. Now we can import it into the app navigator, and for that we just need to add an export keyword in front of it so that this constant, this component, gets exported here in this file. And in app navigator, we now don't import shop navigator, but we import the newly exported products navigator. We import that here, and in our navigation container, we can now add the products navigator like this. And we can get rid of that products overview screen import. Now back to the shop navigator. Let's have a look at those options next, the navigation options we had here on this stack. What do we do with that? Well, we actually have 2 options here on our products navigator, on the old navigator with the old logic. One is the icon this stack should have in the drawer, which we will add later. The second are our default navigation options, which should be applied to all screens that are part of this navigator. And actually, there then also is a third place where we configured things in the past, and that was inside of the screens. Let's have a look at our products overview screen. Whoops, in the shop folder. There, if we scroll down, we had this navigation options property we added to the products overview screen function object. And that was a function where we configured things like the header title, but also what's on the left and the right side of the header. Now, with this new logic, you don't do that like this anymore. Instead, we can copy this entire setup here. So all of that, we can copy it. We can comment it out here in the screen component and go to the app navigator component, the shop navigator component where we set up our stack navigation. And now on the screen where we want to have those options, we can add a third prop, and that's the options property. And 2 options, you can pass exactly what you had in the component before. So you pass a function, this is a function, right, which receives the nav data parameter, and which then returns a configuration object. The concrete value for this parameter will be fed in by React Navigation, and the configuration names we can set here, the things we can configure, haven't changed. So we still can set up a header title, a header left. So this all is exactly the same as you learned it. It works in exactly the same way, thankfully. Now we could do that here in Shop Navigator, but this of course would quickly become very, very large if we had all the different screen-specific configurations in here. So it's actually not what I will do here. Instead, I see 2 options. One is that we actually do our setup of the product's stack navigator screen in the screen component. The second is that we just keep our options there, and that's the approach I will follow. So back in products overview, I'll comment this back in. But now in here, we no longer set this function here as a value for the navigation options prop, but we simply export it as a constant. A constant which we have to give a name, and I'll name this screen options. Now screen options holds this function and we export it by its name. It does not clash with the component export because we do that with the default here. So now we export this configuration function, and in the shop navigator we can therefore import it. So besides importing the product's overview screen from that file, we can now also combine that with a named import where we import the screen options function. And then here, to options on this screen, I just pass a pointer at this function. Don't execute it, just point at it. Let React Navigation execute it for you so that it can feed in the concrete value for this nav data parameter this function wants. And with this screen is configured. Now if we save that, it clashes because we have this name clash down there. So in order to resolve this, let's make sure we also port the other options. Now the drawer specific option is something I'll have a look at later once we added a drawer. For the default navigation options, the good news are we can still apply those. We don't have to set up everything on a screen level if we have a shared configuration that affects all screens of a navigator. And how would you think we can set up such general options for all these three screens here? Well, we set them up directly on the navigator. There, we also have a little screen options property. So not named options, but screen options. But these are the options which will be applied to every screen here. And screen specific options will be merged with these general options, just as earlier in the course. Now here we pass our default nav options object. So this object up there, I just feed this as a value to screen options. And that's it. Now we can comment out this product's navigator here and save everything. Now once we do that, we still can't see the result because in this shop navigator file, we still got a lot of code that uses the old navigator or that old navigator logic, and that is causing a problem here. Now in order to still see a result, I will temporarily comment this all out, just temporarily, and save again so that this rebuilds. And you see we now get an error. Well, there is one thing we actually need to adjust in the product's overview component in our screen options there. Header left, this now needs to be a function here which returns our JSX markup, and the same for header right. So we need to convert both into functions, and you can simply do that by adding an empty parameter list and then the arrow here. Side note, you could accept the parameter here if you wanted to, and that would be props, because this actually is now a React component we're defining here. A concrete value for props will be fed in by React Navigation, and the values you can get from there can be found in the official docs. With this adjustment made, if we now save this, it now restarts here, and we now see that screen again, now definitely picking up our configuration. Keep in mind the drawer will not work because we haven't added drawer navigation yet. So, with all of that, we learned how we can configure our components, our screens, and the overall stack navigator with that new logic. With that done, it's time to keep on porting. Definitely feel free to do the next steps on your own and port the screen-specific options for the product detail and the card screen. And thereafter, we will move on to the next stack and then of course also soon to the drawer. So, let's keep on porting. For that, let's go to the product detail screen, and there we also have some options at the bottom, way shorter though. Here we can export this again as a constant named screen options, and that holds our function here then. And we do the same in the card screen. So on the card screen, if we scroll down, here we export our constant screen options. And here you see it's now actually not a function, but just an object. This, however, should also work. You don't necessarily need a function here. With that back in the shop navigator, let's add that here on this detail screen with the options prop, and also here on this screen. Now we need to import these options. So from product detail screen, we now also import screen options. And the problem we'll now face is that we now have a name clash. We got screen options here and here. We can fix this by assigning an alias and giving this the product detail screen options name, whatever name you prefer, and then do the same for the card screen here with the as keyword. Of course, here it should be the card screen options, and to be consistent, I'll do the same for the products overview screen. Here it'll now be the products overview screen options. So with these imports added, here I refer to the products overview screen options, here to the product detail screen options, and here to the card screen options. So with that, we got these options all set up. Now let's move on to the next navigator in line, which is the orders navigator. Just as before, I'll create a new constant, orders stack navigator, and call create stack navigator to create it, and then export a constant, orders navigator, which now actually holds a React component, just as we have it here in the products navigator, which returns our stack setup for this navigation stack. So here we have the orders stack navigator.navigator, which wraps all our screens that belong to the navigator. And therefore here we have a screen component inside, and we only have one screen in this stack, which has a name of orders, and where the orders component should be loaded, the orders screen component. Now we got some configuration here. Let's ignore the drawer icon, but regarding the default navigation options, we set those up on the stack navigator here with screen options, and we simply point at the default nav options. Now for the screen specific options, let's check out the orders screen. And there at the bottom, we again have our navigation options object. So we can export a constant here, screen options, which holds this function as a value. Now let's go back to the app navigator, to the shop navigator, and import that from the orders screen, the screen options, and give it an alias again to avoid name clashes. And that would be the orders screen options here. And let's assign those here. So now down here to this screen, we can feed in the options and use our orders screen options here. And that's this stack ported over. Now for the admin navigator here, it'll be pretty much the same. We got our admin stack navigator, which we create by calling create stack navigator. And then we export our admin navigator here, which is a React component, where we now return our admin stack navigator component, which wraps all the screens that belong to that stack. So here with .screen, we create those screens, and here we have two, user products and edit product. So first name is user products, the component there is the user products screen, and we can duplicate this to also have our edit product screen, where we load the edit product screen component eventually. Got a drawer icon, which we can ignore, and the default nav options, which we now add here with the screen options prop on the stack navigator, default nav options. And for the screen specific options, we again have a look at those screens. So in the user products screen at the bottom, we again export this here. Screen options is this function we have here at the bottom. And on the edit product screen, we do the very same. We go down there and export a constant screen options like this. Now here, by the way, we're still using params to have our submit function and to decide whether we're editing or adding. And that's something we'll adjust later, because now with React Navigation 5, we'll have a much nicer way of setting things in our screen-specific configuration dynamically. We will no longer have to abuse params for that. But first of all, let's go back to the shop navigator and import our options there. So from user product screen, we import screen options as user products screen options. And here we import screen options as added product screen options, just like this. So we got that imported. And now if we scroll down to our admin stack navigator, here we set up our options, the user products screen options, and here we got our added product screen options. And that's that. Next on, the drawer. So we work with the stack navigator. Now what about the drawer? The logic is exactly the same. We create our shop drawer navigator here by calling create drawer navigator. And just like the stack navigator, this function wants no argument. Instead, we'll set up our drawer navigation in a component-based approach. For that, I'll create a shop navigator here, and this will be a React component. Again, you could have that in a separate file. I'll keep it all in one file to have it side by side with the old code. And in there, we return shop drawer navigator dot navigator. Same logic as before. Doesn't matter that it's a drawer. And in there, we now have the different screens which can be loaded through the navigator. And React Navigation will automatically make sure that a navigator is created and we can open it with the exact same code we used before. We'll not have to adjust that. So here we now have our shop drawer navigator dot screen. And just as before, we give that screen a name. Here we had products, for example, and that name will then automatically be used inside of the drawer navigator, though you could also override all of that if you want to. And we need a component that is loaded when we click on that link in the navigator. And here, that's still the products navigator. So just as before, we can use our stack navigators, even though they're now using this component-based approach, as components that should be created as part of another navigator, in this case as part of the drawer navigator. We can still point at our stack navigators as components here, because they are components. This is a component, and the same is true for all other navigators we created here. They're all React components which hold their specific navigation logic as components. And the overall components, like the products navigator here, can be used in the drawer navigator. So I'll replicate this twice so that we can also add our orders here with the orders navigator and the admin here with the admin navigator. And make sure you have no errors in your names, because we're using them all over the app and that logic won't need to be adjusted. So if you mess up the names here, other parts of the app will not work. Okay, so now we got this drawer navigator set up. And now what about the configuration? Now there are two things we need to consider. For one, we have the configuration here for the drawer content. And second, we want to configure our different screens, like the products navigator or the orders navigator, to have their own icons in the drawer. Now let's start with the icons. Previously, we set up that icon directly in the configuration of the stack navigator, which we wanted to use in a drawer. Now, with the component-based approach, we don't do that anymore. Instead, we can just grab this part here, or actually this entire object, which we previously set up on the stack navigator, and go down to our drawer. And now here on this screen to which it belongs, so in this case it belonged to the admin navigator. So here on the admin screen, we again pass our options, just as we did a second ago on the stack navigator. So here we now pass the options for this screen, and this could be a normal component, or as it is in this case, a component with our stack navigation logic. And two options, we pass an object, and there we can reuse that object we used before, So an object with a drawer icon key where we have our icons and so on. So this all works just as before. One small adjustment, however, we now get props here as well, fed in by React Navigation. And these props will have a color key instead of drawer config active tint color. And the color will always be the right color because React Navigation behind the scenes will control whether this is the currently active screen or not, and it will adjust the value stored in that color prop to be either the highlighted or the non-highlighted color. So that's a tiny adjustment we have to make here. Well, and with that, we can copy the logic from the other navigators as well, like from the orders navigator. Let's grab this object here, which we had in its navigation options, go down to the drawer, to the orders screen, add the options key, pass in this object and comment it back in, and important, we now get props which will have that color key, just like this. And last but not least, let's of course also do that for the products screen, for the products navigator. Here we have this object. Let's grab it. Let's go down to our drawer navigator. And here's our products screen. Set up the options key here, paste it in, and adjust it as I just showed it. So now we have our screen specific configuration here, you could say. Now, what about the drawer overall? Because previously, in the app with the old React Navigation version, we actually had our drawer and we configured the active tint color and also the content of the drawer. Well, you can still do that with that new approach. We go to our drawer navigator, so where we set up the overall navigator, and we configure it via props, just as before. It's all about components and props. So here, we now, however, have a different naming. We no longer have a content options and content component. Instead, and you can find this in the official docs, we now have drawer content and drawer content options. However, the values are exactly the same in the end. So we can grab our content options object here and pass this into drawer content options here and comment it in. And for the drawer content, it's also almost the same. We just grab this component here up to here, copy this, and pass this here into drawer content and comment this in. However, now two important things. Use dispatch is not allowed here. You should do this outside of here. So for example, here in the shop navigator, not in this nested component. And in addition, it's no longer drawer items, but drawer item list, which we also need to import at the top from React Navigation /drawer. So here we import drawer item list. With that, however, if I scroll down, this should now be working again. And this should now be our working drawer. So we got the shop navigator, we got all these stack navigators. What's left now is that switch navigator, which basically renders either our startup screen or the off screen or the shop screen, or the respective navigation stacks, I should say. Well, that's what we'll work on next. So we're making good progress. We migrated all our navigators, or almost all. Now what about the switch navigator and the off navigator here? Well, we need the off navigator for sure. It's a stack navigator, which is responsible for the off screen. And what about the switch navigator? Well, we won't need the switch navigator anymore. There is no @React Navigation /switch package or anything like that. But I'll come back to that when we need it. So for now, let's create our auth navigator or our auth stack navigator here by calling create stack navigator and export our constant of navigator here, which in the end is a React component, just as before, where we return of stack navigator dot navigator, and in there we have our of stack navigator dot screen, and the name of the screen is off, as we have it here, and the component we need is off screen. So that's that. Now we got the default nav options here. So the screen options on the navigator should be the default nav options. And for the screen specific options, let's have a look at the off screen. And if we scroll to the bottom, we have some options here as well. So let's export our screen options here, just as we did it before. Let's export it and then go to the shop navigator here. And on that screen, let's set options to off screen options, which we now also have to add as an import. At the very top, from off screen, we import screen options as off screen options. So that's that. Now we also got the startup screen, but if we have a closer look, in the past we just pointed at that directly from inside our switch navigator, which leaves us with just one question. What about this switch navigator? Now in the past, this would have been the first screen you see once the app loaded, because it's the topmost, the first screen in this configuration. And then we had logic in that old navigation container we built earlier, where we checked whether we are authenticated, and if that was not true, if we were not authenticated, we would redirect the user to that off screen. Now, when would we reach the shop screen? Well, for that, let's have a look at the startup screen. There we see that we tried authenticating, and here we would go to the shop screen eventually when automatically logging us in succeeded. That was the logic we wrote there. Now, that's still some logic that makes a lot of sense. We just need to adjust it for the new navigation package. In the end, what we can see here is that in the startup screen, we're trying to log the user in, and if we can't find user data stored on the device, we go to the off page. If we find data but the token is expired or not there, we go to the off page. If we do succeed with everything though, and we have a valid token, then we instead go to the shop page and we dispatch an action where we authenticate the user, which changes data in our Redux store, which sets the token and so on. Initially, that token in our store is null. Now, we can use that. What if we get rid of all these navigate calls here? So we can delete them or just comment them out as I'm doing it here. So we get rid of all these navigation actions. Instead, what happens if we return here? Well, if we return here, then this function execution stops in the end, right? It stops, and what we definitely don't do is we definitely don't dispatch this action. So we definitely don't set the token to anything. It's still null. That's always happening here. Unless we make it to the bottom, in which case we do have a token, we dispatch this, and the token is not null thereafter in our store. So that token which we manage with Redux is either null or it holds a value. Now I want to adjust the Redux store a bit, the off part of it in the off reducer, and I'll add a new piece of data to this state, and that is the did try auto login key. You can name it however you want, and I'll set it to false initially. Here I want to store whether we tried logging the user in or not. Now, if we authenticate, so if we dispatch an action with that identifier, then I will set did try auto login to true. I will also add a new action here in actions auth. And for that, I'll add a new identifier up here, which I'll name set did try AL for auto login, set did try AL, and create an action creator for that, set did try AL, which takes no arguments, and where I then return my action object, where the type is just set did try al. You could also put it at the bottom of the file, doesn't matter. Now, why am I doing that? You'll see it in a second. Let's go back to the reducer, the auth reducer, and handle this new case. The case set did try al. Make sure you also import this from actions auth. Now in here we return a new piece of state where I copy the old state and where I set did try auto login to true. So the token might still be null, I just set this to true. Now my idea is that I dispatch this action here in the startup screen in all scenarios where we previously went to the off screen. So where we tried logging in, but where we didn't succeed. So here I will dispatch set did try al. So make sure you access this on the off actions, just like this, and do it in these two cases where we previously navigated to the off screen. So now we have this new field in Redux, and why am I doing that? Why is this helpful? Well, because with React Navigation 5 there is no switch navigator anymore, because we don't need it anymore. Since we now manage our entire route setup via components, we can just dynamically render components to have them have an effect or not render them. So in the app navigator, where I render my products navigator, it's now time to add all these navigators we configured and then decide which navigator should be rendered when. So from the shop navigator, I now actually want to import this shop navigator here, which I'll export as a constant again. And then here in App Navigator, I import Shop Navigator. That's our drawer navigator, keep that in mind. And that's what I want to render here, Shop Navigator. So this is basically what I want to render if we are logged in. That's our shop, right? Previously, that is what we mapped to this shop key in the switch navigator. Now we also need the auth navigator and the startup screen. So here in App Navigator, I'll import the auth navigator. And these are the only two navigators I need to import here. Hence, you could remove the export statement on all the other navigators here in our shop navigator file. But what we'll also need to import into App Navigator is the startup screen now. So let's import startup screen from screens, startup screen. And now here we have the shop navigator, we have the auth navigator as an alternative, and we also have the startup screen. Now we'll only render one of the three. And this is where we can now reuse Redux. I'll copy use selector because besides the information about the token, I'm also interested in learning about the did try auto login field, which I added to the auth state here. This new field I added. I now get access to this here in my app navigator file and store it in a did try auto login constant. Now I know I want to render the shop if isAuth is true. And this is how we can do that. If we are authenticated, I always render the shop. I don't care about anything else. Now I want to render the auth navigator if isAuth is false and we did try auto login yet. Because if we haven't tried logging in automatically, then I actually want to render the startup screen. So if we're not authenticated and we did not try our auto login yet, well, then we don't know whether the user might be authenticated or not. So in that case, I want to render the startup screen. Now, I quickly want to pause there and make sure we're all on the same page and we all understand why we're now using this instead of the switch navigator. Now, first of all, there is no switch navigator anymore in React Navigation 5. But why was it removed? Well, since we now configure everything with components, we can use regular React tools to either render a component or not. If you're not thinking about navigation, but a normal screen where you maybe have a text which you only want to show conditionally, then you would use some state, and then in JSX you would only sometimes render the text with a ternary expression, for example. And we're doing the same here with our route configuration, with our screen configurations here. The screen configuration setup we have here, our different navigators and the startup screen, these are in the end all just things that React should be aware of to bring something onto the screen. And React Navigation behind the scenes does the heavy lifting of interpreting our configuration and making sure that the correct component gets rendered on the screen. Now, if we use isOff and did try auto login to control which navigator is actually renderable by React by using such a ternary expression, then we ensure that if, for example, isOff is not true, there is no way that shop navigator screens can be brought to the screen. Why? Because the shop navigator component, which holds our shop-related route configuration, our screen configuration, that component is only rendered if isOff is true. So there's no way for a shop-related screen to be rendered to the screen if isOff is false. Really make that comparison to normal text elements or normal boxes on a screen, which you render conditionally. We're doing the same here, but not with boxes and text, but instead with our entire navigation stack. That's what we do here. And with all that, if we save this and we rerun this on Android, we end up on the off screen. And if I reload this and it rebuilds, we again end up there. Now, if I do try to log in here, I now actually get a problem here. I get an error that navigate with a payload of shop was not handled. Well, this now makes sense if you think about it. We got no switch navigator anymore. Instead, we just control which navigator we want to render under which circumstances. So, why are we getting this? Can you figure it out and fix it on your own? Otherwise, we'll do it together. We'll fix it together in the next lecture. So why are we getting this error here? Well, we're trying to navigate to a route or to a screen named shop. Now we had that in the past here in our switch navigator. There we had the shop screen. But now we have a different logic for rendering this navigator and all the screens and sub-navigators that belong to it. So let's actually go to the place where we triggered this navigation action. And that's actually on the off screen. There, if I search for navigate, you see here's our navigation action. I dispatch my action, but I also navigate. We shouldn't navigate anymore. Dispatching is enough because this will set a token, set us to authenticated, and if we are authenticated, well, then we render the proper navigator. So if we now save this, it restarted, and you actually can already see that it seems to have worked. If I now reload this entire application here, I again am logged in automatically. Now if I do log out here, I get an error, so we should fix that as well. And for this, let's actually go to our shop navigator again, and there to the drawer where we render that logout button. Here it is. And there we're dispatching this logout action. This logout action here in the actions file triggers this action here in the reducer with the logout identifier. And there I set my initial state. And that might be the problem here. Let's actually not set it like this, but set the initial state, but set did try auto login to true. We didn't really try it, but since we logged out deliberately, we know that trying it won't make any sense, right? Because we can't log in automatically, we just logged out. So let's save this and wait for this to reload. And let's give it another try. Let's try logging in here. That works. And let's try logging out. And we're getting that regarding the will focus sub remove function, which is not a function. And in the products overview screen, indeed, I am checking whether this screen is getting focused or not, and I remove this subscription. Now for one, there is no will focus event anymore. There's just focus and blur. There is no will focus, will blur, did blur, just focus and blur. So here we want focus. In addition, what we get back is now not a subscription where we have to call remove, but instead a function itself, the unsubscribe function you could say, which you just have to execute to clear that subscription. And with that, we're done. If we now save this and we reload this application, if I click on logout, I'm logged out. And if I try to log back in here, this also works. So this is all working fine now. Now we can also go to the cart, as you see. We can go to the other pages and oh, no we can't. If I try to go to orders, I get an error. That, however, is a problem related to a problem we fixed earlier already. In the options down there, I said that header left and so on, these need to be functions. So let's turn this into a function. And whilst we're there, we can already scan the other files, product, detail, cart, that's looking good. Added product here, header right should become a function. Header left does not exist here. User products screen, header left should be a function. Header right should be a function. And on the off screen, we have no options here, which need a function. So that's working. If we now save this again and reload this page here, we should be able to go to the orders and to the admin screen and there also to the add screen. And now we got another error. Nav data navigation get param is not a function. And I mentioned this earlier. When it comes to params, some things changed a bit. So let's see what changed there and how we now use params and how we now don't need this strange workaround here anymore to abuse params to set stuff in our header. So when we visit our admin area and we then want to add a new product, we get this error here. We get this error that getParam is not a function. And indeed, with React Navigation 5, getParam, this function you would use to get the parameters for a given navigation action, was removed. So let's see what else we can do. For that, let's go to the Edit Product screen, which is the screen we're trying to visit, which fails here. And we certainly use getParam here, but also here in the main Edit Product screen component. Now, with React Navigation 5, there is no getParam function anymore. Instead, there now is a new prop besides that navigation prop, which you also still have to do certain actions like navigate away. But you got a new prop available now, which is the route prop. This wasn't available before, now it does exist. Now, on this route prop, you'll have a params key, just named params, not getParams, it's not a function, it's just a key named params, which holds an object with all your params you're receiving as key value pairs. So here, we can then conveniently extract the param we want to get. So before, I wanted to get the product ID param, so now we access props, route, params, product ID, and this should work. Now, depending on your application, you might not always be getting a value for this parameter, so sometimes it might be undefined, and for that reason, you could of course also check whether this is null or whether this is undefined before you try to use it. Now, when it comes to set params, which we're also using here in this component, here, this still exists, but for the reason we're using it here, we don't need to use it anymore. Here, we were using it as a workaround to basically get data from our component body, so from inside our component function, into the navigation options down there, right? The submit function, and also here, our product ID. We were extracting that data like this. Now, actually, for the product ID, that's fine because that's a general route-specific piece of information which we're interested in. And we can still extract it like this, but getting the function from our component to the navigation options as we did before, that was really a bit hacky and not really how we want to do that. Now, for the moment, however, I will keep the same approach as before, but one thing needs to change. We don't have getParam anymore. Instead, navData is an object which also has this new route prop, this new route object, so we can access navData.route.params.submit and get the submit function like this, and the same down there. Here we have .route.params.productID like this. With that all out of the way, if we now save this rebuilds here. And with it being rebuilt, if we now go to admin again and click on this icon, I get an error that undefined is not an object when it tried to evaluate navData route params submit. So what's wrong there? The problem we're facing here is that params isn't always defined. If this screen gets loaded without any params, as it is the case when we're in the add product mode, which we are if we just clicked on that button in the top right corner. So if there are no params passed to the screen, then this entire params key here holds undefined as a value. It does not hold an empty object without params. It itself is undefined instead. So that's important to keep in mind. Params itself will be undefined if there are no params. And if we're opening this screen in order to add a product, indeed there are no params initially. This submit param isn't set initially because that's only done from inside the component, so after the screen has been loaded. And product ID definitely isn't set because we're not editing but adding, so there is no product ID fed into this screen when we navigate to it. So how do we make sure we're not getting an error then? Well, we simply have to check whether params itself is defined or not. And we could do this down here by rewriting this so that we first try to access params, and then we use this as a condition in a ternary expression and say if that is truthy, which it is only if it is defined. So if it is truthy, then we want to try to access params submit, because then we know that params at least is not undefined, and otherwise we'll set submit function to null, let's say. And we can repeat this down there too for the header title. Now, we already have a ternary expression here. We can nest those expressions, but to make it a bit more readable, I'll split this across multiple lines, and I will have my route params here, where I basically check if navData route params is a thing. If it is, then I'll store the params in this route params constant. Otherwise, I'll set this to an empty object, let's say. Now, by doing this, we can use route params here, and now this either is an empty object, in which case we can access product ID without an error, but will get undefined as a result, hence will be in add product mode. Or if params is found, then I'll set the actual params object as a value for route params, and we then access this actual params object down there. So in either case, this shouldn't fail. And we can do something similar in the component, of course. There we also try to access our params, so here we should also check whether this is actually truthy, if it is defined, and if it is, then we access the params, and otherwise product ID is set to null. So this is one way how you could work around this, and if we now save this and reload this application, we can go to the admin screen, click this button, and load this screen here successfully in order to add a product. Now I'll quickly test this with a book, enter the image URL here, and a price here, and a test book description here. And with that, I can submit this, and this generally works. Here is our book. If I now click on edit, we load this edit screen with the book data. So that all looks good. And if I delete it, well, that does not work. I get an error here. We'll have to look into that, but at least it now works correctly when it comes to the params. However, I did mention that there is one thing we can improve about route params if we have a case like this here with the submit function where we abuse params to get data from the component body to our navigation options. Because with React Navigation 5, we now have a nicer way of achieving this. So how can we now actually set our options here in a nicer way and avoid a workaround like we're having it here? Previously, we needed to abuse params to get data from our component, so that changed in our component, into the navigation options. With React Navigation 5, that's no longer needed. In this scenario here, we have the submit function, and we want to pass a different submit function to our options here. Now, we did this by setting params here and setting the submit param to our submit handler. And the submit handler was this function here, which would be updated whenever our form state changed, for example. Well, now we don't need to do this with set params anymore. Instead, what we can now do is we can use a new function called set options. Still on the navigation prop, that does not change, but this set options function here is new. And this allows us to set new options dynamically from inside the component. So what can we do here? Well, we feed an object into set options, and now here we can dynamically adjust our options. So in this case, I can get rid of this line here where we extract the submit function in our screen options, and instead go to the place where we use it, which is the header right option. And now we can grab the header right configuration here from the screen options and go into the component here where I set the options and set it there instead. So now I set my header right option here from inside the component. And the cool thing is here I can now refer to that submit handler function. And since this is in use effect, whenever that handler changes, we'll reset that option. So if we now save that and we reload our application and we go to the admin area and I click on add here, you see this works without an error. And if I try adding my book here again, for this price, test book, you see, this now works. I'm getting a key error here, which I'll have to look into, but generally this works. And it worked without errors. Now, what's not working here is my all products page. I briefly see my product here, but then I get an error again. So we can look into this, but besides that, this now works, and using params now works, and we now don't have to use params for things that don't really have something to do with params, right? Params should only be for transporting data from screen A to B when navigating, and not from inside a screen. With set options, we can now update our options dynamically without abusing params. Now that we learned how to work with params, let's go to another place where we need params. That's the product details screen. There, I'm also getting params to get the product title. And here again, we can do that not with navigation get params, but with route.params.product title. Now we can try it like this because on this page here, on this screen, params should actually never be undefined because we always reach this screen with a params set. And therefore, we can try it like this and see whether it works. It should work. Now, let's see if we have get params somewhere else. Yes, we do. So here, as well, we access the route prop, params, and then product ID. Now, if we save all of that, and we reload this application, we still have that error here on the starting screen. On the admin page, the product also is gone, so we'll have to look into that. But for the moment, when we create a new product again, like this, test book, and we submit this, we got it here, and that looks good. I can click on it and edit it. Now, however, to see whether we can view the detail screen, we need to make sure we can load it here on all products. So let's see which problem we're facing there. Why this is not loading. And for me, the problem actually just was that I set up a new Firebase backend here, and I forgot to unlock access for authenticated users. So I did that now off screen, and once I did that, it should now also be working again. So if I now try to add this, this works. Now the key error is also gone because now a key is generated on the backend and we're using that here. And now if I go to the product screen, I also see my product there. Now if I click on it, we can also go to the detail page without errors. If I click add to cart, we should have it in the cart, hopefully. There it is. If I click order now, that's empty. Let's check orders. And here's our order where we can view the details. So this is now all looking pretty good to me. Let's try log out again. Yep. And with that, I think we successfully migrated this to React Navigation 5. Let's also try it on iOS. And then in the next lecture, I'll sum up the important changes and where you can learn more. So here we're logging in on iOS. I can view the details. I can add it to the cart. I can view my cart here. I can go to orders, to admin. I can delete it there. That's looking good. Back to products. Cart is empty now. So that also looks good to me on iOS. So we spent quite some time on migrating this to React Navigation 5 now, and maybe it looks a bit overwhelming right now. So let me sum up the key changes we made here and the key changes, the key differences React Navigation 5 introduced. The biggest change is how we set up our screen configuration. Instead of having this registry-like approach, we now use components to set up our configuration. But the pattern here is actually quite simple. You always create a navigator that could be a stack navigator, a drawer navigator, or also a tab navigator. And then you use that navigator, this navigator component here, as a root component for this set of screens that belongs to this navigator. The screens are then nested components in there, and there you provide a name and the component that should be loaded for that screen. Now, when it comes to navigating, you still navigate with the navigation prop and then the navigate function by identifying the screen by name. So that does not change at all. You also still pass params as before. The only important thing here, or the one thing you should keep in mind, is that the name you use here, of course, should be the name you also use here when you set up your screens. So that's the biggest change, that you set up your configuration as components. Ultimately, you then can still nest your different navigators into each other, as we're doing it here, where we have the drawer navigator, which also has stack navigators as screens. That also doesn't change, it just looks different now. And what changed is where you configure things. Screen-wide configuration options, so options that affect all screens of a navigator, are set up directly on the navigator component with the screen options prop. And screen-specific configuration is set up with the options prop on the screen component. Now, where you manage that configuration, if you do it all in one big file, or as we're doing it here, if you're doing it in the screen and you then just export it so that you can use it when setting up the components, is up to you. Now, that's all you need to keep in mind there. One thing that did change because of that is how you handle authentication or related cases. You don't have the switch navigator anymore. Instead, you control which navigators should be rendered by React, and what's not rendered can't be effective, can't do anything. So if we don't render the shop navigator because we're not authenticated, then there is no way a shop screen can be loaded. That's how we now control which screens are accessible here at the example of authentication, also keeping auto login in mind. So that's something where you have to switch to a new mental model. This is much more React-ish than what we had to use before though. And then we have one other big or important change, and that is how we extract params and when we need params. We extract params on this new route prop with the params key. The params key can be undefined if there are no params received in this component. And params should now really only be used to get data from component A to component B, so from screen A to screen B. Hacky workarounds as we needed to use them before in the added product screen, are not needed anymore. If you needed to use params to get data from inside the component into your screen options, you don't need to do that anymore. Instead, what you do now is you use the new setOptions function, which you can call directly on your navigation prop. Here it is. So we call setOptions on this navigation prop, and then we can dynamically adjust the navigation options from inside the component. These are the key changes we had to make here and the key things that changed. Now, as always, the official docs are your friend if you want to read about that again, if you want to dive into some other cases which we haven't covered here. For example, if you want to learn how to work with tabs, we're not doing this here, but the approach is very similar. You do it with a component-based configuration with a navigator and screens. And then the official docs are a really great place to dive into. Also check out the announcement post for React Navigation 5 and the upgrade guide, which is also linked there. You find all these resources also attached to this lecture. And with that, it's up to you whether you want to use React Navigation 3 or 4, or if you want to switch to 5 or later once we have new versions. It's up to you. The majority of projects out there in the wild will certainly still use version 3 and 4 because these versions have been around for so long. New projects might switch to version 5, but might also still use the older version. So I would argue that it's important to know both kinds of navigation. If you're working on your own project on your own, I would recommend that you switch to React Navigation 5 right from the start. But if you like 4 or 3 better, that's perfectly fine as well. React Navigation 3 and 4 is fully stable and also will be maintained and updated in the future by the React Navigation team. So it's not going anywhere, it's not insecure to use it, and it's up to you which version you want to use. A feature which you actually need in quite a lot of applications is push notifications, or showing notifications in general to your users. And therefore, that is exactly what I will show you step by step in detail in this module. To be precise, we'll have a look at what kind of notifications we have, because it turns out that it's not just push notifications. We'll then work with the first type of notifications, which would be local notifications, and I will show you how to trigger those and how to handle those. And once we got that, and we will need that for the push notifications, we will dive into triggering and handling push notifications. Now, I will do all of that in a very trivial and simple dummy application so that we can really focus on just the notification part and so that you can understand how that works. But thereafter, I will also show you how you could integrate push notifications into the shop app we built earlier in the course. And with that, let's not waste any time and let's dive right into notifications. As I mentioned, there are basically two types of notifications, and that would be local notifications and push notifications. Now, the two types are related, as you will see, but it is important to understand that we generally have these two types. Now, what are local notifications? Local notifications are notifications that are scheduled and triggered and handled on one and the same device. So they are triggered by the app and displayed locally to the user. They never leave the device. Local notifications are never sent or shown to other users or other devices. They stay on your device. Now, you might wonder when this could be useful. Why would an app send a notification to itself? Well, here's an example you probably all know. A reminder app. If users use a reminder app, it is quite common that you can set like a deadline or simply a date and time when you want to be reminded. And that can be achieved with local notifications, for example. There, you don't really need a server or a backend or any other users. You just want to remind yourself, and therefore, of course, a local notification should be triggered so that even if the app is closed, that feature still works and you get this reminder. I mean, that's the whole idea of this app there. And a reminder app is just one example. You will notice that many apps on your device send you local notifications from time to time, reminders that you should use them again, or anything like that. Now we also have push notifications though. These are notifications which are not triggered by the app for itself, but which are received by the app, sent by someone else. And I will of course show you how to send a push notification in this module. Now when a push notification is received, that in turn then shows such a local notification. So that's the connection we have. But a push notification is sent by someone else, by a server, by another user, by some interaction in an app on another device. A push notification is not triggered by your local app installation, but instead it is received from outside your device, so to say. So push notifications are notifications that are sent remotely to one or many users and devices, and they then show up on those devices to lead those users to do something. For example, open the app. Examples here, of course, would be chat apps, email apps, where maybe you as the seller of an item get a notification if someone ordered an item. So there are plenty of applications out there where something happens and a push notification should be sent. In addition to such triggers that would happen inside of an app, we could also have marketing push notifications where all users of an app get a marketing push notification sent by the developer of the app. Now, as I mentioned, we'll have a look at sending push notifications later. I want to start with local notifications. Now for that, I got a brand new project here, again created with Expo init using the managed Expo workflow. At the end of the module, I will also link to resources that help you get started with push notifications in non-Expo apps, but I will say that it's way easier with Expo. So I absolutely recommend using that, and that's why I'm showing it here, because it is super easy to send notifications with Expo, as you will see. So here's this brand new unchanged app running on Android and iOS. And to start with local notifications, we first of all need to install a new package. With Expo install, we should install the expo-notifications package. Simply hit enter and this will download and install this into your project. Now once that is done, we're ready to write some code. Now here, as I said, I want to keep this very, very simple. So I will simply display a button in this application here. The built-in React Native button will do. Set a title of trigger notification. And when we click the button, I want to do what the title implies. I want to trigger a local notification. Now this button is automatically centered by default, which is quite nice. That's exactly what I want. And now here I can register a new function, the trigger notification handler function here, which is a default arrow function which we bind to press on this button like this. And in here we now, guess what? Want to trigger a local notification. For that we need to import from Expo notifications, and actually we want to import everything as notifications, for example, from Expo notifications. Of course, you can name this however you want. Now with this imported here in this trigger notification handler function, we can use this imported notifications object, and there we will have a bunch of methods. And one method is the schedule notification async method. This is the method that will help us, well, schedule a notification. And with that, we always schedule a local notification. Again, later I will show you how you send a push notification. With this method, you always create a local notification. Now, this method wants an object where you configure the notification that should be sent. And as you can see, we got 3 basic options we can set here. The content of the notification, I'll come back to that. The trigger, which will simply define when the notification should be displayed. And an identifier, which we could use to cancel this notification in case we, well, don't want to display it after it was scheduled. We don't necessarily need the identifier here, and therefore I'll start with the content. The content itself is an object where you got various options. Now, not all options are supported on both platforms, but you can set them all, and if a platform doesn't support it, it will simply ignore it. What you can set on all platforms is the title, where I will write my first local notification, and the body of the notification. This is the first local notification we are sending. So simply 2 strings. Now, as you see, you could set more. You could set a color, for example. You could add extra metadata, which you later can retrieve when the notification fired. You can give it a priority, which might lead the operating system to display it with higher priority. You can add a sound, but I will keep it fairly basic here and just send this basic notification. You can, of course, play around with the other options as well and send a more complex push notification. Now, that's the content. We also need the trigger. The trigger is also an object where you simply define when the notification should be sent. And there you got a couple of nice properties that you can set. For example, you can set the seconds until the notification should be displayed. And I'll set this to 10 seconds here. Well, and that's our scheduled notification. Let's see whether that works. For that, I saved this. And after killing the app here and completely restarting it on Android, I will press the button there once the app finished loading. And now with the app loaded, I will press this trigger notification button. Now, what we'll notice is that after 10 seconds, nothing happens. We don't have any new notification here. This has nothing to do with the notification we scheduled, and we saw nothing else. Well, there are a couple of reasons. For Android, we need to do one extra thing in the app.json file. There, we need to add the Android entry. And on Android, you want to set the use next notifications API to true. Save that, and then it might be best if you simply restart your Expo server with Expo start so that this new configuration is taken into account. And thereafter, to be super safe, I will simply kill those apps here, starting with Android, and I'll simply rerun it. But that will not be the only thing we have to do. And now that this restarted, let's click the button again. But as I said, this will not be the only thing we need to change, and therefore still you will see nothing. If I expand this, I see no notification here. Well, there is a reason for that. If your app is in the foreground, so if it's currently running as it is here, local notifications by default are not shown. Now, therefore, if I click this again and now I go to my home screen, so that the app is no longer in the foreground and it's no longer running, but instead it's in the background, you now see this My First Local Notification pop up here. Now, if you click it, we're taken back to our application. Now, we're not doing anything in the application upon this notification yet, but at least we saw that we were able to create a local notification. Now, what about iOS? Let me start the app there again as well. And let's try the same thing here. If I click on trigger notification and I go to the home screen, let's see whether we get a notification after 10 seconds there. I can tell you that we don't need to set anything up in the app.json file for iOS. But still, I don't see any notification here. We definitely have no new notification here. Well, there is an important difference between Android and iOS here. On Android, it works just like that out of the box. On iOS, you need to grant explicit permissions to receive notifications. So let's do that next. So in order to also get local notifications on iOS, we need to ask the user for permission. And for this, we can use another package which we also install with Expo install, and that's the Expo permissions package. The Expo permissions package, as the name implies, helps us manage permissions. It helps us request permissions and work with permissions. So once this is installed in app.js, or in any other file where you want to get those permissions, but here we only have this one component, we simply import everything as permissions from Expo permissions, just like that. And with this imported, we need to ask the user for permission to show notifications before we try doing that. Now, it depends on your application when you want to ask the user. Maybe you want to ask when the app starts up. Maybe a better point of time is better. After all, you want to ask for permissions when it's very likely that the user gives you the permission, right? Now here we'll do it right when the app starts up. So I will actually import the useEffect hook here from React so that we can run logic when this component mounts, simply by passing an empty dependencies array here. And in there, I now want to use this permissions object, which we imported here, to first of all check the permission status, and thereafter, if we don't have permission, to ask for it. So therefore here we can call getAsync to first of all check the current permission status. We now need to specify for which permission we want to get that information, and we can therefore access permissions.notifications, whoops, all caps though, to check how the current permissions status is for notification permissions. On Android, this will do nothing. On iOS, it will find out whether we already are allowed to send permissions. Now, this is an async task, and therefore it gives us a promise. Hence, we can use then here to proceed. Now, in here, we'll get the status of that permission. So we'll get the information whether we do have permission to send notifications or not. Now we can check which status we got. There are a couple of possible values here, but in the end, we're interested in the granted status. If we got that granted status, we don't need to continue. But if we don't have the granted status yet, we want to ask for permission, because we haven't been granted those permissions before. So now we can use the permissions object again, but this time we call askAsync. Before we checked the status, now we're asking for a new permission, because now we know that we don't yet have the permission which we need. So now here we again access permissions.notifications, and now this will ask for getting that permission. This will return a promise, so we can overall return it here to stay in this promise chain, which we started here. And therefore now here we can again use then. You could also use async await, but in useEffect you shouldn't make this function async. Instead, you would have to wrap this into a new function which you immediately execute, just as a side note. But here I will use good old then catch, and will reach the function in this then block after askAsync finished. Now again, here we'll get the status, because of course, just because we're asking does not mean that we're getting the permission. So the user might still deny the permission, and in this case, there's nothing we can do. So now we want to check this status and find out if it's still not granted. And if that is the case, then, well, as I said, there's nothing we can do. So here we can just return. We might show a message to the user. We might show an alert that we now can't send any notifications, but in the end, there's nothing we can do here. If the status is granted though, then we're good. Now, either way, we can definitely schedule a notification, because the worst case scenario is that we don't have permissions and therefore nothing happens. But now that we're asking, the best case scenario is that we did get the permission and therefore this here will succeed. Now actually I have to step in here. This code has an error. We don't get the status string like this here. Instead we get the status object, which then has a status property. And the same is the case here. We just didn't get an error before because even though our code technically didn't work, we did request the permission still. But now this properly checks whether we have the permission. And in addition, we also have to adjust it in one other place. Here, if we already did have the permission, we of course will get granted as a response here, hopefully, and will not ask again. That means that in the next then block we have a problem though, because there we now expect to get our status object, but since we didn't ask again, because we didn't need to, we'll not get that object here. So accessing status will fail and will think that we didn't get the permission even though we have it. So here we should return status object in that first then block, so that in the next then block it is available for the cases where we already had permission. This is a change you should implement to ensure that your application properly detects its notification permission status and does not think it doesn't have permissions when it actually has them. So let's now save this. And make sure to restart that on your iPhone simulator. And now, right at the start, I'm asked whether I want to grant this permission because of that code we just added. And if we now click allow here and trigger the notification and close the application, let's see if that now works here on iOS. Let's wait for the 10 seconds to go by. And here's our first local notification sent by our app. And now we got that working on both iOS and Android. And just as on Android, if we click on the notification here, we can open our app. So that's working. Now, one thing that did not work, or where nothing happened, was when the app is in the foreground. Now, in some cases, that is the behavior you want. In some cases, if the app is open, not showing the notification might be absolutely fine. But if I come back to the reminder app example, just because it's in the foreground might not mean that you don't want to let the user know that some task is due. So therefore, let me next show you how you can handle notifications if the app is in the foreground. So what can we do if we get a notification whilst the app is running? Currently, as you saw, the notification is lost, and sometimes that might be what you want, but sometimes that's also not what you want. Well, for that, we can again use the notifications package, because there we can actually define what should happen if we get a notification whilst the app is running. For that, we can use it outside of our component, just here in a JavaScript file, which is guaranteed to be executed. And there we can set a notification handler. Now this wants an object, and in that object we in the end define how incoming notifications should be handled if the app is running. For that we got this handle notification property, which we can set here, and that wants a function that should execute. And this function, and that's important, must return an object which in the end tells the operating system what should happen when a notification is received whilst the app is running. So this function is not executed if we get a notification and the user taps on it or anything like that. This is instead executed to let the operating system know what it should do with that incoming notification before it's even displayed to the user. So here we return an object that describes the desired behavior to the operating system. And it is worth noting that actually you should not return the object like this, but you should return a promise. And a simple way of returning a promise that yields that object eventually is to turn this into an async function. Now that function here is guaranteed to return a promise, and what you return in the function is the value that promise will eventually yield. And now in that object you got a couple of options. For example, you can let the operating system know whether it should play the default notification sound, whether it should set a badge to let the user know that something happened, whether it should show an alert. And here I will set should show alert to true. And this tells the operating system that it should show this default alert, which it also shows if the app is closed, but now that it should show it when the app is running. So now let's save that, and let's trigger another notification on Android. And what we'll see is that after 10 seconds, even though the app is running, we see our notification here. Here I even got a sound then as a default, but of course we could have disabled that with the should play sound option here. Now let's also test it on iOS, of course. So there, let's click trigger notification. And let's see what happens there once the 10 seconds are up. And we see our notification here as well. So that's great. Now we know how we can control how notifications are displayed. Another thing we typically want to do with notifications is that we want to react to when the user tapped on them, so that we're able to do something with the interaction of the user. So that will be the next step. So now it would be nice to not just show a notification to the user, but to actually do something in our code when such a notification is received or when the user taps on it. Because often that is what you want to do. If a chat application sends a notification and the user taps on it, typically you want to take the user to that chat the notification belongs to. And therefore, here in our dummy app, we can also do something when a notification is received. And for that, we have another feature provided by that notifications package. I will register another use effect here, simply to keep the code organized. Technically, we could use the same use effect, because here I have another function that should only run when that component here is mounted for the first time. And here we can now use that notifications object, which we imported, and on it, we can call add notification received listener. This is a method that allows us to define code, that allows us to define a function in the end that should be executed when an incoming notification is received and, important, the app is running. So here we then get the notification, and for the moment we can simply console log the notification here to see what's inside it. And now here, add notification received listener actually returns some data to us. It gives us a subscription, because of course this method sets up an ongoing subscription. For every incoming notification, this function here, this function, will be triggered. Now that's nice, but sometimes you want to stop doing that, especially if you had a bigger application with more components and more screens. If you set up this subscription on some screen in your app, you definitely want to clear it if the user navigates away and the screen component is unmounted. And this subscription here allows you to do that. It allows you to unsubscribe. Now, since we're in use effect, we can simply return a function here, and that will be a cleanup function, which is executed automatically by React whenever this effect is about to run again, or when the component is unmounted, which is exactly what we want here. And in this cleanup function, we can then call subscription.remove. And this will clear this subscription and avoid memory leaks or unwanted behaviors. And with that, we got all we need to handle our incoming notification if, and that's important, the app is running. So back here, let's click trigger notification in Android, and let's wait for that notification to appear. and see what happens thereafter. So here's the notification. And now here in the terminal, we see the console log for Android. And there we can see that this is the notification object, which I in the end logged here. And we see the content of the notification, the body we set, the title we set. If we would have added extra metadata, we could extract that as well, and so on. And this, of course, is very powerful because whatever kind of application you are building, you can add the data you need, especially with this extra data object, which can be any data of your choice. For example, my special data, which is just some text or a number or whatever you want. And then you can parse that data and that incoming notification in this notification listener and then react to it in your app. You could, for example, then navigate to a different screen. You could show an alert, a modal. You can do whatever you need to do upon such an incoming notification. But of course here, that's just a local notification when the app is running in the foreground. So therefore, let's now also see how we can react to a tap of the user on that notification if the app was closed. So let's now make sure we can also react to a notification if the app was closed. And for this notifications package, this one here, simply has another useful method. So again, in useEffect, and here I'll use the same effect as I did for handling incoming notifications if the app was open. We can also call another method on the notifications object here. And that would be the add notification response received listener. This now allows you to define a function that should run when a user interacted with a notification whilst the app was not running. So when a user taps on a notification. Here we get a response object, and we can console log that response to see what's inside of it. Now, just as before, here we also get a subscription, and now to avoid a name clash, I'll name this background subscription, and I'll name this foreground subscription, but of course those names are up to you. And then here in the cleanup function, we want to clean up both the background subscription as well as the foreground subscription, of course. And you see those APIs are very similar. We work with them in the same way. We get different data though. Here we get the notification. Here we get a response object. Well, let's look into this and see what's inside of that response. So for that, again, I'll trigger the notification on Android. Actually, I'll first of all clear those old notifications. Then I will trigger it, and now I'll put the app in background mode. So I'm back on the home screen, and now we can wait for the notification to arrive. Here it is. Let's tap on it. This opens the app. And now here in the terminal, we got a new output. Down here it is. This is now that response object. And actually it's almost the same as the notification we got before. It's just an object that holds the notification, but it also gives us this action identifier, which we can actually ignore here. Instead, we see we have a notification key, and there we'll again be able to get the data, the body, the title, and whatever we need. We even get information about why the notification occurred now. For example, that it simply had a timer for 10 seconds. So that's pretty neat. Let's also test this on iOS, and therefore I'll run this on iOS and make sure that I have the iOS console here. And now let me trigger the notification, put the app in background mode, and let's wait for the notification. Let's wait for it to arrive, and once it's there, we'll tap on it here on iOS as well. This opens the app, and now here we also got an output on iOS. We got an object here with notification data, just as on Android. Now what you'll see is that some data fields differ because it's iOS, but generally your data is here with your special data, your title is here, your body is here, so you can drill into this notification there into the request, into the content, just as on Android, and then into the body, data, or whatever you need. And that's how you can handle notifications when they arrive when your app is not running. And again, here, instead of console logging, you can of course do whatever you need to do. Navigate to a different screen, send a HTTP request to a server, log the user out, do what you want to do in your app. It's your app, you're running this inside of UseEffect, inside of a component, so you can do what you can always do in components. There are basically no limits. So now we know how to trigger, display, and handle local notifications. This is an important prerequisite because with push notifications, we are going to trigger local notifications, but, and that's the difference, the trigger is not coming from inside our app like it currently does. Keep in mind that currently, in the end, we trigger our local notification here with the trigger notification handler, with the schedule notification async method. That's how we currently trigger the notification, and that will no longer be the case. Instead, now with push notifications, the trigger will be outside of our application. It could be the developer of the app manually sending push notifications. It could be server-side code that leads to a push notification being sent, for example, when a new chat message is stored in a database. And therefore now we will need to learn how we can send push notifications to other devices and not just to our own device. For that, we need to understand how push notifications work. We got our app, and typically, of course, it runs on multiple devices for multiple users. Then we got some event that should lead to a push notification to be delivered. That could be a chat message that's being posted, but it could also be that we, as the owner of the app, decide to send a marketing message or anything like that to our users. So we want to deliver our message or our notification to a device. But this is not how it works. We can't directly send messages to devices. That's a security mechanism, because if anyone could just start sending push notifications to random devices out there, our phones would get spammed. So instead, to deliver push notifications to our apps on our devices, we have to use official push notification servers. And both Android as well as iOS, so Google and Apple, have their own push notification servers. And you have to use those to deliver your message to the devices. Why? Because those servers will only deliver messages to devices and app installations that identified themselves. Essentially, your app will have to identify itself with Google's and Apple's servers. It will get a unique token, an ID you could say, and only that ID can then later be used to deliver a push notification through those official push servers to your app installations. Because then the official servers can verify that your app opted into getting those push notifications. That's the security mechanism here. And therefore, instead of directly sending messages to devices, we in the end use that event in conjunction with those official servers to send our push notification through those official push servers to the different devices we want to target. That's how push notifications work. So we have that extra security step in between, which matters. Now let's see how we can implement that in code and how, again, Expo helps us a lot with that. Thankfully, handling push notifications is made easy with Expo. And there are various steps which we already implemented, which we will also need to implement if we are looking to handle push notifications. For example, we also need to ask for permission if we want to get push notifications. So that permission, which we're getting here for receiving notifications, that will in the end enable both local and push notifications, you could say. So that is code we absolutely need. On iOS only, but there we need it. We will also need our handlers for handling incoming notifications when the app is in foreground and when the app is in background, because actually push notifications will still cause a local notification once they arrive. So for handling the message once it's on our device, our code is exactly the same. So this does not change. But what will change, of course, is how we schedule a notification. We're not going to do this with this code anymore. Instead, I first of all want to start with showing you how a message could be sent from totally outside of the device. And then as a second step, I will show you how our app here could send a notification to itself, but to itself running on a different device on a different user. That would be the scenario you have in a chat app, for example, that your app wants to send a notification to, well, the same app, but the same app on a different device, the device of the user to whom you just sent a chat message. That will be the second step. First of all, I'll show you how to send a notification totally from outside the app. But for that, one important step is missing. And that's that identification with Google's and Apple's push servers, because as I mentioned, we will need to do that. And those servers will then give us this token, this ID, which we ultimately need to send push notifications. And that's therefore code we have to add here. Besides asking for permission here, if we plan on receiving push notifications, we also need to sign this app installation up with those official push servers. So this app running on a device of our user needs to register itself with those official push servers. And for that, we need to add some code. Now we will need to make some changes here to our permissions though, or not to the permissions, we'll still need those. But after we have those permissions, we'll now need to get that token, that ID. We'll need to sign our app up with those official push notification servers and get that ID, which then allows us to use the ID to push notifications to this app installation on this device. Now, thankfully, Expo makes that super easy. It makes it very simple because the team behind Expo basically did not just give us all these nice JavaScript functions and APIs for building React Native apps in a convenient way. They also have their own backend server to which you can talk through some functions where they have all the logic for signing up an app with those official push servers and getting that permission. Actually, to be precise, Expo does not sign our app up with those services. Instead, Expo signed itself up with those services, and it allows us to use its sign up, you could say. So Expo, the team and the software, does all the heavy lifting behind the scenes for us so that we don't manually need to sign up our app, but that we can leverage Expo's existing server to push notifications through Expo's subscription with those official servers to our different app installations, users, and devices. That is how you can think about that. And that will make implementing push notifications with Expo very easy. I can tell you that if you would need to sign up manually, that would be a lot of steps, a lot of work, and Expo is handling this for you in a very elegant way. Expo really makes it easy to deliver push notifications to your applications. What do you need to do? Well, after we got our permissions, here in the next then block, we want to tell Expo and their own server, which they have for us, to sign our app up with those official push servers. We'll need to tell Expo to basically sign our app up, so to say. Behind the scenes, Expo will do all of that. Behind the scenes, Expo will sign up, and then our app will leverage Expo to deliver push notifications. Now, for that, we need to ensure that we only reach this then block if we do have an active permission. Therefore, here, if the permission was not granted, we don't really want to return, because then the next then block would still be triggered, even though we don't have permission. Instead, here, I want to throw a new error. Permission not granted. With this, we'll ensure that this code only runs if we do have permissions. You will see I now get a warning that permissions were not granted, even though we did grant permissions before here. The reason for that simply can be seen if we console log this status object here. If we do that, we see indeed I do have a status of granted here. But before that, we have a status of undetermined, which simply means it's still figuring out whether we have permissions or not. That is okay, because ultimately it should see that we do have them, so we can simply get rid of that warning by adding a catch block here. And then here, for the moment, I'll not return anything. But with that, we no longer have an unhandled promise rejection, and therefore this warning goes away. Again, getting the permission should work. Now, with those permissions out of the way, let's see how we can get this push token, which we need to deliver messages. Here in this then block, we now know that we do have granted permissions. That's the only scenario where we will reach this then block in the end. And therefore now here, we want to sign up with expose push service, which under the hood will ensure that those official services get used. And for that, we can again use that notifications package, which we imported, this one from expo notifications. And there we can call getExpo push token async. This is a method that will talk to Expo's server, so not to Google's and Apple's server, but to that server owned and managed by the Expo team, so to say. And when I say team, by the way, that's not just 2 people working on that. This is a reliable service backed by a big community. So we'll talk to that server there, and we'll sign up our app with that Expo server. And then behind the scenes, Expo, this server, and so on, will know how to deliver push notifications to the different app installations on the different devices. So we just need to call that and return the result, since this will return a promise. And then in the next then block thereafter, we'll get that result. So here we'll get some data, and for the moment, let's simply log that data to see what's inside there. Now, if we save that, we'll have a problem though. We can do this, but this won't work on those simulators. If we try to run this on the Apple device, on the iOS simulator, if I run the project again there, we'll see that ultimately nothing is being printed here. And the same for Android. If I quit that and restart it on Android, we'll not see any output there as well. So we're not able to test this on simulators. Instead, we'll need real devices. And I'll start with a real iPhone. So I'm going to quit this Expo server and restart it with my real iPhone connected. And now I scanned the QR code with my iPhone. Now I did actually run the app there before, I have to admit. That's why I'm not getting prompted for providing permissions here. I did have to do that before, so you should be prompted. And now there, with that connected, we should be able to analyze whether everything works. For that, let's first of all add a console log here, getting token, to see whether this works, whether we're trying to get the token. And we do. Getting token is being printed here. Now still, we don't see the console log here for the data we get back when we request the token. So let's add a console log here in the catch function to see whether we got an error. And indeed, we did get an error, an API error, that the Expo push notification service is supported only for Expo projects. So that we need to be logged in our Expo developer account on the computer from which we are loading the project. And that's not the case for me here. I'm not logged into my Expo developer account. Now, getting an Expo developer account is free. You just need to sign up with Expo to get such an account. And once you do have that account, you can quit that Expo server and run Expo login there. And now you'll need to log in with the account you just created. And once you did log in, you can start the Expo server again and reload the Expo app on your iPhone or Android device as well. And once you do that, once the app starts on your real device, you should see that you now got a log where the data that we log here is actually such an object with a data field which holds that exponent push token value here. And that's the token we'll need to deliver push notifications to the different devices. And what I just showed on my real iPhone will work in exactly the same way on a real Android device. So now let me show you how we can use that push token to deliver push notifications. So finally we got that token. Now here we can retrieve that token by accessing data.data, because it's the data field that holds the token. And therefore, of course, if that's confusing, you can of course also rename that argument to response to access response data, but ultimately that will be our token. Now, we'll not need that token here for the moment. Instead, I want to use it to manually send a push notification to our real device. And testing push notifications is made easy with the Expo push notification tool. You can find it if you search for Expo push notifications. This is a tool which allows you to test push notifications you want to send to your Expo projects. In reality, you would probably not use this tool, but you would use one of Expo's server-side SDKs to trigger a push notification on the server, or you would send it from directly inside your app, as I will show you later in this module, depending on your use case. But for testing, this is a great tool. Now, as you see, it needs this push token in this format we just saw it. So let's copy this push token, this full string here, and insert it here. That's the identifier of my device now. And then we can enter a title. This is a test. My first test message as a body. We could add extra data if we wanted to. That should be in JSON format then, though. And we can also add iOS and Android specific information, but for the moment I'll just send this notification. And now I'm sending this notification whilst the app is in foreground. It would also work if it's in background. And you see here's the message delivered, and we can tap it, and if we do tap it, we run that same code I showed you before for the local notifications. So that code for handling incoming background or foreground notifications, that code still executes and it still gives us access to the notification object and all the notification data. And that's in the end all that's to it. This is how we send push notifications in an Expo application. As you can see, it's really not that difficult thanks to Expo's own push server, which in the end wraps those official servers and which has done all the nitty-gritty details of registering itself with those official servers for us. Instead, we just use these convenient methods I showed you and we can deliver push notifications. Now let me show you how we can trigger push notifications from inside the app. So now that we got push notifications working, let's see how we can work with them from inside the app, so that when we press this trigger notification button, we send a push notification. And for that, Expo has got us covered as well. Here in Trigger Notification Handler, or wherever you want to send a push notification, in the place where you want to trigger that a push notification should be delivered to some device, you need to send a HTTP request to Expo's servers. So we can do this with the Fetch API, which is available in React Native, and the URL to which you need to send this is https://expo.host/API/v2/push/send. make sure you have no typo in there. That is the URL to expose push notification server, which we will leverage to deliver our push notification to a different device. This in the end was used behind the scenes when we used this testing tool here. So we need to send a request there, and we need to configure this request with the second argument we can provide to the fetch method here, to the fetch function. There we need to set the HTTP request method to post, because we need to send a post request to that URL, and we need to add some special headers. The headers we need to add here are the accept header, where we should accept application JSON, the accept encoding header, where we accept gzip, deflate, and the content type header, where we also specify application JSON. In addition to those headers, we now need to set the body, which will hold the actual message we want to send. And message is now not just a string, but an object, because after all, there were a lot of things we could configure. So here on body, we simply provide an object, however, not like this. Instead, it needs to be in JSON format. So we stringify this object with JSON stringify. And then in there, we can set up various things. Most importantly, we need the to property. This is a required property, which then needs our token. So the token we're getting when we're registering. Now, currently, we only have the token here. We can simply use state to manage the token as state of our component. So there we got the push token and a set push token function. And we want to set the push token once we got the token here, set push token to token. And then go down to the trigger notification handler function. And there we want to send to our push token here. Now we can configure all the other fields we can set on notifications. We can, for example, add the data field and set this to extra data, some data. But of course, most of all, we can also set a title which will be displayed. And there that could be sent via the app. Sent via the app. And a body for the push notification, which could be this push notification was sent via the app. And now this will send a HTTP request to expose backend servers, which then in turn will do all the rest for delivering this push notification to the device with this push token. So let's save this and let's give it a try. And now with it all set up, once it restarted on my device, I can test it there. Now I will actually here send it to the same device as I'm running on, but this could be sent to any other device as well. I just don't have any second device around right now. But if I press trigger notification, you see sent via the app, which clearly is that brand new message we prepared. So that is this push notification sent through expose push servers. And whilst I sent it to myself here, which of course might not be what you want to do in most scenarios, you still see the idea behind it. This could have been sent to any other application of which we had the push token. Now, speaking of that push token though, how should you manage that? Because at the moment you could argue that the only push token we can know in this application is the one of this device on which this app is installed. So how could we know the push token of some other device? How could that work? So we learned that we can leverage expose push servers to deliver push notifications. But we need a push token for that. That's no problem because we can get that token as we do it here with get expo push token async. The problem with that, however, is that, of course, we can get a token with that, and we can store this in state thereafter, but then we only have the token of this device on which this app installation is running. So when we later want to send a push notification, the only token we know is our own token. Now, for this example, this was just what we needed, but in reality, we of course want to send a push notification to other devices, so to the same app installed on other devices of other users. How would we get their tokens? Well, just as we get their emails or whatever else we need in an application. You can of course write code where once you got that token, you don't, or maybe not just, manage it in your local state, but instead you send a HTTP request to your own API where you then have some logic to receive that token and store it in a database. This token, of course, can, and in reality will, be shared and stored in a database, so that any user of your app submits not just his or her email address and password, but also his or her push token. And with that data stored in a database on your server, you can of course always retrieve that token and use it in your app when you need it. So you can share that token just like you share other user data as needed. After all, if a user creates a product in a shop application, we also store that product in a database to show it to other users as well. With a token, it's no different. We won't show it to other users, but we can still fetch it on the devices of other users and there use it in the code to send push notifications as shown here. In addition, it is worth pointing out that when it comes to sending notifications, there is a separate article on the Expo docs, and you can find it if you search for Expo push notifications and look for this sending notifications article. There, you will learn about different ways of sending notifications. One way is this way, that you use Expo's push server like this. This is something you can do and there's nothing wrong with it. But if you don't really need to trigger the push notification from inside the app, but instead you want to trigger it from inside your own server, so now I'm talking about your server, which you as developer own, for example, the server where you also store products users create, and you want to trigger a push notification from on that server, you can do that as well. The Expo team gives you many SDKs for Node, for Python, for PHP, which make it very easy to trigger push notifications on your own server. Under the hood, those SDKs will basically do what we do here. They will send a request to the Expo push server because that Expo push server needs to be involved at all times. So those SDKs will still do that. But they can take away the need to run this logic inside of the app, and instead you could run it on your own server if that would be something you needed. So you can really send push notifications in different ways. You can use a SDK like this. You can also just send a request to this Expo push API as we did it here, and that in turn can be done from inside your app or even from outside of it. You could use any tool you want to send a post request with this data to this URL. That doesn't have to happen inside of an Expo app. This is a regular HTTP request. So whenever you send a request configured like this, a push notification to that token, which you of course need, will be delivered. So that's how you can send push notifications. And that's how easy it is to get started with push notifications when you're using Expo. Now, let's apply what we learned over the last lectures in our shop project we built throughout this course. Here I got that project with React Navigation 5 integrated, so after this other section where I show how to upgrade to React Navigation 5, and I haven't changed anything else. So this is the app as we know it, running on the simulators, and there we can of course create an account with some credentials here. First of all, I need to sign up. And now here we can add products and so on. Now, my idea is that when we add a product here, we actually don't just store the product with all the data we're uploading thus far. At the moment, when we create a product, we are sharing title, description, image, URL, price, and owner ID. But instead, besides sharing all of that, I also want to add the push token of the device of the user who added this product. So the push token of the seller, I want to add that to the product as well. Why? So that when we fetch the product data, we can also download the push token that belongs to a product. And whilst we won't show this to the other users, we'll use it in code to ensure that when an order is placed, when we add an order, we don't just store that order data in the database, but we also send a push notification to the owner of the product that was just ordered, letting him or her know that the product was ordered. That's my idea here. That of course means that we'll have to analyze the items that are in the cart, and then we'll send a push notification for every product, basically. That's my idea. So for that, to ensure that this works, we first of all need to prepare this project for push notifications. That means that we first of all should go to app.json and add that Android entry here, where we set use next notifications API to true. That's what I showed you before in the other lectures as well. We also need to ask the user for permission. So the question is where we want to do that, of course. Since it's the creator of a product who should receive push notifications, I will ask for permission right before we create a new product. So we have our user, our edit product screen where we create a new product. And there in the end, we trigger an action in the products.js file here. We'll trigger this create product action. And now my idea is that I ask for permission here. I then also fetch the token here, and then we can add the token to the outgoing data that's being sent to the server. So therefore, let's first of all expo install the expo notifications package and also expo permissions. And then let's use both just as we learned it over the lectures in this module. So with that installed, here in create product, before we do anything else, we want to use the notifications API. And for that, we have to import everything as notifications from expo notifications. And let's also already import everything as permissions from expo permissions. And with these two APIs imported, in create product, we can use notifications to get our expo push token. However, as you know, we don't directly want to do that. Instead, we first of all want to check the permission status. So we should use permissions and get the information about the notifications permission. This returns a promise, and since we're in an async function here, we can simply await it. Now what we'll get back is that status object, which has that status property that tells us whether a permission was granted or not. So we can check if status object dot status is maybe not granted, which means we are not having permissions yet. Then we want to use the permissions API again to ask for the notifications permission with this code. And that's all just what we had before, now just with async await instead of then, but other than that, it's the same. And here we'll again get our status object. Now, since we would have a name clash here, I'll name this here updated status object. And of course, here we should also await because that is asynchronous and it returns a promise. So at this point of time here, we can now check if updated status object has a status that's not equal to granted. And if that's the case, we know we won't be able to send push notifications. And that is absolutely fine. I will simply create a token variable here and set token equal to null here to make it very clear that we simply don't have a token here. Actually, let's not name it token because we already used that name. Let's name it push token because that is what we want to retrieve in the end. So we set this to null here if we absolutely didn't get permission, because there is nothing we can do in that case, because we then just don't have permission to send push notifications. It is what it is. But in the else case, that this is granted, in that case, we can set our push token equal to notifications.get expo push token async. And of course, that's a promise, so we should await this. And of course, we don't directly get the token. Instead, we get an object which has a data field, if you recall. And so we could wrap this here into brackets and call data on that. That simply means that first of all, this promise is resolved. Then we call data on the resolved object after we awaited the promise. And it's the value in data, which we then store in the push token variable. So here we'll have our push token, which we need. Now, when we have that, we can continue. And since we use await, this code will only execute once that all finished. This line, of course, should be removed now. And now, with the data we send to the server, we don't just send the title, description, the owner ID, but also the owner push token. And that will be our push token here. And that's either null or it is our token we got from Expo. So now whenever we create a new product, ideally we're able to send our push token along. Now getting that token and all of that won't work on simulators, as you learned, so therefore I'll save this and again test this on my real iPhone. So again, I got my app booting up here and I just logged in with the user we created. And now under admin, I will create a new product, push token test. Now we need an image URL. And I just grabbed some random image. And I'll enter a price here. And a description. And confirm this. And I'm getting an error that updated status object wasn't found. And that makes sense because actually I'm setting this here in this if check, but then I'm using it outside of this if check. So of course this has the wrong scope. Little oversight from my side. We can fix this by actually reusing status object up here instead by turning it into a variable with let. Then here we simply set our status object to a new value and then we use status object again here in this if check. Now the scope is right and this will work. So let's try this again. Push test, insert that image which I picked, insert a price and a description. This is a test. Then close this, confirm this, and now this seems to work. I added my product, and what will be interesting now is our database. Here's my Firebase database, so the backend we're using, and a new product was added here, and indeed here we see our push token. Again, I added an overlay over my actual device token, but this is now a push token, which allows us to send a notification to the user who created this product. So now let's work on that other part, and let's make sure that we indeed do send a notification once we actually order a product. So let's work on the ordering part now. Whenever a new order is placed, we want to send a notification, a push notification. Now we are storing this owner push token, which we need for sending a notification. And actually we got two options now. Since this is all on a backend, we could send this request to Expo's push server from the backend. either by using one of the Expo SDKs I showed you earlier, like the one for Node and PHP, depending on which language you are using on your backend, or by simply sending that same HTTP request we sent from inside the app earlier from your backend. That would also be an option. Now, Firebase is a special backend. We don't fully own it. We instead use the services that we have. Indeed, with Cloud Functions, there would be a service that allows us to run server-side code, and we could make that all work, but since using Cloud Functions isn't entirely free anymore, I don't want to show this here. I just want you to know that you absolutely could come up with code on the server that would cause the push notification to be sent from inside this server, so that this triggering happens here on the server. Now, I will do it from the app instead, since that's easier for us here, but that is only one possible option. Now, from inside the app, we'll send the notification just as we did it before. Here in add order, we do want to send it. And there we got our cart items. Now, the cart items we're getting, let's have a brief look at what exactly is in there. So if we go to the shop, to the orders, to the cart screen, that's where we dispatch this action, the add order action with the cart items. And if we have a look at our cart items, we see that in the end, cart items are fetched from our Redux store, and cart items will be an array where we in the end have objects where every object has a product ID, product title, product price, quantity, and so on. So what we need here is we also need the product push token, so the token of the creator of this product in the end. And we can get this from inside our state, there from the cart, from the items for that key, so basically what we do up there, and there let's look for a push token. Now this is a field which won't be there yet, because we first of all need to make some changes to our store. There, let's check out the cart reducer. When a product is added to the cart, we get information about this product here. And from there, we, for example, extract the title and the price. And then in the end, we add this price and title to our cart item. Now, we don't just need the price and the title, we also need the push token. So here, let's also extract the push token of this product. So added product.push token, for example. This is also a field which won't exist on a product yet, but we'll change this soon. And then we can add this push token, let's say, as a third argument here to cart item, and also here. Sorry, it's the fourth argument, of course. So I'm adding this as a fourth argument to the cart item constructor. Now for that, we need to change the cart item constructor. So here, cart item should now actually get this push token as a fourth argument and then store this here. So this push token is equal to push token. But we're still not there, because now I'm storing this for every cart item, but I'm getting this from my product. And a product doesn't have a token yet. Yes, it has one on Firebase, but we're not fetching that data, or we're not using that data in our client-side app, in this React Native app. Instead, here in the products actions file here, products.js in actions, where we do fetch all products, here, fetch products, what we do is we extract things like the ID, title, price, and so on, and create a new product based on our product model with that information. Now here, we should also get that owner push token, just like we're extracting the owner ID. So here we want to get the owner push token for the individual products and add this to our product model, for example, as a third argument. So now with that, we need to go to the products model, to the product model here, product in models. And there, as a third argument, we now need to accept the owner push token and store this. And I'll name this field push token and store my owner push token in it, because push token is the field name which I now also used here in the cart reducer. There I'm accessing added product.push token. So if you use the different name here to retrieve the token for a given product, you also need to adjust this name here in the product model. But with all those changes, we're making sure that we're fetching the token that is stored for every product, and we're using it and storing it in the front end in our models as well. And we're storing it in every product model which we're creating, every product instance, and we're also storing it in our cart items which we're adding to our cart here in the Redux store. So now every cart item will have a push token, and our cart item model also stores that in a key named push token, and therefore now we'll finally be able to get that data when an order is placed. Now we don't just need to update how we create products here in the products.js file in the actions file, but also in the reducers. In the products.js file in reducers, there we have the create product case which we handle, where we also instantiate our product. Now, since we changed our product model to take the push token as the third argument here, we also need to update this here, of course. So here, the third argument, the title, should no longer be the title, but instead it should be coming from our product data, and there it should be the push token. Now for that, of course, in turn, we need to check where we dispatch create product to ensure that the action that adds product data also adds a push token to that product data. We also create a new product down there in update product, and there it's the same. The new third argument, which we get here in the product constructor, should in this case be state user products for the given product index, and then there again it's the push token. Push token is the name we have here because that here will access a product stored in our user products field, and that product will have the form of our product model, and there I picked push token as a name, so this also is push token as a name here. So with that, back to the create product case. As I said, we now need to go to the place where this action is dispatched to ensure that the proper data, the push token, is added to the action. Now it's the products.js file in the actions folder, and there the create product action creator, where we do dispatch this create product action in the end. And therefore here, to product data, anywhere in this object, we should make sure that we also add a push token. And now this push token value is simply the push token we already are using up there. So we should store this here as well. And with that, we ensure that we don't get an error when we create a new product. Otherwise, we would be getting one. So back here in the orders actions file, in the add order action, here we now want to get our token from inside the cart item and send such a push notification request. Maybe after adding the actual order on our server, because sending the push notification is less important than storing the data on the server, I would argue. So therefore, after this request was sent here, after we added the order in our Redux store, after all of that, we want to send our push notifications. Now for that, we'll have to go through all the cart items we have here and send one notification per item. That's another reason why you might want to consider doing this on the server side. If you have a lot of items, this can take some time, and at the moment, that will all be work that happens here in our React Native app on the client, not on the server. On the server might be better because it takes that work off your client, but for the reasons mentioned, since we don't have our own server, since we're using Firebase and Cloud Functions aren't free to use anymore, because of all those reasons, I will actually use the suboptimal solution of triggering that on the client, so inside of the React Native app. And therefore here, we want to go through all the card items we have, so through all our card items here. And for every card item, we want to get the push token simply by accessing carditem.pushToken. And then we want to send our request. So again, with the fetch API here, we want to send a request to HTTPS, and then that was x.host/API/v2/push/send. And add the second object where we configure this request to set its method to post and to also add a couple of headers here. And we wanted the accept header, which should be application JSON. We wanted the accept encoding header, which should be gzip deflate. And we want the content type header here, which should also be application JSON. But now even more important, we want to add our body to the request, which should be a JSON stringified object in which we now point at this push token with the to field. And then we can add extra information. We could add extra metadata about the card item, for example, for which this notification is being sent. But here I'll just add a title of order was placed and then a body for this push notification where I simply share the, let's say, the title of the product that was ordered. Keep in mind that in every card title, we store the product title on a product title field. So therefore, back here in the orders actions file, I can access carditem.productTitle to share that product title as part of the push notification that should be sent. And this is in the end it. With that, we're going to schedule a bunch of HTTP requests. I'm not waiting for their responses. I'm not handling the responses. You could look into those responses and try handling possible errors. But in the end, this should work. And if for some reason one push notification shouldn't go through, in this case, it's also not the end of the world, but it should really work. So let's now save this and let's give it a try. So back here in my application, I'll add a second product simply to see if we get 2 push notifications. I'll use the same image though. Enter my price and a description. Confirm this. And now go to the products area and add both to my cart. Now these are my own products, but in this app I can still order them. So now let's press order now, which should place the order, and we don't see anything. Now does this mean that we have an error? Not necessarily. We don't see anything because you might remember that if the app is running in foreground, by default, no notification is shown. And that's the same for push notifications because, as you also learned, they just trigger local notifications in the end. So let's fix that and let's make sure we can see something. So let's fix that. And for that, we can go to app.js and there also import everything as notifications from Expo notifications so that there, even before we create the component, we can set up our notification handler where we tell the operating system how notifications should be handled if the app is running. And here in the end, we want to pass in an object where we define the handle notification function, which is an async function here, because it should return a promise. And then in here, we simply return an object where I will set should show alert to true, to tell the operating system that local notifications should always be shown. With that change made, let's try it again. Let's add both to my cart, click order now, and I still don't get anything. Well, let's add a console log here in our for loop and see if we're maybe having problems extracting the push token from the card item, because I think that something has to be wrong there. So I'll add a new item to my card and test this again. And I see I simply named this incorrectly. It's product push token. That's the name I have here. Because, and that was my mistake here, if we do place an order from inside the card screen, I mentioned it at the beginning and then forgot it again. We're not submitting our raw card items. We are transforming them, and there I used product push token as a name. So that's my bad. Let's go back here to the orders action file and use that proper name and extract the product push token. And with that, we should have a push token. And now, of course, push notifications should be delivered. Nonetheless, adding this in app.js was also important, because otherwise we wouldn't see anything if the app is in the foreground, which might be what you want, but which still is good to know. So now I added 2 products again. I'll click order now again. And now here we see our push notifications, and we also see the information, the title and the body we defined. And that now works, and that is how we could integrate push notifications in a more realistic app.
Great job, you did it. You completed this course, and therefore you learned a lot about React Native and how to build React Native apps with React Native and its core components and its core features, but also with many important third-party packages like React Navigation, like maps or the camera, so all these native modules which you can integrate. And you learned it all with the help of Expo, an amazing tool that makes building React Native apps so much easier. But I also showed you how you can build apps without Expo, how you can turn your Expo app into a non-Expo app, and that even when using Expo and getting this easier development flow, that you still get a normal React Native app in the end, which you can deploy as a standalone app to both the Apple App Store and the Google Play Store. So therefore, you now get all the tools you need to continue your journey as a React Native developer, and you're well prepared to dive into React Native jobs, to build other projects, build your own project, and of course, because that's always important, keep on practicing. And that would be my recommendation in general. If we have a look at the next steps you could and you probably should take if you want to continue with React Native, then the most important step, as always in life and as always in programming, is that you continue practicing. This course gives you very solid fundamentals and the core foundation you need to be a React Native developer, but you always need to keep on practicing. Build dummy projects, build simplified clones of popular apps, and therefore practice all the things you learned. You will encounter problems and challenges along the way, and solving these on your own with the help of Google and Stack Overflow and the official docs and so on, that will make you a real and a better React Native developer. Now, I already kind of mentioned it, also dive into those official docs, be that the React Native docs, the Expo docs, the docs of a specific third-party package you're using, and also explore examples. Many third-party packages give you examples of how you may use them, in which different ways you could work with the package. And you will also find plenty of demo projects on GitHub, for example, by people who built dummy or real apps with React Native. So definitely also explore those to get ideas on how you could build a React Native app with that. And in addition, also explore other packages you could be using, alternatives to the packages I used in the course maybe, because that again will broaden your horizon, give you more tools and a deeper understanding of how all these things work together. Now, last but not least, it's important to stay updated because, like everything in development, React Native keeps on moving. It's a moving target. We see new features, maybe some features are deprecated, maybe there's a new package out there that does something in an easier or better way than you used to do it. So therefore, keep your eyes open. Check the official React Native blog, check the Expo blog if you're using that, check the changelog or check the GitHub repo of the React Native project to stay updated about changes that might help you in future projects or that might require you to adjust your code. Of course, as I did in the past, I'll keep this course updated as well and I'll inform you about important changes, But not every change that happens in the React Native ecosystem affects this course, so therefore you definitely also need to stay updated on your own. Well, and with that, you got everything you need, you're well prepared to become a React Native developer, and I wish you all the best. I hope this course was helpful to you, I hope you got a lot out of it, and I'd love to see you in other courses as well.
Welcome to this optional, that's important, optional module, where I want to introduce you to the JavaScript basics. And this module is really just a quick refresher. I do expect you to have some basic knowledge about how JavaScript works, what you use it for, and its base syntax. This module does not replace that. You can't really use that module with zero JavaScript knowledge, or at least it will be very, very challenging. But if you only got some very basic knowledge, or it's been quite some time since you worked with JavaScript, then this module will be a great refresher. Please skip this module if you already know JavaScript though, because then this module is not for you. So you don't have to be an expert to skip this. If you know JavaScript and you also know some of its next-gen features like the REST and spread operator or object destructuring, so a bunch of nice things that we can do in JavaScript, definitely skip this module and maybe come back later if there is some feature you don't recognize or you're not sure what it's all about. If you don't have that knowledge though, this module is for you. And also have a look at the next lecture where I provide links to helpful resources in case you're brand new to JavaScript, because there are some free resources that allow you to get started with JavaScript, after which you can come back to this module and to the rest of the course where you will need that basic knowledge. So now that we know for whom this module is, let me summarize JavaScript briefly. JavaScript is a weakly typed programming language. It's an object-oriented programming language, and it's very versatile. Now, what do I mean with that? Weakly typed means that we have no explicit type assignment. JavaScript knows types like numbers or text, which is called string, or booleans, which is true or false. But it doesn't force you to define which type you're using in a variable or in a function. And indeed, you can also have a variable where you store a number, which you then suddenly change to a text variable. So you can switch types dynamically. In other languages, this is differently, and whilst this gives you greater flexibility to be able to change it and to not have strict typing, it also can lead to errors. So it is just something you have to be aware of. Object-oriented simply means that data can be organized in logical objects, and we'll see these objects in this module. And one important concept here is that you have to be aware about the difference of primitive and reference types. And attached to this lecture, you'll find a link to an article and video I created for my free YouTube channel, Academind, where I do dive into primitive and reference types and where I do explain the difference and why they are important. So definitely check that out if primitive and reference types don't tell you anything. Regarding the versatility, well, we can see that in this course. JavaScript runs in the browser, and this is actually where it comes from. But you can also use it with Node.js to run it on your PC outside of a browser setup, or also on a server therefore. And that is exactly what we'll do in this course. We'll build a web server with Node.js, so we got this broad versatility of being able to use JavaScript on different platforms. And you can also perform a broad variety of tasks with JavaScript, also depending on the platform you're running on. You can, in the browser, listen to user events, re-render the DOM, and on the server or on a PC, you can work with files, with databases, a lot of cool stuff. So this is the summary of JavaScript and what makes up the language. Let's now dive into some core features, also some core next generation JavaScript features, which are supported by Node.js. And let's see some things we'll see throughout the course. For that, let's just play around with JavaScript. And I'm in a brand new empty folder, which I opened with my IDE, Visual Studio Code. And in there, I'll create a new file and I'll name it play.js. The name is totally up to you though. Now let me start with some core language features, variables and functions. And again, you should definitely dive into a core JavaScript resource like the ones I linked in the second lecture of this module if you are brand new to JavaScript. So I by now do expect you to know what variables, functions are. I also expect you to be aware of what if statements or loops are. These are all core things you gotta have set by now because they are crucial for JavaScript, no matter if you're using it in the browser or on the server. So for variables, you might know this syntax with the var keyword. You can have var name and, for example, store max in there, right? This would be a variable, and now you can use that, for example, to simply output it like this. And if we now run this file with Node.js by running node play.js, this is the command we have to write in a terminal, navigate it into that project folder, so into that folder where I'm having this play.js file, then I see max down there, right? So that is some JavaScript code. We can also create another variable, age, which now would be a number. It's not enclosed in quotation marks. So this first one is a so-called string. This is a number. We can also add a third one, has hobbies, and that would now be a Boolean. These are some core types JavaScript knows. True, false are Booleans. Numbers are, well, numbers. They can also have decimal places. These are strings. And now here, I can also define a function with the function keyword, summarize user. This is how you create a function JavaScript. And there we could return something. Functions can return values with the return statement. They also can get input like user name, user age, and user has hobby. You can name these arguments as these things here are called, however you want. These are now local variables, only available inside of the function, not outside of it. And then you can return name is plus username plus, let's say, some text with a comma, a white space. Age is white space, user age plus, and the user has hobbies, and then user has hobby, something like that. Now here I'm simply returning some text which I'm manually concatenating by hard-coded strings and the dynamic values I'm getting as an argument. Now we can also console log the result of summarize user, and we call a function by adding parentheses after the name, and now we just have to pass in data we expect here as arguments. So we need to pass in 3 arguments here, the name, the age, and has hobbies, so the 3 variables I defined up here. We could have directly accessed them in the function too, by the way. We don't have to take the way of accepting arguments, but this is a purer function which does not depend on anything from outside the function, but gets all the data it works with as part of the arguments, which is a nice way of writing functions. And now, if I execute this, well, then we get this output here. Now, this is just a summary of the features you should be aware of, as I mentioned. I just want you to know, or I just want to be sure that you know how we work with variables, how we work with functions, how we call functions, and that you understand how parameters or arguments in the function are used in there and only in there. We couldn't use username outside of there because of something called scoping in JavaScript. We can then call a function like this and pass in the data. We could hard code the data here or refer to variables, which have to be available in the scope of this statement, which is the case for these variables since they are global variables. And these are variables and functions and how we interact, and these are some core features you have to be aware of. Let's now dive into something more exciting in the next lecture. Now that I had a quick look at the very basics and the core terms you have to know, let's dive into some next-gen JavaScript syntax you'll see throughout this module or throughout this course. Var is a keyword that creates a new variable, and actually it's a bit of an outdated syntax. From now on, we'll use let instead of var, and let also creates a variable. The scoping behaves a bit differently, but we can ignore that for now here. Check out some next-gen JavaScript resource like my ES6 course, or of course also some free resources to learn all about let. But the core reason for using let is that we now also have another way of creating a variable, and with that I mean a variable which never changes, which actually is the case for all three here. But let's say we actually do assign a new value to age here, but we never change name or has hobbies. We could absolutely use let, there is nothing strictly wrong with that, but to be clearer about our intentions in the code, and we know that we'll never change let name and has hobbies, we can also use a new keyword available in JavaScript, and that's the const keyword. This creates a so-called constant, and this makes clear that we never plan on changing the value of name or has hobbies. We do plan to change it of age, and that is why we have let. And that is the reason why we have two different keywords for creating variables, though again, these are not really variables, there are constants, either const or let, depending on whether we plan to change this or not. So now if I execute this, it works in exactly the same way as before. But by the way, if I would try to set name to Maximilian here, and I do run node play.js again, I actually get an error now that I try to assign to a constant variable. So this actually already shows us the idea behind const, and you want to use const as often as possible to be as clear about what happens in your code as possible. And if something should never change, make it a const so that you get an error if you do accidentally change it. So here I'll revert this change, but I wanted to show you how let and const work. Let and const are two relatively new features in JavaScript. Another cool new feature are arrow functions. We can rewrite this function as an arrow function by, first of all, creating a new variable or constant. Since I'll never set a new value, I'll use a constant. And I'll give that the name of my function, so summarize user. The value which I then assign after the equal sign is a function. Now we could already have done it in the past with this syntax. This is another way of defining a function. The part on the right side is a so-called anonymous function, because we don't set up a name after function, but we make it a named function implicitly by storing the anonymous function in that named constant. So we can always call that constant, which holds a function as a value, and we call the value with the syntax, and therefore this is like a named function here. So this would have worked in the past too. It is a way or a different way of defining a function, but we can now also use a new syntax where we remove the function keyword and instead we add an arrow between the argument list and the curly braces. And this arrow is simply an equal sign and a greater than sign. This also creates a function. It's a bit shorter since we saved the function keyword, and it runs in the same way as this function ran before. Now, why would we use this syntax except for the reason that it's a bit shorter? Well, that is already a nice reason, but also there's one key difference regarding the this keyword which JavaScript knows. And attached you find a link to another video and article I created where I dive into the this keyword and how arrow functions help us with it. The attached article and video actually uses the browser, but it's the same for Node.js. So this will be helpful too. You have to know what JavaScript objects are for that, but again, that is some core knowledge I require you to have for this course. In this course, I will pretty much only use arrow functions. So this syntax for defining a function should be something you understand for this course. That this is the name of the function, and then here we have the arguments, and then we have the function body. Now a little side note. There is also a shorter syntax of writing this, or a couple of shorter syntaxes. Let's say I have another function, which I'll name add, and there I get two arguments, a and b, and I just return the sum of them, so the addition. Then you could write return a plus b, of course, and that allows us to run console log add with 1 plus 2, and if I now run node play.js, we see 3 here as a result. If you only have an arrow function with one statement, which happens to be the return statement, or which you are fine returning, well then, you can omit the curly braces, you can omit the return statement, and you have to omit it, and you just use the function like that. This simply is the same syntax as before with the curly braces and with return, and this function will now always return the result of this statement here. So now if I execute this again, we still see free. Now if I would adjust this function to, let's say, always add 1, then I have just a as an argument, let's say, and I return a plus 1. Now I could call this by console logging add 1 to, let's say, 1 here. So the result should be 2. And I can, of course, execute this, and indeed I see 2 here. Now, in such a case, you already saw my auto formatting removed the parentheses I had there previously. Because if you only have one argument, and that's the case really for that case only, if you have one argument only, then you can just have the argument name here without parentheses, and it will work just as it will work with parentheses. So both works here, but you typically use the syntax without the parentheses. And again, my IDE auto formatting removed them for me. If you have an arrow function with no arguments at random, then you have to specify an empty pair of parentheses though. You can't have just a white space. You have to have that empty pair, and then you can have your code there, which obviously uses no arguments because that's exactly what I want to show here. So here I could have add random called like this without any data passed in, and now we see free here from that result. So these are arrow functions and their different syntaxes, and you will see them throughout the course, and you should recognize that syntax and understand how they work. Again, for a reason why to use them, check out the attached article plus video. Now let me get rid of that existing code. You find a snapshot of the code we wrote thus far attached to the last lecture. And let me write some new code. An important thing you work with, or important data structure you work with in JavaScript, are objects. You could have something like the person object, and you create an object typically with curly braces, and then in there you have key value pairs. You define the key by simply typing, well, whichever key you want to use, let's say name. Then you have a colon, and you must have that colon, and after the colon you have your value, in my case a string max. And then with a comma, you can add another key value pair, age 29. Now this is an object, and I can log person here. If I now execute play.js, we see that object being printed here. Now objects allow us to group data together. You can also not just have variables in there, so to say, but you can also have functions in there. For example, a greet function. And there you can simply have an anonymous arrow function, or an arrow function in general, as a value after the colon. And then in there you could have console log hi I am, and then the name, and this would now be accessed with the this keyword. Instead of an object, you have to use this to typically, and there is something special about this, which I showed in that video I linked before in an earlier lecture, but typically this refers to the surrounding object. And now we can use the dot notation, so dot, to access properties or methods, so variables or functions inside of that object. So we could now use this name. And now I can use that person and call greet with the dot notation and executing it as a function. So the dot notation is important on this, which refers to the object, or on you, referring to that object which is stored in this constant here. And now if I execute this again, I'm saying, hey, I am undefined. Now why is that? Well, the reason for that indeed is what I taught you about arrow functions. This now here refers to the global scope, to the global node runtime scope, and not to this object. To have it refer to that, we either have to use the old school function like this. Now if I repeat that, I'm saying, hey, I'm Max. Or we use a slightly different approach or syntax here in an object. And that is, you don't use an arrow function, but you use greet like that. So you omit the colon, add the parentheses after the key name, And then, without a function keyword or anything like that, you add your function body. And now this is a method of this object, and you see hi, I'm max2 now. So this is something important, and this is the syntax you'll see me use throughout this course, without the colon, parentheses right after the key, and then the function body. Besides objects, another crucial data structure in Node.js or in JavaScript in general are arrays, like hobbies. An array is defined with square brackets, and in an array you can have any data you could normally use too. You can use strings in there like sports and cooking. You can have numbers in there, and you don't have to use one and the same type in the array. Here we are mixing text and numbers. You could have arrays with just text, just numbers, and so on too, of course. You can use Boolean values, and you can even store objects in there or other arrays. That is all possible. Now here I'll have an array of text though, and you can use for loops to go through that. With this syntax, for example, with the for off loop, where we store each element for each iteration in that hobby variable. And now, if we do that, we would execute console log 2 times because we have 2 elements and we're looping through all of them. And I'm outputting the current value we're currently looking at, because this will change for every iteration, going through it from left to right. We'll output that for every iteration. So now if I run this, we see sports and cooking printed in 2 lines because this executes 2 times. So these are arrays. The for off loop is interesting. And it's also interesting that in JavaScript, we got a lot of built-in methods we can use on arrays. So on hobbies, on that array, if I add a dot, my IDE suggests a lot of methods I can use on arrays in JavaScript. And all these methods help me go through the elements in the array, manipulate them, get a subset of that array, whatever I need. Often you'll see map, for example, which allows you to transform an array or transform the values. And map will actually return a new array, so it will not edit the old one, but give you a new one. And we can print that new one here actually. And just to show that the old one was not edited, we can print that right below. And now map always takes a function where you define how to edit that array or how to edit the elements in the array. That function will be executed on every element in the array, one after another, and you return the updated version of the element. So here we would get our hobby. You can name this however you want. And here I'm using an arrow function with 1 argument only, hence no parentheses. And in here, I'll return the edited version. For example, here I could take my old hobby string and simply add hobby in a white space in front of that. So I'm simply constructing a new string which keeps the old hobby name but adds hobby : white space in front of it. And yes, since we only got 1 statement in that arrow function with a return statement, we can get rid of the curly braces, get rid of return, and just return it like this. This would be the equivalent. And now if I clear this and I run play.js, I see the old array was not edited. That is my second output here. It's coming from this console log where I console log the original array. But the result of my map here is a new array where I have my edited items with hobby added in front of every item. And this is something you'll see me do quite a bit in this course. Use that map method. And as I mentioned, it's only one of the many methods provided here. Always check out the docs on MDN to learn more about all these methods. Link can be found attached to this video. And make sure that you understand how they work, or that when we use one of them in this course, you can quickly look that up in case it's not clear what exactly that does. Though, of course, I will do my best to explain it when we use it. But these are arrays, very important data structures, and some very important methods you can use on arrays. Now that we learned about objects and arrays, there's one common misconception I sometimes see in the Q&A section. Please Check out that video I linked earlier in this article where I talk about primitive and reference types in JavaScript, because that is a crucial concept. Objects and arrays are so-called reference types, and you'll learn all about that and what that is in the linked video, so I'm not going to re-explain it here. They are reference types, and therefore when I store an array in a constant hobbies, I can still edit this array without violating the restriction that constants must not change. Let me prove that to you. If I comment that out, and I add a new line here, and I use another method, the push method, which allows me to add a new element to the existing array. So this will not return a new array, it will add it to the existing array. And here, I will add programming. Now, if I now console log hobbies after pushing, and I run node play.js, you see that is the output. And we get no error about editing this constant. The reason for that is that reference types only store an address pointing at the place in memory where that array is stored. And that pointer, this address, has not changed by us adding a new element. So the thing stored in this constant is just this pointer, just this address, and this has not changed. Therefore, our constant value has not changed. The thing it's pointing at has changed, but that totally does not matter here. And this is something you have to understand so that you don't wonder what's going on when we do edit, in quotation marks, a constant value. We're not really editing the thing that is stored in a constant, we're only editing the thing that constant thing is pointing at. In modern JavaScript, there are two important operators you also should be aware of, since I'll be using them throughout the course as well. And that are the rest and spread operators. Now, specifically, the spread operator is one we'll use quite a bit. Let's say we want to implement a pattern where when we add a new hobby, we don't edit the original array, but we create a new array with all the old values and the new value. This is actually a pretty common pattern called immutability, where we never added existing values, but where we always replace them with copies plus the changes. And that is also a pattern I'll use quite a lot in the course. The idea behind that is that we avoid errors because we always have this clear approach of copy, then edit, and don't edit existing objects, which might lead to more unreadable code. Now, to copy an array, let's say here I create the copied array, we got a couple of possible techniques. One of them is to use the slice operator. Now, if I output copied arrays down there, and I run node play.js, I see sports and cooking, so I did indeed copy it. Slice simply copies an array. We can pass arguments to narrow down the range of elements we want to copy. With no arguments, we copy the entire array. Now, instead of slice, there's also a different technique. We can create a new array with square brackets, and we could add hobbies there, right? Now, what happens if we execute this? What will we see in the console? Well, if I hit enter, we see, well, it looks like a copy on first sight, but actually it's an array with another array in it. So the outer array has only one element, and that's the inner array. So it's not a copy, it's just a new array where the first element is the old array. And with that I mean the exact same object, not a copy of that. So we just created a nested array here. And that, of course, was not what we did want to do here. And here we can use the spread operator. The spread operator are 3 dots we can add in front of an array or of an object. And these 3 dots are an operator just as the plus or the minus are. And they do one thing. They take the array or object after the operator and pull out all the elements or properties, so all the elements of an array or all the properties of an object, and put it to whatever is around that spread operator. In this case, we got square brackets around the spread operator, and therefore all the elements which are pulled out of the existing array are added to the new array. And therefore, if I now run this file again, whoops, and I save it before running it again, now we see this was the output of the old approach, the nested array. Now we got no nested array anymore. We got one array, and this is now a copy of the old one because we take the spread operator to pull out these elements and add them one by one to the new array. So this is something you'll see me do a lot to copy existing arrays or objects. There it would work in the same way. We could have our copied person by using curly braces, then the spread operator, the 3 dots, and then the old person. And now if I console log the copied person here, and I execute this file again, this is our copied person here because I'm pulling out all these elements from that object and I add it to a new object. So this works for both objects and arrays, and it is syntax I'll use quite a bit in this course. Now this is the spread operator. I also mentioned the rest operator. And the rest operator is essentially the opposite. Let's say I have a function which I'll name toArray. It's an arrow function. And there I expect arguments, arg1, arg2, arg3. I want to return an array that contains these arguments. Whoops, and I should add an equal sign here. So I want to return an array that contains these arguments. I can return square brackets here, of course. And then the first element will be arg1. Then I have arg2 as the second element and arg3 as the third element. Now I can console log toArray, and I pass 1, 2, and 3 as the 3 arguments to that function. If I now execute play.js, we see an array with 1, 2, and 3, these 3 elements. So this is working. But this is totally not flexible. What if we want to pass 4 arguments? Well, we could call it like that. JavaScript actually allows that, but of course it doesn't get added because we only work with 3 arguments here. What we could do is we could use the so-called rest operator there, ... and then just args. And this will actually take all the arguments, how many we might specify, that doesn't matter, and it will bundle them up in an array for us. So here, args will be an array, and I can just return that actually. And now if I re-execute this with toArray getting 4 arguments, you see now I have my array with 4 arguments here. So the rest operator looks just like the spread operator, 3 dots, and it's the place where you use it that defines how you call it. Are you using it to pull elements or properties out of arrays or objects? Then it would be the spread operator. Are you using it to merge multiple arguments into an array, and you use it in the argument list of a function? Then it's the rest operator. It's the same operator by the syntax, or from a syntax perspective, the name differs depending on the place where you use it. I'll not use that syntax a lot in this course, but it's still nice to know. But being able to pull out elements or properties, that is something you should understand, because that is a syntax you'll see me use quite a bit throughout the course. Rest and spread are important syntaxes to know. Now I want to dive into another important feature, and that is destructuring. Now let me comment out this code down there, and let's begin with object destructuring. I got my person object, and now let's say we have some code where I only need the name. So I have a new function, print name, let's say, and that actually takes the full person object, because for whatever reason we wrote it like this, or we simply have a function where we are able to get multiple arguments or a full object because some third-party package always gives us that person. We can't change that. So we get the person here, and I only want to console log person.name. Now that is totally fine of doing it like this. I can now execute print name here. Now I need to pass person here. Now to avoid naming confusion, you can name this here however you want. So here we could name it person data, And inside here, we use person data. So that function does not use that person. It just expects any person data. We then call that function and pass in that person as an argument. And now if I execute that file, I see Max here. And this is stemming from this line here. Now, of course, we can absolutely do it like that. And we always get person data because, again, let's say this is a function which is actually called by some third-party package, which is a pattern you see quite a bit throughout this course. Now, therefore, we can't change the data we get. But in this function here, we are only interested in the name. We can then use a syntax or a feature called object destructuring, where we add curly braces here in the argument list. And we then specify the property of the incoming object we are interested in, name. That is this property we have here. Then this will be pulled out of the incoming object. The other properties will be dropped for this function, and it will be stored in a variable named name, which we then can use in there. So now if I execute this again, I also see Max. But now we're using this destructuring syntax. And we can pull out the age too if you wanted to, or the greet function. So that all works, and that is just a syntax we can use that allows us to write a bit of a more understandable code where we are very clear about what we need from the incoming object, and which then gets stored in a local variable that we can just use in this function. And you can, of course, not just use destructuring inside of a function. You can also use it outside of there. You can create a new constant here, for example, and then the syntax will look like this. Curly braces equals person. Curly braces on the left side of the equal sign are something we don't see that often in JavaScript because typically it's wrong, but for destructuring it's correct. And then here we can have the name and the age, and this will create two new constants which hold the values stored in name and age. So these names here have to match the property names of the person. And now we can console log name and age like this. If I now re-execute that file, this output here is coming from this console log, and the values we're outputting here are retrieved via object destructuring. Now there's also not just object destructuring, you can also destructure arrays. So if we go back to the hobbies, which we have here, well, then if we would want to destructure that, we can also create a const. You could also use let, by the way, the same for the object destructuring if you plan on changing it. You could use a const for hobby1 and hobby2 wrapped in square brackets, and then assign this to hobbies. And now if you console log hobby1 and you console log hobby2 and you execute that file again, you see the two hobbies being printed there. Please note there are no square brackets around them in the console log because we're not logging an array here. We are logging two individual values which we got via array destructuring. Unlike the object destructuring, here you can choose any names you want because in arrays your elements have no names. They are instead pulled out by position. So this will always be the first element, this will be the second element. In objects, you pull them out by name, by property name. So that is destructuring, and this is also something used in this course. It simply allows us to access elements in objects or arrays quickly by their name or position and to drop, and that does not mean delete, they're not getting deleted, they're just not used in our function or whatever we're writing. So to drop the data we don't need in that specific code snippet we're working on. Now, I cleared the play.js file again because to conclude this quick refresher module, I'll dive into another core concept, and that is how to work with asynchronous code. And for that, we first of all have to understand what asynchronous code is. Let's say I set a timer with setTimeout, which is a function built into Node.js. There, we define a function that should execute after a certain timer expired. Here I'll use an arrow function, you could use a named function, whatever you like. The second argument is the timer. Let's say 2 seconds. You express it in milliseconds, so 2 seconds are 2000 milliseconds. In there, I'll simply log timer is done. If I now run this file for 2 seconds, nothing happens, and then we see timer is done. Now this is asynchronous code because it doesn't finish immediately. And it would even be async code if we had 1 milliseconds there. So if it's super fast, it does not happen immediately. In other code snippets, like if we have console log hello and console log hi, these two snippets are synchronous code because they are executed right after each other. And yeah, technically, of course, Node will take some time to execute them, but there is no delay other than your hardware, so to say. And therefore, this is synchronous code. This is async code. Asynchronous because it does not execute or finish immediately. It takes a little time, even if that's super short. And indeed, if I execute this file like this, you see hello and hi before you see timer is done, even though it's super fast. Because Node.js and JavaScript in general does not block your code execution until that is done. Indeed, here, it will recognize this so-called callback function. So a function should execute in the future. It should call back later once it is done. So once this timer expired here. It will just recognize that and will then immediately move on to the next line and will execute all the synchronous code and then execute your async code once this is done, which is why we see hello and hi first, even though in our code, timer is done is printed first. And that is a crucial concept you have to understand in JavaScript and especially in Node, and I will come back to that throughout the course because it's so important. Now, when working with that, and I'll increase this to 2 seconds again to make it even clearer. Then you will see, again, our sync code runs, and then after 2 seconds, this code runs. When working with async code, we get multiple techniques of, handling it. The callback function is one, the oldest one, and you'll see it quite a bit, especially in Node.js. There's nothing wrong with it, but you'll face a problem if you have a couple of depending async operations. So here we set the timer, and now let's say I create another function which I'll name fetch data, and in there I will also just set a timer because I don't want to set up some database or something like that where we fetch data from. We'll do all that throughout the course, of course, no worries. So here again I have another timer in there, which takes like 1.5 seconds. And now here in fetch data, I need some way of, doing something when this inner timer is done. So here I will actually expect an argument, which I'll name callback, because this argument will be a function I will eventually call in my inner function here once I'm done with the timer. And there I can pass done as a value. Now in the place where I use fetch data, let's say that's inside of this set timeout call. I call fetch data like this. There I now need to pass another callback. And here I will get the text passed by the callback in my function when I execute it. So I will get some text here. And I can console log that text. Now this might look confusing. In the end here I'm creating my own function which gets a callback, so that I can define a function which should execute once this inner timer is done from some other place. So from this place here, this is the function which effectively is passed in as the callback. And I'm executing that function here. Now, if I save that and I run that, takes 2 seconds, then the timer is done, and then after 1.5 seconds I see done. Now, if we have a couple of nested async calls, as we have here, we go deeper and deeper from a callback perspective. And that is why we also have a feature called promises, which we can use in Node.js. Now, often we'll use third-party packages that already use promises for us. So the syntax I'll show you now is one you rarely have to write on your own. That will be done by the packages behind the scenes. Still nice to know. You create a promise inside of our fetch data function here, let's say, by storing it in a constant or variable, and then by using the new keyword, which you use in JavaScript to create a new object based on a constructor. If constructor functions are something that tells you nothing, check out some basic introduction resource to JavaScript, because constructor functions are a core feature in JavaScript. And here you use the promise constructor function, which is built into JavaScript and Node.js. And this actually also takes a callback, which gets two arguments, resolve and reject. You could name them however you want, but these are two functions. And the first one completes the promise successfully. It resolves it successfully. The second one rejects it, which is like throwing an error. You then take your async code and move it into there. And again, you rarely have to write this on your own. Most packages already do that for you and give you the finished promise, which does all the magic behind the scenes, hidden away from you. Here we do it manually. So now in that callback, we have our own function. Set timeout does not give us a promise API, unfortunately. So here we also have to use a callback. But in there, we now know no longer use any callback function we get. I get no argument here in fetch data anymore. Instead here, I resolve done, let's say. So I successfully return the resolve value. Now in fetch data, after defining the promise, we just have to return it. And please note, this is synchronous code. So actually, this will be returned immediately after the promise gets created, before the code in the promise is run, which will happen sometime later when we actually call that function and when this timer then completes. So we now return that promise here. And in the place where we call fetch data, we now no longer pass a callback, but we can now use then, which is callable on a promise, and we return a promise. And this simply allows us to now define the callback function here, which will execute once the promise is resolved. Now, what is the advantage of that? If we had multiple such promises, so let's say I call fetch data again in there, then I don't have to use then like this, and therefore I would end up with nested callbacks again. But instead, inside of a promise, and the then block is part of a promise, I can just return a new promise and then add the next then block after the previous one. Like this. So now we have a chain of then blocks. This one gets called on the first promise. Then in the then block, I return another promise. And even if that would not give us a promise, inside of a then block, returning it would convert it to a promise that instantly resolves. And then we add another then block, which is now referring to this promise here. And this is more readable than having infinitely nested callbacks. So now if I run that, we see hello, hi, the timer is done, we see done, and we see done again because I'm calling fetch data twice. So this might be difficult to wrap your head around for the first time. We will reuse it throughout this course, and then it will become clearer. Again, this code is mostly not written by you, but it is a crucial concept that makes our async code more manageable. There also is another way of managing this, async await, two special keywords you can use in modern JavaScript, and I'll have a separate section about this towards the end of the course. I don't want to introduce it here because it can actually be more confusing than this syntax here, and I want to stick to this one to not introduce too many new features at the same time here. Async code is something you have to understand though, and if it's not totally clear by now, that is fine though. You will see it throughout the course a bunch because we have a lot of asynchronous events in Node.js, and I will explain this multiple times. I'll also explain promises again. I just want to ensure that you have seen this by now and that you then have a chance of understanding this, how it works, and how we deal with it. That's it for this refresher module. Obviously, this is no complete JavaScript module. There are way more features which I didn't touch on, and the reason for that is simple. I do require very basic JavaScript knowledge at least. If you got none, check out the resources I linked in the second lecture of this module. These resources allow you to dive into JavaScript for free or with paid courses, whatever you want. And with that, plus this refresher about next-gen JavaScript items or features as well, you are more than prepared to continue with the course and now understand the code we will write throughout the course. I hope this was helpful. Let's now dive into Node.js and write exciting applications. To ensure that we're all on the same page and we all have the basics of React down, let's now have a brief refresher on React.js, understand what it is all about, how React generally works, and how you build modern front-end web applications with React. Now, one important note, though, this does not replace a complete React course. It's only a brief refresher having a look at some of the core fundamentals that make up React. I definitely recommend that you also have a look at a dedicated React course, like my React the Complete Guide course, if you want to learn all about React and if you want to ensure that you get the most out of this course as well. We're just having a brief refresher here. Now, in detail in this module, we'll have a look at the React.js basics and understand how React works there and how we can build web applications with React. We'll also have a look at how React manages state and stays reactive and what makes up React in the end. And with that, let's dive right in. So, what exactly is React.js? It's a JavaScript library for building user interfaces. And as such, it's all about running JavaScript in the browser. It's a JavaScript library for browser-side JavaScript code. It's not a Node.js library. It's a browser-side JavaScript library. Now, to be precise, React.js itself is referred to as a library because it's very focused on that user interface thing. But it actually started a huge ecosystem with other third-party packages that, for example, help us with app-wide state management or with routing, front-end routing, and therefore effectively you could also call it a framework, I would argue. But these are semantics, not too important right now. Let's instead understand how React works and how we use it. React helps us build user interfaces that are shown in the browser, that run in the browser, and therefore we use it to build the front end of web applications, what the user sees. React does not run on a server. React does not communicate with databases. We use it to build highly reactive modern user interfaces. And we do so by following a declarative approach, which means that in React we rather define the result and maybe different states of the result and under which state we want to render what and want to show what on the screen instead of the steps that lead to the result. That would be an imperative approach, which is basically what we have if we use vanilla JavaScript, where we have to define every step, add this element, add this CSS class to an element, remove this element. This is what we do in vanilla JavaScript. And this can be very cumbersome in very complex user interfaces. We typically don't want to do that if we're building bigger applications, because managing and orchestrating all these steps and ensuring that when something changes, we execute the right steps is very error prone and takes a lot of effort and work away from our actual business logic and from building nice user interfaces, and instead forces us to spend a lot of work on JavaScript primitives, on reinventing the wheel, and so on, and we don't want to do that. So in React.js, we instead focus on the result, and we do so by using components. Components is a concept introduced by React. Basically, these are UI building blocks, which we define, and you will learn how you do that in this module, of course, which we define, and then we compose our user interface from these components, and every component can also define what it should render under which circumstance, and React will then magically wire up everything behind the scenes and implement all these steps in the gray box here for us so that we don't have to write the steps, we just define the results. This is React.js in a nutshell. Now let's have a look at how it actually works when we write some code. For this, attached you find a starting project. This starting project was created with Create React App, a tool created by the React team in the end, which makes it easy to spin up new React projects and give us a project structure like this. I adjusted it a little bit, but generally it's exactly the same you would get from this tool. Now, why do we need such a tool? Why don't we just import a script in a HTML file and get started? Because React is a bit more complex than vanilla JavaScript. In the end, we ship vanilla JavaScript code, but the way we write the code is a bit more convenient to us as a developer. We can use certain features which wouldn't run in the browser, and therefore this project setup here has a couple of tools included which take the code we write as a developer and actually convert it to code that runs in the browser, so that we have normal code that is executed in the browser, but we have an easier time writing that code as a developer. In addition, we get a development server, which is a simple server that serves our front-end application, so which has no backend, only serves that front-end application, and which automatically reloads or injects changes whenever we change and save something in one of our source code files. In addition, here with React, we're building a single-page application. That's not a must-do, but it's a common choice. In a single-page application, you only have one HTML file, which in the end is returned by the server serving that application, in this case, this HTML file, which itself is relatively empty. But this file will then later include script imports. They will be added automatically by these tools I mentioned earlier, which in the end host and run our React application, which we in turn write here in the source folder with our files we got there. So that in the end, we have a web application, a front end, which consists of one HTML file, where then JavaScript is used to render something on the screen and re-render that something on the screen when it's needed. And that allows us to build highly reactive modern user interfaces where everything happens instantly. Because JavaScript runs in the browser, things happen instantly. We don't need to wait for a new HTML file to be downloaded from a server. Instead, everything is already there. So when a user clicks a button and we want to show a box on the screen in response to that click, boom, it happens instantly because of JavaScript. That's the feeling we want to provide, and we can do that with React. Now, enough talking about the theory, let's write some code. As I mentioned, we do that here in the source folder, where we find an index.js file and an app.js file. Both very simple files. Now, let's have a look at the index.js file. There you see we have a couple of imports at the top. This is, by the way, how you import code on the front end. Import something from, and then either a relative path to your own file, or if it's a third-party package, just the package name. And then here we have imports from our own files with a relative path, as I mentioned. And then here we are executing one command in the end, React DOM render. Now this is coming from the React DOM object here in the end, which we're importing from the React DOM library. And that renders this strange thing, which is not regular JavaScript, into this place on our HTML page. This is regular JavaScript, and here we are selecting the element with an ID of root. If we have a look at our single HTML file, that is this div here. So that is in the end where our React single page application will be hosted to, and thereafter React will take over and render everything in that place. So that is what we're doing here, but what is this strange thing? Now for that we need to understand what components are and how React works. So we learned that we have this index.js file, and I can tell you that this file in the end includes the code which executes first when we start our app, and that this renders this strange thing into the place of this div here. Now what is that strange app thing here? We're importing app from this app file, in the end from the app.js file, because extensions are added automatically on the imports. And there what we have is in the end a JavaScript function. This is a regular function, an arrow function stored in this constant, and then we export this constant and therefore this function. Pretty straightforward. But the thing inside of the function is not straightforward. What we return here looks like HTML, just like this looks like HTML. But it's in a JavaScript file. It can't be HTML, right? You can't add HTML in a JavaScript file. That's a special syntax invented by the React team. It's called JSX, and it allows us HTML-looking code in JavaScript files. And under the hood, this will be translated to instructions React understands. In detail, this here is similar to React create element, a method provided on this React object here, and then here h1, and then here null or an empty object, and then as a third argument your text here. For example, hi, this is React. Different text than before, but it will render something similar on the screen. This will yield the same result, and I can prove that to you if we simply start our development server and try to see this app in action. To start it in the package.json file, we find a script, the start script, which already exists there. And this will in the end use that tooling I mentioned earlier to then transform our code and to start up a development server, which automatically reloads or injects changes when we change something. So here we can open up a new terminal integrated into this IDE, and there run npm start to bring up that development server. And you should keep that server up and running as long as you are working on your code, because when you close it, you can't preview your page anymore, your app anymore. Now, when you start this server, when you run npm start, it should automatically open up a new tab in the browser on localhost 3000. If it doesn't, simply do so on your own and visit it. And there you should see, hi, this is React, which clearly is the text I entered here. So in the end, this here is React syntax, and we could write our entire app with this syntax. But this gets very cumbersome, especially if we start nesting elements into each other. That is why React gives us this alternative JSX syntax, which in the end is just translated to React create element and then what I just showed you. That's also why we need to import React here, even though it looks like we're not using this React object anywhere in this file, right? We have this React text here, but that's something different. So we're not using it anywhere in this file. Well, it gets used implicitly because this is just syntactic sugar in the end. It is translated to that other syntax I showed you. And that is what React is all about. We tell React which elements it should render. And under the hood, it then will translate this into commands that the DOM understands, that the browser understands to render real DOM elements. Now, for example, if I add the title here, which gives us this tooltip that's built into the browser basically, this works. And I save this, it automatically reloads. You don't need to do so on your own. And if you now hover over this, you see this tooltip. This works. Very small here, but you can see it if you test this on your own system. Now, this works because that in the end is translated to React create element h1, then this object which we previously left empty. Here we set the attributes or the properties we want to set on that DOM node which is created here. In this case, title to this works. And then thereafter, we have the text. This is how this works, and React will do everything it needs to do. It will create this element, it will set all these properties or attributes here, and it will render the last argument here inside of that created element. And that's also the part where this JSX code helps us, because if in here we have, let's say, another HTML element, we would have to nest multiple React create element calls into each other, which quickly becomes very hard to manage. That's why this JSX syntax here is a great idea, a great invention. So we will use this syntax, and we also use it here in index.js. The difference is, though, that here we don't use it with a normal HTML DOM element, but instead here we use a custom function, because we are using what gets exported in the app.js file. And what we export there is a normal JavaScript function. Well, that is one of the most important concepts of React: components. React is all about components. Now, what does this mean? This function here is of course a regular JavaScript function, but it's also a React component. What makes up a React component? A React component can be one of two things. It can be a function which returns JSX or returns React create element calls, or it can be a JavaScript class that has a render method. So this here, if I change this, would also be a React component. Class app extends React.component. That's important. You have to extend React component. And then you have to add a render method. And in that render method, you return JSX. This is a regular React component as well. And if I save this, you therefore see the same output as before. It works in basically the same way. There are some technical differences, which I discuss in detail in my React to Complete Guide course. Here, it doesn't really matter. In modern React, you can use functional components only, so function-based components, and that's therefore what we'll do in this course. We'll write every component as a function. It's not a must-do, and as I mentioned in my React to Complete Guide, you learn about both types and how they differ, but using function components only definitely is a modern way of using React, and it is therefore the way we will use. But always keep in mind that this is just a regular JavaScript function. What makes it a React component is that it returns this JSX or this React create element logic in the end here. If we return, let's say, an object instead, this would not be a React component, and hence you get an error if you save this. It really has to be JSX code, something which can be interpreted as JSX, like this here. This is how React works. And therefore here I am exporting my own component because this is treated as a component, and your own components can be used in JSX as well. The only important thing there is that they should start with a capital character in the file where you use them in JSX, because this tells React that it's not a built-in HTML tag. App wouldn't be a built-in tag, but that it's a custom component. And this information is important to React, and therefore start with an uppercase character, but then you can use any custom component in JSX. And the cool thing now is that we can build up our application from small reusable components and compose our user interface with the help of such components. And with that, why don't we do that? Why don't we build a simple first React application and see how things work together there? Now, in this refresher course module here, we'll not write a complex React app because that's simply not the idea of this module. We will write a realistic app in the main module later in this course, after this module here, where we will work on the course project. So that's just a refresher here, and I focus on the core React elements therefore, and not on building an amazing application. So React is all about components, and therefore typically we split our app in components. Now let's start without splitting it though, and instead of outputting a h1 tag, here in app, I will use a div, let's say, and in that div, let's add more HTML code. I'm saying HTML here. Of course, it's JSX, but it is translated to HTML, to DOM nodes in the end, right? But it is JSX. So here we could have a h2 tag where we say course goals. And below that, we want to have a list on, or the list of our course goals. And there, a goal could be that we want to finish the course, that we want to learn all about the course main topic, and that we want to, let's say, help our students in the course Q&A section. And that could be some goals. Now, a very trivial application. Now, I don't have any special spectacular styling here, which is why we save that and we get this output. Now I will add some styling, and for that I will add a app CSS file here and import that file into the JavaScript file. This of course is not possible in vanilla JavaScript, but because of that under the hood tooling, which in the end analyzes our files and then transforms the code, this is possible, and this is simply transformed to inject this CSS code into the HTML file as well. Now here I'll give this a CSS class, and there is one special thing. The class attribute like this doesn't exist in JSX because class is a keyword in JavaScript. So it is class name. And this is how you add CSS classes to elements in JSX. This also, of course, is kind of a proof or reminds you of the fact that this is not HTML, but HTML-ish looking syntax. I'll name this class goal list here. And now in here, we can define some styles for the goal list here, and I will simply set list style to none here, remove a margin or give it a margin of 2 rem top and bottom, and a padding of 0. And on every goal list item, I will add a margin of 1 rem top and bottom, 0 to left and right, and then simply a border of 1 pixel solid, and then this grayish color here, and a padding of 1 rem. And this is very, very simple styling because I don't want to spend a lot of time on writing CSS styles here. Now, maybe one adjustment. Let's actually give the list a margin of 2 rem in all directions. Now we have this list of our goals. To adjust the course goals here at the top, I will also give this div a class name of course goals. And then in the CSS file, maybe at the very top, we can style course goals and there the h2 tag to be aligned in the center, just like that. Now, again, very huge goals, but that is okay for this course here. We're just practicing React. So we got these course goals here. Awesome. This, of course, is a very simple markup. Now, what you often would do in React is you would split this into more components. You would, for example, outsource this list into a separate component to keep every component on its own, relatively lean and focused on one task. For that, we can add a components subfolder here in the source folder. And in there, I will add a goal list.js file. This will hold my goal list component. Now, to create such a new component, we first of all have to import React from React. Otherwise, we can't use this JSX syntax. And then I mentioned that a component is a function. And by the way, you can also create it with the function keyword or with the function expression or with the arrow function syntax I used before, which is the syntax I will use here, but that is not a must do. And then here I export my goal list like this. And now in here, I return this unordered list. So I'll cut it here and then add it here as a return value. And if I reformat that, you see automatically these parentheses are added around it so that this can be nicely formatted across multiple lines. Otherwise, this would not be valid JavaScript. So it is. With the parentheses, it is, because then JavaScript knows that this block belongs together. So now we have the goal list in here. And in app.js, we can now import our goal list component. You can name this here however you want. Doesn't have to be the same name as under which you export it here. Only important thing is that it has to start with an uppercase character here in app.js. And I import from the components folder and there from goal list. And as I mentioned earlier, you can omit the file extension here. It's not required. And then here you use goal list like a regular JSX element, like a regular HTML element, you could say. But since we have no content between the opening and closing tag, we can and we have to write a self-closing tag here. This would not be allowed. You always have to close tags in JSX. So this would now be my goal list component. And therefore, if we save this, we see the same output as before. We also get the same styling because styles here are always applied globally, even if you import them into a specific component file. And still, it is a good practice to set up the styles in the CSS file next to the component they belong to. Hence, I will add a goal list CSS file, add my goal list styles there, and import that goal list CSS file into the goal list JavaScript file. This is not a must do, but it makes it easy to find the styles that belong to this component. Keep in mind that styles are not automatically scoped to a component though. The normal CSS rules are applied because all the CSS files, no matter where you import them, are applied globally to your entire page. With that though, we're back to the same result as before. So why did we do that then? Why do we split this up if we have the same result as before? I created the separate component A, of course, to practice creating your own components, but B also because it really is the core philosophy of React to split your app into smaller pieces. Of course, it's up to you how small you want to split it. Every list item, for example, could also be its own component, and there would be nothing wrong with that. The idea simply is to have small, manageable code files, and later, once we add more logic to the app so that we can also interact with it and we change the number of goals, for example, upon a button click and so on, we of course want to be able to manage a lot of the logic in the goal list component and not in other components. So really splitting it into components has the idea of separating concerns, of keeping your files small, focused, and manageable, which, if you're working in bigger projects, is a huge win because it makes it much easier to manage and work in such bigger projects. Now, thus far, everything in our app is hard-coded though. Now, more realistic would be that, let's say, our goal list is managed here in app.js as data, and we want to render the goal list HTML items or JSX items based on that data. Now, I'll manage it here in app.js simply because later I will add another component here that helps us create new goals. But for now, let's just add a normal constant here to this functional component because it is a normal JavaScript function. Of course, you can do more than just return JSX. And this constant here will have my course goals. You can name it however you want. And this will be an array. And in this array, each goal can be a JavaScript object created here with the object literal notation. Of course, you could also create your own class or constructor function and instantiate that to create such an object. Now, let's say every goal has an ID, CG1 for course goal 1, and then has some text, let's say. And the text here is simply the text I have hard-coded here. Finish the course. So I'll copy that and add this here. And I'll split this across multiple lines to make it easier to read. Because I'll not just have one goal, but 3. So the IDs are CG2 and CG3, let's say. And now I will just copy all that text here into my objects here in app.js. Also that last text like this. And there I can now also get rid of that ampersand thing here. We don't need that here. We can output the text like this, and React will render it properly. So now we have the course goals array, and my idea now is that in the goal list component, these goals, that data here, should in the end be output. So it should be output dynamically in this component, in the goal list component, instead of being hard-coded. So we can remove this code here. Now that leaves us with 2 problems. Number 1, how can we output a list of data dynamically in JSX? But more important than that at the moment, how can we get that list of data, which is defined in the app component, into the goal list component? Well, let's focus on that first, because without that, we can't focus on the other problem. We can pass data from component to component with a concept called props, short for properties. We can define our own, you could say, attributes, which are these props, on our own components. So for example, here on goal list, we could say we have an items attribute or a goals attribute, totally up to you. I'll go with goals here. And that goals attribute, or prop is the common term, so this goals prop, then passes data to that component. Now for that, I don't use a string here, which I want to pass down, but instead I want to pass down my JavaScript data structure, the array here. And for that, here actually we use another special syntax in JSX. We use single opening and closing curly braces. Looks like we're creating a JavaScript object here, but we are not. If you do this inside of JSX, which I am doing here, that's JSX, then this means you want to merge your JSX code with some JavaScript expression in the end. And here we can point at course goals. That is a valid JavaScript expression. We're just pointing at a constant. And what this in the end means is that React will pass course goals here, the value stored in this constant, in this case this array, into this place of JSX. In this case, into this prop, therefore. So goals will be a prop that holds a reference to this array now. Now inside of goal list, we can now receive that goals prop. So let's go to goal list and see how that works. in goal list, we have a function, right? A functional component. Now this function right now doesn't get any parameters. We can change this. We can receive a props parameter here. Every function that is used as a React component, which means it returns JSX, also receives props. This is an object passed to your React functional component automatically by React. And it's an object that bundles all the props you passed to the component. So in our case, goals is the single prop we have. So here we will have an object which has a property with the name of goals that holds the value passed to that prop. So in other words, here I could console log props.goals. .goals because I named my prop goals here. If you chose a different name here, which is perfectly fine, you have to use the different name here. Now if we save that, we won't see our goals anymore at the moment. But if we open the developer tools, we see the array being logged here, and that log is coming from goal list line 6, as you see, which of course is this log here. And there we see our goals data, which means, yes, it arrives successfully inside of the goal list component. The concept of props is a super important concept in React, because this is what allows you to pass data from component A, the app component, to component B, the goal list component in this case. Now let's have a look at how we can output a list of data dynamically in JSX, because here we got a list of goals, an array of goals, and we want to output this as list items here in our unordered list. How can we output an array of data as JSX elements? Well, actually, it's relatively trivial. We will map this array of JavaScript objects to an array of JSX elements because React is capable of outputting an array of JavaScript elements. For that, let me show you how this works. Let's use these single curly braces because I want to add a JavaScript expression here. And my expression here is a simple array, but an array of list items. Hi, and then another one. This works. I output this in my JSX code with the single curly braces because this here, of course, is not JSX, it's an array, but it's an array full of JSX. And if I save this, it outputs hi and this works. We get an error or a warning, which you can ignore for now, but this works in general. Now, since this works with hard-coded data, we can also output our array of goals. So we can output props goals here. But the problem is that props goals is in the end an array of JavaScript objects, not an array of JSX code. So if we try to output this here, it will fail. It tells you that objects are not valid as React child or as React children. So in the end, we can't output plain vanilla JavaScript objects in JSX. Instead, we need to map every object into a JSX equivalent, so into a renderable element. So here we want to map every object into a list item in the end. So on props goals, which is an array, we can call the map method. That's a default vanilla JavaScript method that exists on any array. The map method takes a function, here I'll pass in an arrow function, which is executed on every element of the array you call map on, and then this function here will return a transformed version of that element in the original array, and overall map will then return a new array full of these transformed data pieces. So this function will therefore receive the existing element here, so every goal in our goals array, and then returns a new element. So in this new array returned by map, I want to have a bunch of JSX elements. So here I will just return a list item, which is JSX, of course. And in that list item, I want to output my goal text. Now, goal here is that JavaScript object we have in the original array, because this function runs on every element in the original array and gives you the object in the original array, or the data piece in the original array, as an argument. So goal here is that object which looks like this here. So I'm only interested in the text here. And again, we can output the text by outputting a JavaScript expression here. Hence, we need the curly braces in our JSX code here. And we have goal.text here. My expression is that I access the text property on the goal object. So now what happens here is I map my array of plain JavaScript objects to an array of JSX elements. And such an array of JSX elements is renderable, as you learned. So now if I save this, you see this outputs my course goals again. Now we also get a warning regarding a unique key that is related to how React re-renders the DOM and that it wants to do this efficiently. You learn more about that in my React the Complete Guide course. And therefore, whenever you output lists of data with this technique, you have to add a special prop to every item you are rendering in that list, in this case to every list item, and that's the key prop. That is a prop React itself understands, and here I want to output goal ID, again wrapped in curly braces because this is a regular JavaScript expression. So now with that we don't get the warning and we get our course goals. So this is how we output a list of data. With that, this is looking pretty good. We're outputting our list of data. Why don't we now work on adding some functionality that allows us to add our own goals? That would be a nice next step. To output our own goals, I'll add a new component in the components folder. And to keep it manageable, I'll actually create a new subfolder for every component. This is not a must do, but I personally like doing this because then I can quickly find all my components. Of course, you now need to adjust your import here in app.js. My IDE did it automatically. In case that did not happen, make sure you adjust your goal list import to reflect that new folder I added. And then I will add a new goal component here in the components folder as well. In there, add a new goal.js file and a new goal.css file if you want to apply some styling. Now in a new goal.js file, we first of all need to import React from React. You always need to do that, otherwise you can't use JSX in that file because, keep in mind, JSX is translated to React create element. And then here I have my new goal component here. We could accept props, but as long as we don't need them, we don't have to. And then I export new goal. Now in app.js, I want to render new goal. So I will import new goal. Again, the name here is up to you, but it should start with a capital starting character. And I import this from components, new goal, new goal. And then here we can render this above our goal list, let's say, like that. Now this wouldn't work because new goal is not yet a valid React component because it's a function right now, but it's not a function that works as a React component because it's not doing one crucial thing. It's not returning JSX. So let's return some JSX here. And there, to keep things simple, I'll add a form. And in that form, I'll add an input field, type text, self-closing element. In regular HTML, this doesn't have to be self-closing. In JSX, it does have to be self-closing. And then a button, which is of type submit, where I say add goal. A very simple form. And if we now save that, you should see it here. Now let's add some styling to make this look a bit prettier. For that, I'll add a class to the form, new-goal, and I'll import the new goal CSS file into the new goal JavaScript file. And then here on the new goal class, which is added on the form, I'll add a margin of 2 rem in all directions and text align center so that this looks a bit nicer. And now we could also style the input and the button, but I don't want to spend too much time on that, so I will leave it the way it is. Now right now when you click the button, by the way, this page will reload because right now the default browser functionality will kick in, which is that when a button of type submit is clicked in a form, a request is sent to the server that served this page. Now that's not the behavior we want here though, because here I don't want to send a request to any server because we're not doing anything on the server side. Instead, I want to handle that click with JavaScript. And that is the first thing I'll do here. Let's see how we can handle events, because thus far we haven't done that. I want to handle the submit event of this form here. And React makes that simple. We can add event listeners to any element, not just to the form, but to any element by adding on lowercase on, and then the name of the event. Now, not every event is supported on every element, but here you got the default HTML elements available. So for example, on a form element, you have the submit event on submit. On a button, you also have on click, but since it's a button in a form, it's better to handle this on the form itself. Now, what do you pass as a value to on submit though? As a value, you have to pass a function that should be triggered when this event happens. So a pointer to a function. You could do this here with curly braces and then an anonymous inline function, but I don't like that too much. Instead, I will create a new function here. And in JavaScript, you can create functions in functions. So instead of the new goal function, which it still is in the end, I can create a new function. I will create my add goal handler. Now the naming is up to you, but I like this naming of having handler at the end of my function name if it is a function that is triggered upon some event. So this is a function. In this case, I'll again use an arrow function, which is not a must do, but I will use only arrow functions here. And onSubmit now can point at add goal handler. Don't execute it here, so don't add parentheses. Instead, you just want to point at the function so that the browser and React, in a common effort, can execute this function for you when this submit event occurs. Now, this function will get an event object, an event parameter, passed in automatically by React. And there, for example, we can call prevent default, which prevents the browser default of sending a request to some backend, which it shouldn't do here because we're not handling this on the server side here. Our server only serves that single index HTML file. It does not have any logic to handle any submissions. Instead, I want to handle it here in JavaScript on the front end in my React application. And for the moment, I'll ignore what the user entered here, and I will simply instead create a dummy goal. And I want to pass that dummy goal to app.js and add it to my course goals here so that it then is rendered here. Now, step by step. We can create a new dummy goal, of course, in that add goal handler by adding a new goal constant here, which is a JavaScript object. The ID here could be a random number with math random. This, of course, is not really a unique ID, but it's good enough, and I'll convert it to a string. It's good enough for our demo application here, I mean. And then the text here later will be the text the user entered here. For now, just some dummy text. My new goal. So now we have the new goal here. And of course, we can console log that to see that everything up to this point works. So if we save that, we see our form here. And if we click on add goal, the page will not reload, but instead we see this dummy goal here. And I can create, of course, multiple goals, but at the moment they're not added to this list. To add them to the list, we now need to get that goal out of the new goal component to the app component. Now before, we learned we can pass data around with props, but that was from app to goal list, so to a lower level component, a component which is included in app. Now it's the other direction. We want to pass data from new goal to the parent component, so to the component which includes the new goal component. How does this work? You can also pass data back, and you still do this with props. The idea just is that instead of having props that pass in data like a string or an array or an object to the lower level, to the child component, as it's also called, you pass a callback function from the parent component to the child component. So no array or anything like that, but a callback function. So here in the app component, we could define a new function, add new goal handler. The name is totally up to you. And I name it handler because it also will kind of be triggered upon an event. And here I expect to get the new goal. And then here I can reach out to course goals and, for example, push the new goal into this array. And thereafter, console log course goals. Now we have this function, and now we can pass it to new goal via props. So there we could add a prop onAddGoal, this is now not an event listener React defines. For all the built-in HTML elements, we have built-in event listeners. Like for example, in the new goal component, on the form, we had onSubmit. On a button, we have onClick. On input, we also have onClick, for example, because you can also handle click events on inputs. You can handle those on any HTML element. Now, in the end here, I called this an event handler. But what it actually is just a prop. Technically, there is no difference between class name, where I pass in a string, and onSubmit, where I pass in a pointer to a function. So in the end, this is just a prop of the form element which React offers to you. So here in app.js, we can also pass a prop here on new goal, which holds a pointer to a function. I just name this prop like this, not because I have to. I could name it add goal or this here, but it's a convention to name props which in the end pass functions to lower level components like event handlers, because the functions you pass down to components in the end will be called by these components upon certain events. That is how it typically works, and you will see that the more React applications you build. So therefore, I follow this convention and name this onAddGoal and pass my addNewGoal handler to the newGoal component. So I pass a pointer, not the execution, but just a pointer to this function to newGoal on this onAddGoal prop. Now that means that inside of newGoal, I can now accept props here. I can accept this props parameter. I always get it, even if I don't get any props. But if I don't get any props, there isn't much sense in explicitly writing it out here. But now I need a prop, which I'm getting on newGoal. And that is that onAddGoal prop I defined here. I want to call that function I receive on that prop here inside of my addGoal handler in newGoal. So instead of logging the newGoal, I can now call props onAddGoal here. OnAddGoal, because that's the name I chose here. And onAddGoal passes a pointer at a function to the component. So inside of the newGoal component, I know I can execute onAddGoal because it holds a pointer to a function. So I now execute that function it pointed to. And I can pass my newGoal as an argument to onAddGoal because indeed, in the function I passed to onAddGoal, I expect to get a newGoal as an argument, as a parameter. So now if we save everything, we should see that if I click add goal, we're outputting something from app.js line 16, which is this log here, and we're outputting our new course goals array, which are our old goals and the new goal. So passing the goal from the lower level, from the child component, the new goal component, to the parent component, the app component in this case, works. And it works with props. We just use props to pass a function that is then called by the child components instead of passing data directly from parent to child. This gives us a way to communicate back from the child to the parent with help of such a function. So now we're able to communicate back, and we are actually updating our course goals array in the app component. But what you see is, despite the array being updated, and clearly the new goal is part of the array, our output here on the screen didn't change. And that leads us to a core concept of React: state. React does not re-render this JSX code and therefore the real UI all the time whenever some event is triggered anywhere in the app. So just because I click this button here does not mean that React will re-render the entire screen just to make sure it doesn't miss any data change. This is not how React works. Instead, in the end, you have to tell React when it should re-render. And you do so by using a concept called state. This course goals array here is a regular JavaScript array. Put in other words, React totally ignores it. We have to tell React that it should not ignore it, and that instead, whenever we change this array, it should update the UI, the JSX code of the component in which we changed it. So in this case, of the app component. Now to do that, we import one other thing from the React package, and that's useState, a function built into the React library a so-called React hook, and you'll learn more about hooks in my React the Complete Guide course, of course, a function which we can execute inside of functional components and only inside of functional components. In class-based components, you also have a state management mechanism, not focus of this course here, but you could also do it there. But in functional components, you use these hook functions, as they are called, all these functions starting with use at the beginning, to manage state. So to manage data, which when changed should lead to the UI of that component in which you manage the state to re-render. So here in the app component, I now want to call use state, and to use state, I pass this array here. This is my so-called initial state then. I can get rid of that constant for now. This tells React that this component has some state and that this is my initial state. By the way, you can also have multiple different state pieces and they're all watched independently. But here I only have one main state, and that is my array of goals. And I tell React that I have this state and that this is my initial state. Now, of course, I want to get access to that initial state, store it in some constant, so that I can use it in the rest of the component, because course goals is now missing everywhere. So use state also returns something. It returns an array of exactly 2 elements. The first element always is our latest state snapshot, so either our initial state or, once we changed it, the updated state. And the second element of that array returned by use state is a function that allows us to update that state, replace it with a new value, and tell React that it should re-render. So here I will use array destructuring by using square brackets on the left side of my equal sign here to extract these 2 elements I have in the array returned by use state. And there are always exactly 2 elements. So it does not depend on which kind of state data you pass here. Use state gives you an array with exactly 2 elements. First element, your current state. So in my case, my array here. Second element, a function to update the state. Therefore, typically we name this set, and then any name of your choice. Set course goals in my case. So now I have 2 constants created with the help of use state. First constant holds my state snapshot. Second constant actually holds a function which we can call to update that state snapshot. And we will call that function here in add new goal handler. We can call set course goals here. And now I want to update my course goals by adding a new goal. Now, a simple form of doing that is to simply then use my old course goals and call concat here. Not push, because push modifies the existing item. Instead, set course goals wants a brand new array, which will replace the old array. And concat will also add an item to an array, but it will return a new array to which this item was added. So it gives us a brand new array, doesn't touch the old one, and we then pass the brand new array to set course goals, and React will then use that brand new array to, under the hood, replace the old array in its internally managed state, and it will re-render this component once it did so, and therefore update this course goals constant with the new array in the next render cycle, which in the end means that React will execute this function here. And therefore, when it does so, it will reflect that new data in our JSX code. So here I want to concat my new goal. And if we now save this and I click add goal, you see new goals are added to the list. Because React now re-renders this screen or the parts that need to be re-rendered whenever we update our state. Now, how exactly React re-renders and so on is not the focus of this course. You can learn that in dedicated resources like the official docs or my complete guide. For now, it just suffices to know that React magically and efficiently does re-render the page or the parts of the page that need re-rendering based on the state changes we applied. State is a crucial concept in React, and therefore it's important to me that you understand how it works. Use state is how you manage state in functional components, and your state can be anything. It doesn't have to be an array. It could be some text, a number, an object, an array, a boolean, anything like that. Use state always returns an array with 2 elements, no matter what your state is. If your state is a number, use state still returns an array with exactly 2 elements. because the first element then always is your latest state snapshot, and the second element is a function that allows you to update that state snapshot. Whenever you update the state snapshot, React will do two things. It will update the internally stored state data. So for example here, when we add our first new goal, it will replace the initial state with our brand new state, in this case with the brand new array we created with concat. And once it did update the data internally, it will call this component function again and execute the entire function, and hence also re-render this JSX code. Now under the hood, it will not re-render the entire DOM, it will just check which parts of the DOM need to be updated, but it will re-evaluate the entire component. This also means, of course, that it re-executes useState, but useState internally works such that it only initializes that state when the component is rendered for the first time, and for subsequent re-render cycles, it just pulls out the latest state snapshot and basically ignores the initial value we set up here. This is how state works. Now, it is also important to understand that this way of updating our state in this scenario is not the best possible way. So I'll duplicate it and comment it out so that we still have it for reference, but we also see the better approach. This approach clearly works, and in most cases it will work. But you have to be aware that this whole state updating, re-rendering part of React is in the end managed by React. And when you set a new state, it doesn't pause everything and immediately re-render your app. Instead, it schedules the state update. And if you have an application with a lot of ongoing state updates and a lot of work being performed, which is not the case in this application, but can be the case in other applications, then your state update might be deferred by a few milliseconds. That means that actually maybe if a user clicks add goal multiple times, the course goals which are currently rendered on the screen might not be our latest state, because not all state updates might have been processed yet. Therefore, there is a better form of updating this. Instead of passing our new state data to set course goals, you can pass a function to set course goals. A function which receives the latest state, pref course goals, and has to return a new state snapshot. And React will then schedule all these function calls and guarantee you that they are executed in the right order, so that even if a state update was deferred, by the time the update thereafter executes, it guarantees you the first one executed as well. And then here you would simply therefore return pref course goals, which still is an array, concat new goal. It will yield the same result as before in this app, and in this simple app, this approach would have been fine. There is basically no chance of React deferring updates so long that we would end up with an incorrect state. But this is the bulletproof approach which will always work. You only need it if your state update depends on the previous state's data, as this one does. If your state update is a new data piece which doesn't depend on the previous state, you can always safely use this non-functional form. And here, side note, we can of course also shorten this, take advantage of arrow function syntax, and get rid of the return statement and the curly braces, since we have only one expression which we immediately return. So now with that, it works as before, but this is a bit of a safer approach and the recommended approach if your state update depends on the previous state. State is a crucial concept in React, and with our knowledge about state, we can now also make sure that we don't just create a dummy goal, but we actually reflect the real user input. So for that, let's go back to new goal. What we want to do is we want to store the user input in some variable on every keystroke, so that we have the latest value entered by the user, and then pass that entered value to props on add goal, or to our new goal here, instead of that hard-coded dummy text we have at the moment. So here in new goal, I want to capture the user input here and send this instead of my hard-coded text here as part of the new goal. So we could create a variable here, user input or entered text maybe, which is an empty string initially. And here on input, there actually is an onChange event we can listen to, which is fired on every keystroke. So now we can add a function, text change handler. There we will get an event object And that event object will hold the user input on event target, which refers to the input element dot value. And therefore we could set enter text equal to that. Now enter text will change with every keystroke once we bind onChange to text change handler, like this. Now here in new goal, we can use enter text, so what the user entered here. And then thereafter, let's also console log the new goal here so that we can see that this works. If we now save this and I enter test here and I click add goal, we see this works and this is output here. This approach is generally fine, but it can have one tiny flaw. What if we want to reset this after adding a new goal? Of course, we can go to our add goal handler. And once we created the new goal, we can of course set enter text back to an empty string. But of course, this won't do anything. If I enter this goal, you see this is not reflected here. Why is it not reflected? Because the new goal component didn't re-render. This is not state we're managing. This is a regular variable. So of course we can change it. Of course we can use the changed value. But if we then set a new value to it, this is not reflected on our input because this input only has a connection to the text change handler. It does not know that it should reflect the current value stored in entered text. Now we could tell the input component that it should do so by binding its value prop. We can bind this to entered text, and with that we tell the input component, hey, the value displayed in the input should be the value stored in entered text. If we do that, we'll notice something new. Now we can't type there anymore. If I type here, the input is not reflected. Now if you think about it, that makes sense. What you're telling React is that input should be rendered such that the value is the entered text. With every keystroke, we change entered text. But entered text is not state, it's a regular variable. So that means that we change the variable with every keystroke, but React doesn't re-render the input component. It doesn't reflect the updated value. To React, the value always is an empty string because that was the last time it rendered this component and therefore this JSX code and therefore this input. So we need to tell React that this is some state and that when it changes, it should re-render our JSX code. So again, we can import use state here and convert entered text. Use array destructuring here. And use state is an empty string initially or has an empty string initially here because I'm managing my entered text. And the second element is a function to update the state, which I'll therefore call set entered text. And now here on every keystroke, I set my entered text to the value in event target value. And here we don't need that function form of updating the state because we have a brand new value that doesn't depend on the previous state. So we can just update the state like this. And now this will re-render this component whenever we type, whenever we call set enter text, so on every keystroke, which sounds horrible, but which is great. React will do this in a very efficient way. And therefore, this latest value will be reflected on the input element. And here in add goal handler, if we want to update enter text and reset it, we can therefore call set enter text and set it back to an empty string. And with that, we now have the best of both worlds. We can enter something here, that all works, but we also can manipulate it and reset after adding a new goal, like this. So this is now another use case for state management. And of course, there are many use cases in a React application. And here we are using state management to create something which is also sometimes called two-way binding. We're binding the value of the input, and on every keystroke, we're updating the value which we then bind back to the input, so that we always reflect the latest value inside of the input, but we also are able to manage this in a state-driven way, so that we also have a chance of manipulating the value from inside our code up here and reflect this back into the input in this case. With that, we have another scenario of state management, and we are now able to add our own goals. This is React in a nutshell. Now there is way more to React, and we'll see way more throughout our course project, where we will build an entire app with React, where we will also add routing and do more complex user input management and so on. But for this refresher, we learned everything we need. Now, as I mentioned multiple times, really also take some dedicated React resources, no matter if that's my complete guide course or the official docs or any other tutorial, if you are serious about React. This course has not the goal of teaching you React from the ground up. I do explain a lot to ensure that we're all on the same page, and I will explain every feature we add throughout this course, but in dedicated resources, you simply get a way deeper and better insight into React, into all its features, including features which we don't need in this course, and how it works under the hood. So that's my strong recommendation. From this refresher, the most important takeaway is that you understand that React is all about components, that components are functions that return JSX or JavaScript classes with a render method, which we don't use here though, that components can receive props to receive data from parent components, that props can also receive functions, pointers at functions, so that the child component, the component used in another component, can communicate back to its parent component, so to the component using it, and that you have this very important concept of state, which allows you to manage data that, when changed with one of the state updating functions, actually causes React to re-render the component and re-render the JSX code and re-evaluate what needs to be output on the screen. This is what allows you to render dynamic content with the help of React. These are all the important takeaways. And again, there is more we will learn and more you can learn about React in general, but these are the concepts which definitely should be clear by now.